Okay, welcome everybody. This is 3ds Max for architectural visualization at the intermediate level. This is a 18-hour class over 2 days, and as you can see, here's the agenda. And before I go over the agenda, I need to go over some ground rules. My name is Brian Smith. I am from CG School, and this class is sort of a different class than what we typically teach, in that we are currently here live in Miami at the Spline 3D studios, also the CG School studios, and we're broadcasting online. So there's several people in class here. There are several people online, and because of the unique nature of this class, because this class is being broadcast online and people live in class, we don't do the normal introductions because I'm wearing a headset right now, and what people say online can't be heard here in class except for myself, and what people here in class say can't be heard online. So when there is a question, I will repeat the question so that everybody can hear. When there's an answer, I'll repeat the answer. The way this class is going to be conducted is I'll be presenting the material as you can see here. You have online an interface where you can raise your hand to ask a question, and if you're live here in class, you can raise your hand. I'll address the question that you have. There is in your interface a chat window where you can type messages, but I won't see those messages pop up. If you have a question or if you want to raise your hand, please do so. Just raise your hand or ask a question. There's a place that you can type in a question. If you don't want to speak your question, or if you don't have a microphone, type in your question. I'll see that your hand is raised, or I'll see that you have a question, and I will address it. If you would like me to unmute your microphone, let me know. You can just say question microphone, or I would like to ask a question. That is an indication to me that you would like me to unmute your microphone. If you simply type your question, I will read the question for everybody, and I will provide the answer. And also, because everybody can't hear each other, we're not going to go over the same normal introductions. I'll just do a quick 30-second introduction for myself, or of myself, and then we'll move straight into the agenda for these 2 days. Again, my name is Brian Smith. I've been doing 3D since the mid-90s. I got started in 2D back in the early 90s in school. Got started in 3D in the mid-90s using 3ds Studio, or 3D Studio DOS version 4. And back in those days, things were a lot more difficult. The hardware was a lot more expensive, and making a living was not really as easy as it is today. You know, workstations back then cost about $100,000, a good SGI workstation. So it was hard to make things work back then, but things are a little more simple now, thankfully. And I was an architectural draftsman for about 5 years, and a lot of what I'm going to be teaching in this class is going to be shown at times through the perspective of a draftsman. And after working as a draftsman, I started working in several different 3D companies, a landscape company, a pure 3D company, and I teach now. I've been teaching since about 2002. And I believe what I teach is practical because I do production as well, and I work with a lot of pretty big studios around the world doing 3D. And I don't teach anything that I don't put into practice, or anything that I wouldn't do myself. So I really think the things that I teach have been tried and tested. And I think if you use some of these techniques, they will work well for you in a production environment. So with that being said, let's go ahead and look at today's agenda. Day one today, we will be talking about scene preparation. We will learn about how to work with AutoCAD drawings and bring in line work into Max. 2D modeling, which can be called spline modeling, or using the Edit Spline modifier, is, in my opinion, one of the most important areas in 3D. It is the foundation of 3D. If you have good, clean line work, it usually translates to good, clean modeling. So we'll spend the first couple hours working in AutoCAD drawings, cleaning up the AutoCAD drawings, preparing that line work, importing that line work, and showing you how to use that line work to create some some 3D geometry. We'll look at how to create walls, windows, doors, roofs, all those different objects that are so important to a visualization. At 1400 or 2 p.m. local time here, we will look at furniture modeling, and what we are going to do is I'm going to pass the microphone over to somebody else, a gentleman by the name of Alexander Gormanov, who is probably one of the best furniture modelers or poly modelers that you will find anywhere. He is incredibly good, incredibly fast, and you will learn a lot from him, and you'll be amazed at what he can do. So he is in a different city, and I'm going to make him the presenter at 2 p.m., and he's going to be talking for about an hour. And after that, we will move into site elements. We will work on 2D sites and 3D sites and see what the differences are between each. We'll start creating some vegetation, both 2D and 3D vegetation, and then see how we can create backgrounds in our scenes. Day 2, we'll look at how do we actually finish a scene, specifically advanced material creation and the Unwrapped UVW. Anyone that's ever struggled with creating good maps or placing those maps on objects will probably have something. We'll probably learn a lot from this Unwrapped UVW. If you haven't tried it yet, I think you'll find it's a very interesting subject, and it will just add a lot of power to your workflow. We'll talk about cameras and animations. We'll look at advanced lighting techniques. We're not going to be covering mental ray or V-ray, but I'm going to show you a bunch of different scenes, analyze how those scenes can be created, and show you some basic concepts for working in scenes with global illumination. We'll look at how to animate certain architectural elements, everything from water fountains to pools to flags blowing in the wind to cars moving down the road. The differences between a static scene and a dynamic scene where either just the camera is moving or objects in your scene are moving. We'll look at how to control those animations specifically through the curve editor, and then we'll move into efficient workflow. We'll look at, there's an hour class, probably my favorite class to teach, is this class entitled System Resource Management. And this is probably going to be the most, this class will probably blow your mind in some cases, because sometimes students are amazed at what they don't know about what's going on behind the scenes, what's going on with the computer and the RAM and the processors. So hopefully you'll learn something there. And then we'll talk about render elements and power modifiers. There's a lot of different render elements that you should use, and if you're not working with, if you're not doing post-production, if you're not doing compositing or at least Photoshop for still renderings, then you'll probably want to take a look at this and you'll have something to learn there. We'll look at some really nice modifiers, some modifiers that can really add some efficiency to your workflow. In the last hour, we'll talk about production tips and tricks. So with that, does anybody have any questions about the format of the class or how class will be conducted? If you do, if you're online, simply raise your hand. I'll see your hand is raised, and I will address your question. If not, we will go ahead and get started with scene preparation. So everybody here in class, you should have AutoCAD on your screen. If you don't have AutoCAD, it's not a problem. You can sit back and relax and just watch. If you want to follow along, feel free. This class is going to be somewhat fast because it is an intermediate class. It assumes a certain level of knowledge. It assumes that you know the basics about 3D. It assumes that you've worked a little bit with AutoCAD drawings. So it's not going to be a class where I hold your hand and say, okay, do this, do this, do this. I'm going to be demonstrating a lot of things, and as I demonstrate, I will be talking the entire time and explaining what I do. Whether or not you want to follow along or just watch, that's completely up to you. And some people like to try to keep up. If you are trying to keep up, if you're trying to do the exercises and you would like to have me slow down, please do not hesitate to raise your hand and just ask me to repeat something or ask me to slow down. I have absolutely no problem doing it. We have plenty of time to go over everything we need to go over, and we budgeted in a certain amount of time for questions and answers. And this class is going to be better the more questions you guys have, because if you have a question about something, chances are somebody else has a question about something. Okay, let's go ahead and start looking at some drawings. If you would, if you want to follow along, there's a folder. If you haven't downloaded the files yet, you might want to start downloading the files. Everybody should have received an email yesterday. There were about 12 folders that were provided to you guys. They're in 3 separate folders. So there's 12 folders within 3 folders: 3ds Max 01, 3ds Max 02, 3ds Max 03. And in the first few hours, we're probably going to be concentrating just on the first folder, 3ds Max 01. And it is all in that first download link that you were provided. So if you want to follow along, at least download the first set of files that were provided in that link. The file that we're going to be working on first is the Pines. So if you would open up the file called the Pines 01, it's in the 02 Preparing Line Work folder. And again, this is an AutoCAD file, so if you don't have AutoCAD, you can simply watch. If you want to follow along, that's fine. So here is what I would call a dirty site plan. This site plan has a lot of information that you simply do not need to create your 3D models, whether it's the building or a site. This is a retirement home. This is an adult living facility. It is about it's a development that has, this particular drawing has a lot of layers, a lot of information that we simply don't need for our architectural elements. So when you're presented with a set of drawings like this, you may have everything consolidated into one folder. You may have instead of this, you may have a project in which you have to consolidate all your objects or all your drawings into one folder. So this is one way you can receive your drawings. If you receive your drawings piecemeal and you have all your drawings, all the information you need in multiple drawings, what I suggest is importing or copy-pasting all the line work from all the different files into one file. And then you can start doing the same thing to all the files at once. The process that we're going to use here is a cleaning process, and if you don't import all your drawings into one drawing, if you don't get all your line work into one drawing, then the process has to be done multiple times. So by bringing everything in, what I'm about to do, we can do all at once. There is, before I go any farther here in AutoCAD, this is not a class in AutoCAD, but there are a few certain things that I think everybody should know about AutoCAD, whether you use it to produce architectural drawings or construction drawings. Regardless, there are a few basic things that you should know if you're not already doing it. I want to type config and go to the configuration menu. It's actually called the options menu now. And in the display tab, one of the first things you should change is this crosshair value. By default, it's set to 5, and if you set it to 100, then the crosshairs that you see on your screen that I'm moving around allow you to project lines from one side of the screen to the other. And so when you start orienting and aligning your drawings, it's very helpful to see if things line up properly using that cursor. Next, under the Open and Save tab, there is an option to automatically save every so many minutes. That is a good option to play around with. There are, under the Drafting and Selection tabs, under the Drafting and Selection tabs, the ability to change the pick box size, grip size, aperture size, auto snap marker size, and so on. Probably most important is underneath the main set of menus at the top, you see this Command Alias section, which allows you to change the Autocad Pgp files. There's a file called Autocad Pgp, and it's stored somewhere in your Documents and Settings folder, somewhere on your computer, that has all these shortcuts set up. And there's hundreds of different commands here, but in reality there is only about 30 that you need to do most of your work in AutoCAD. I have 30 commands that I typically use to do everything I need, and if you want to change your file and load a particular AutoCAD Pgp file up, and it's just simply a text file, you can go to File, Open, and find that file, that Pgp file that has a list of shortcuts. And that file is nothing more than a text file that has the shortcuts and the commands that those shortcuts represent. So it will look like this inside AutoCAD. Or you can change everything right here. But the point is, it's good to set up some quick shortcuts, so instead of typing out 5 or 6 letters to implement a command, a quick 1-letter or 2-letter keystroke on your keyboard can execute a command. So this is one type of project where all the line work is provided for you in one particular file. And I want to close this out and go into a different one. And the one I'm going to go into now is under a folder called 03-walls. 03-walls. In this folder, you will find a lot of subfolders. And the one that I want to go into is Building A-4 Story House. Building A-4 Story House. And here we find a folder with several files and a folder called Originals. And this folder called Originals is the original set of drawings that was provided by the architect. This is the original files that were received by the architect, and as you can see, there's a site plan, a first floor plumbing plan, electrical plan, all these different drawings, most of which reference these base drawings that are where the actual floor plans are located and referenced into other drawings. So as an example, if I go into the base 1 drawing, I can actually take this drawing, I can simply copy paste all this information into a new file. And when I do this, I need to make sure that there's no hidden layers, so I would have to go into Layer Manager, turn all the layers on, or at least make sure all the layers are on, which they already are. But the idea is to pull all this information into one nice clean file to work with. So if you go up out of this folder and get to the point in which you see base 01, base 02, base 03, open the first file called base 01. This file contains the consolidated information from all of those original files that I was provided. And the only information that is placed in this one consolidated file are the floor plans, the elevations, and the section information. There is no site plan for this drawing. The very first thing that I would do after I start to consolidate drawings is find the origin. Unlike AutoCAD, Max has a certain level of accuracy, and that accuracy changes the farther away you are from the origin. If I go into Max just for a moment and look at the unit setup within Max, in the system unit setup, I can see that there is a certain level of accuracy. And this window allows me to change the scale, so I can set up what unit. I can set up what a unit represents. In this case, 1 unit equals 1 inch. But it also has this portion down here that lets me see what the accuracy of Max is. What it's telling you down here is that when an object is 1 unit away from the origin, it is this accurate. And if I drag this slider over to the right, I can see it written in a different way. I can see that when an object is 16 million units away from the origin, the closest you can have in terms of accuracy, the best accuracy you can have, is 1 unit. And that simply means if you were to draw an object 16 million units away from the origin, the best accuracy that you can have is 1 inch. So instead of being able to draw an object that is, or a wall that is 8.5 inches wide or 9.2 9.2 inches wide or something, the best you can do is 8 inches, 9 inches, 10 inches, and anything that you try to draw that far out will give you some very erratic results. You'll literally try to move a vertex, and instead of being released where you release the mouse button, it'll seem to snap to some other point. It's not as accurate as AutoCAD. In AutoCAD, you can start working and creating objects way out in no man's land. It doesn't matter how far away from the origin you are. And when you work with especially civil engineering drawings where they build line work a great distance away from the origin because of the many different reasons, one of which is the coordinates they build into their AutoCAD drawings, where they're trying to use, in some cases, real-world coordinates, and they start building line work millions and millions of units away from the origin. If you import that line work into Max without respecting the origin, you're going to you're not going to get good results. And with civil engineering drawings, when you start to, if you scale those drawings up to make the scale in the civil engineering drawing match the architectural drawings, things become even worse. So if you're already way far away from the origin and you need to scale up the site because the site is written in feet and your architectural drawings are written in inches, if you execute the scale command inside AutoCAD and scale everything from a place that is already far away from the origin, when you scale that drawing up 12 times, you might push that set of line work 12 times even farther away. So things can get out of control pretty quickly if you don't respect the origin. So what I always do is I start by placing all of my drawings around the origin. So I need to find the origin. If I were to just type in line 0 dash or 0, 0, if I type in 0, 0, I can see a line drawn from the origin, and that tells me that that is where I need to put my AutoCAD line work. That's where I need to center all of my line work. So I will simply take the first floor plan of this building and I will put it somewhere near the origin. And then I will line my other drawings up. I will find some similar point on one floor, try to match it on the first floor, and then I will execute the move previous command, which simply allows me to move the previous objects that I had selected. If I type in move and then type in P for previous right there, I can move the previous objects that I had selected. And then I can line up the next floor, and all I'm trying to do is get it all in the same line. And then I do the move previous command again, and so on. Next, I need to orient the elevations around this first floor plan, because floor plans don't do me any good if I can't see what the elevations look like. So I will find the front view, figure out where to locate that, and I'm going to use on the elevation a point that I know is going to be the load-bearing wall. In this particular elevation, we see some trim features outside the wall. These trim features usually are not shown in architectural drawings. Some architects like to show trim as a light line outside their load-bearing wall and make their load-bearing wall, which in the U.S. is usually 8 inches wide. Sometimes they like to have both the load-bearing wall and the trim, but in most cases, most floor plans are going to only show the load-bearing wall and not the trim. So if I'm trying to align this wall properly, I'm going to pick the load-bearing portion of the wall here and not a trim feature out here. So if I click somewhere over here to drag this building over, and if I place it in such a way that the line that I grabbed is placed somewhere on the top of that same line as it's projected on the floor plan, I can place the elevation right on top of the floor plan, execute the move previous. So I simply type M, enter, P, enter, move it down, and I can start drawing some lines from the floor plan downward to see if the drawings the floor plans match the elevations. If I zoom in really close, I see that that line projected from the floor plan comes down, lines up with the load-bearing portion of this wall. If I go over to the other side of the building, I see the same thing there. I see the line that I projected down matches with the line of the load-bearing wall in this elevation. And I need to make some space over here for the elevation on the other side. So I'd place another elevation over here. I'd place the rear elevation over here, which would have to be flipped because the elevation as I see it in the AutoCAD drawings or the architectural drawings are showing me what I look like if I'm standing in the backyard here, but in reality when I'm looking at the floor plan I would see a mirrored version of it. So I come over here, I start to line things up, and I see that this set of doors here does not match the doors over here because this is what I would see if I am standing in the backyard here looking down towards my floor plan. So to project things properly, I need to do a mirrored version of this. So I need to do a simple mirror. Oops, let me undo that. Mirror all of this. And re-project this. Make it line up. So now the door right here matches the door here. When I'm done moving all of this line work around, if I open up another file called base02, I can see what the result of cleaning and orienting all this line work is. I can see the result of cleaning and orienting the line work. All the line work is positioned around the first floor plan. I have the second, third, fourth, and roof plan off to the side. I have the left side and right side elevations lined up, ready to match the floor plan. Everything would line up. And I also have, notice that they are rotated, but I have a non-rotated version here just for reference. Okay. Notice that it's clean also. The process that I use to clean these drawings is really quite simple and streamlined. I'm going to go back into this drawing just for a moment and show you how I clean these drawings. So if I were to type isolate and then select a layer like the dimensions, I can see that actually I need to type in the word lay ISO. Lay ISO is layer isolate, not isolate an object. Lay isolate allows me to alrighty, lay ISO. Yep. Yeah, I guess the new version of AutoCAD does not actually erase the layers that are isolated or layers that aren't isolated. All I'm trying to do is isolate one layer, so I only select those objects that are on that layer that I'm trying to isolate. So if I were to do a window selection around this and delete all this line work after making sure that I don't need it, just the line work on the layer that I isolated is actually showing up. I type in lay on to turn all the layers back on. Select another layer, lay ISO. I must say I don't think I like this version of AutoCAD. This is the first time I've actually worked in AutoCAD 2011. But the idea is to select and isolate one layer at a time, delete that layer once you determine that you don't need it, and keep going one layer at a time. And the final end result is that you are in a drawing that looks like what you saw a moment ago. This drawing right here. So once the line work is clean, oriented, and positioned properly, you can start building some of your line work. You can start building the lines that you need to create the walls, windows, doors, and etc. and as I mentioned before, good 3D models start with efficient 2D line work. Now, if you work in Revit, if you have to produce construction drawings, then the process that I'm showing right now may not be as valuable. However, even if you use Revit to build drawings or to create drawings for buildings, you will still need to use this process, or you should still use this process for sites. It's the exact same process for sites, where you clean up your drawings, get all the information, just the information that you need, and start creating what I'm going to do now, which is paths and profiles to loft certain objects. What I'm going to do now is start building some line work to create some walls and windows and doors, but you can also do the same process with site plans to, for example, loft curbs around a site. And the process is still the same. You've got to create some good clean line work, create a path, create a profile, use the loft feature, and use some other compound objects that will look inside Max. So my goal right now is to start to create some line work that I can use to import inside Max. If I open up the layer manager right now, you'll see a lot of different layers. And I don't want to just create a bunch of layers that are mixed in with all of these layers. But I want some new layers so that I can isolate just those layers and bring them into Max. So I'm always going to start making new layers. I'm going to create my new layers and place those objects on those layers. Place that line work that I create on those new layers. I'm going to create a new layer, and if I click on this icon for new layer, it allows me to give this a name. I always name my layers with a prefix 0- because that allows me to see all the layers at the top of the layer manager instead of having it being mixed up between all the layers that exist already. So I want to type in layers. I'm going to type in 0- wall -path 01. And this is going to be the first layer that represents the first path that I create that I'm going to use and import inside Max. So I create a layer name and I create a color, and I want to create a color that shows up well inside Max. Let's use a color that looks like purple, so I'll select purple and hit OK. And I'll create a few more. 0- wall path 02. Give it a color, light blue, and we'll leave it at that. Now I want to create the line work that I create. I want it to be on this path, so I can double click that layer and make it current. So anything I draw now is on that layer. Point is, you want to create a layer, make it current, and start drawing some things on that layer. So I start to look at the elevations and try to figure out what this building looks like. And a lot of people like to use the Edit Poly procedure or the Edit Poly method, the box modeling method, to build buildings. And that method is simply using a bunch of lines that represent the walls, extruding those walls, using the Edit Poly command to build some trim features into the walls, and that's fine. If that's the approach you want to take, that's fine. There are some merits to it. I don't believe it's anywhere near as powerful or as fast as using the Loft method that I'm going to show here. The Loft method requires you to have a path and a profile. So what I'm trying to create right now is a path on the floor plans, and then create a profile from the elevations, and then loft a profile along that path. So I'm looking at this and I'm trying to decide where are all the unique different wall types, because I have to have a different wall profile for each wall type. I can have a loft created anywhere that I have a unique wall type. So in this case, this wall is a curved wall that holds the staircase, and I can see that the wall changes when it gets to this point right here. So the wall is only unique in this area and this area here. So it's confined to basically just a circle. So I need to have a path that is represented by just this circle. So I will draw an arc from one point of the wall to the other. Actually, the way you draw arcs in AutoCAD is slightly different than the way you draw arcs inside Max. But the result is just the same. So I want to pick the start point, the midpoint, and the end point. And once I'm done, I'm left with the file or the line that looks like this right here, the purple line. That's the line that I had just created. And that line is sitting right on top of the existing line. And I like to trace the line work here because I don't like working with just the line work that was created by somebody else. I want to make sure that it is created properly. And I want the endpoints to match up perfectly. I don't want any endpoints to overlap. I don't want to have any gaps. I want to have good, clean line work. And I should probably also check to make sure that this is in fact two-dimensional. A lot of times a drawing can look two-dimensional, but it is in fact 3D in many cases because of things like this door, which is a three-dimensional door created by some other program like Desktop or Revit, and you could have all the line work in your file be two-dimensional, and then one object like this that you snap to create some line work, and then all of a sudden your lines are at different elevations and they don't work properly inside Max. So if I check this from a front view, I can type vPoint 0, 1, 0 and see this drawing from a different perspective. I'm looking at this from a horizontal perspective, and in fact I see a lot of different line work at different elevations. And if I were to just go through and select and delete all of this line work that's at a different elevation, that would give me an indication of all the line work that was sitting on an elevation that is not 0, not the home grid. So I could erase all this, go back to viewpoint 0, 0, 1, which represents an overhead view, and I have a better chance of not snapping to some line work that is not at an elevation of 0. So I go through this process of analyzing each wall one at a time and trying to figure out where one wall type starts and where another one ends. Did you have a question? Okay. So looking at this wall here, I can see that this wall, as shown on the elevation here and shown on the elevation here, as well as the one over here, exist. If I project this line over, it seems to start, looks like it starts right here, goes over, and then up to this point right there. So I could draw a line, a polyline, which is different than a regular line. I can draw a polyline or a P-line from that point there to that point there to that point there. And I would need to put this on a unique layer. I would need to put that line on a unique layer. So I would either need to change the layer right now or activate the new layer and draw it on that new layer. So that's the process, going through, creating those paths. And once those paths are done, I need to then create the profiles that I can use to Loft. And this is all done and it's shown in another file, but I want to create one profile as an example, and I want to select the line work in one of these elevations right here, and what I'll do is I'll make a copy of this line work and then place it off to the side, and then I'll use this line work to quickly clean up the line work that I'll use it to quickly create a shape that I can use to Loft. And what I'm doing is I'm just simply erasing the line work that I don't need. And I have to be careful not to erase too much, But I know this wall is going to be about 8 inches, and I can see that from the sections. But even if I don't know it's 8 inches, it really doesn't matter whether it's 6 inches, 7 inches, 8 inches. Chances are it's something close. But even if I don't know, I just need to give it some reasonable thickness. I'm only going to see this from the outside, but even if I see this from the inside, an inch or two difference is not going to make a difference. It doesn't have to be that accurate. I want to offset this line by typing the word offset, giving it a distance of 8 inches. And again, oops, that wasn't right. This class is not a class on AutoCAD. I am just showing the process using AutoCAD so you can see how I clean up line work. All right, so I type offset, type in 8, enter, click on one line, and then click to the opposite side. So I've just created an offset 8 inches apart from my previous line. Then I can fillet the blue line and the red lines to create a corner using the spacebar to reactivate the command very quickly. And I'm just going through this process of trimming and cutting, trimming and cutting. Oops. In order to quickly create a profile that I can use inside Max. I would actually go right up to the fascia in some cases, or in other times I would simply go up to where the bottom of the fascia is. If I look at this particular roof, notice that this roof is circular. So I could actually have the shape include the fascia of this building. Sometimes I don't. Sometimes I need to have a separate shape and path just for the roof. But here I can actually have the shape of the wall combined with the shape of the fascia. When all this is done, I can go into base 03 and see what the final cleaned, oriented, and prepared line work looks like. I have underneath this first floor plan some lines that you simply can't see right now, but if I go into the layer managers and if I go into layer, oops, let's do it one more time. If I go into layer manager and hide everything, turn off everything except these lines that I created myself, 0-boolean, or boo for short, 0-frame, 0-glass, pass 2, 3, 4, all these different trim features. If I turn just those back on, I can see the line work that I created to create the paths that I need to loft inside Max. So this is the line work for the paths sitting on top of the floor plan that I need to bring inside Max. And this over here is the line work that I need to, the profiles that I need to loft along those paths. These are closed splines that were created from the elevations. And these lines down here are what I call helper objects. They are on a separate layer, and once I bring this inside Max, you will see what the purpose of these lines are for. But they are to set the pivot point, and they aid in the process of setting the pivot point. But all I need to bring inside Max right now is this line work. The line work for the paths, the line work for the profiles. And with just this line work, I can, in literally just minutes, create all the walls that I need for this particular building. The hardest part is, in many cases, just figuring out what the building looks like and where you need unique individual lofts created. So everywhere you see a different line, which is set to a different color, every one of these is a unique wall or a unique loft that I need to create. Off on the side here, you see one copy of every door and window that was needed for this project. This particular house has a lot of different door types and window types. And the process that I use to create these door and window types is make one copy of each, line them up, and then start building the line work either inside AutoCAD or inside Max. I can create the line work here, or I can import this line work into Max and then trace this line work inside Max. I can either trace the line work or I can use the line work that already exists. But the idea or the goal is to create a set of line work for the trim, for the glass, for the frame, for all these unique individual elements of the wall, of the windows and doors. And I want to do it all at once. I don't want to create one window, bring it inside Max, then go back to AutoCAD, work on the next window, and so on. I want to line these things up and create it like an assembly line. So it speeds things up whenever you can create objects of a similar type all at once. If I look very carefully at what I did here, I see all the line work is already created and it's ready to bring inside Max. If I put my cursor over this, you can see the name of the layer. It's called 0-trim. Put my cursor over this, 0-glass. This one is called 0-frame, and so on. So I can bring in this line work inside Max, and I can very quickly and easily do some extrusions, do some edit poly commands, and very quickly create all this line work, create all these windows. And this line work was simply was copied, or this line work was traced. The original windows and doors were traced, and this line work was created. Whether you trace the line work or try to use the existing line work, that's totally up to you, but the line work that you bring inside Max has to be good and clean. So for example, this line, it needs to be closed. It needs to not have any lines overlapping, no gaps, because when you bring it inside Max and start doing things like extrusions, any holes, any gaps, any lines that crisscross each other simply will create some models that won't work. So the line work that I want to import is all this right here. And to create, I want to create a new file that has this line work in the exact same location. I don't want to just do a copy-paste, paste it into another drawing, and bring in that line work without some common reference point. All the line work that I bring in, or whatever I bring in, whether it's line work or if you bring in some 3D models from some Revit or desktop program, all the line work that I bring in needs to have the same base point, the same common reference point. So what I will do is I will select all this line work and I will type W block for the command, W block for a write block. I'm writing a block to my hard drive. I have the objects already selected. I have my pivot point or my pick point set to the origin, which is what I want, and I want to create this file on my desktop here. And if I want units, I can set up the units, but this is unitless and that's fine. I can select OK. It says no objects have been selected. And let's see here. W block, I have to select the objects first. Type in W block. Hit OK. It just created my drawing on my desktop right here. So this file called new block now has just the line work that you saw isolated a moment ago, and I can bring this line work into Max and start building some objects. But the line work that I bring inside Max has to be good, it has to be clean, and if it is, you can really start to knock out your architectural elements very quickly. Does anybody have any questions so far as to the process that I'm using to do this? So there's a few steps you have to do. You have to consolidate your drawings. You have to position your drawings on the origin. You have to clean your drawings, isolate layers one at a time, figure out what you don't need, delete those layers, and then you should orient those layers, the elevations on the floor plan. And once you do that, you can start importing this line work into Max, which is what I'm going to do now. If I go into Max, I see under the File menu that there is a feature called Import, and this import has several different file types that you can import. There are numerous different file types here, but there's only two file types that are related to AutoCAD. You have an AutoCAD DWG and a legacy AutoCAD format. The AutoCAD DWG is not the file type that you should be using, and I'm going to show you why. If I select AutoCAD DWG and then select the file that I just created, the new block DWG file, if I use this method to import, I'm going to run into some problems. First thing that I notice is it has a Layers tab, which allows me to import specific layers. And because of this, I could literally import the entire drawing that I see right here. I could import this entire drawing into Max, or I should say I could select that drawing to import and then just isolate the layers that I want. I could literally do that, but the problem is it will mess up a lot of lines. So I just want to show you what I'm talking about. So if I were to go to Import and select the file that I want and use the AutoCAD DWG file type, not the legacy AutoCAD, but the AutoCAD DWG file type, actually instead of using the new block, I want to show you how you can isolate layers. I want to go into the 3ds Max 01 folder, 03-walls, and find that same file that we were just cleaning up a moment ago. I want to look at the base 03 file. So I can bring this file in, and with layers I can isolate the specific layers that I want. So I can turn off all the ones that I don't want. So I can select just these layers and bring these layers in. And that's nice. It's nice to be able to say I want to import just these layers. The problem is a lot of the curves that you bring in will not be created properly, and there's a reason why. I'll show you in just a minute. If I leave everything else alone and just hit OK, I see that this line work is brought in. Now this line work was all brought in as part of the same layer. I can change that. I can make all the unique layers allow me to bring in line work separately. But that's not what I'm trying to focus on right now. If I zoom in nice and closely to this path, or I'm sorry, this profile over here on the left-hand side, if I zoom in nice and closely, I'll see what one of the problems is with this particular file type that I imported. If I go back to the AutoCAD file and look at the same curve in the AutoCAD drawing as I imported here, notice that the AutoCAD file shows a nice round semicircle, but this circle is not created properly. It's not produced properly. Has anybody experienced that before, importing line work with AutoCAD DWG files? It is a particular problem that I consider a bug, and what is actually happening is if you go into sub-object mode, if you look at each vertex, you see that one vertex imported as a Bezier corner, and I can see that by right-clicking on top of that vertex. It says Bezier corner. But the other vertex translated as a corner instead of a Bezier corner. I could change it to a Bezier corner and make that curve go back to where it should be, but that's too much work. I don't want to do that because I would have to do that to many different parts of this drawing, and there's no telling when and where it's going to happen, but it happens too often, like here again, it happens too often to clean up. It's simply not productive to go through this process, figure out everywhere in your files that lines or arcs got messed up. Here's another one. This particular line should be up here with the rest of the lines. For some reason, the vertex sitting right here was turned into a corner vertex. So this format type while great because you can isolate layers and bring in specific layers, is not practical because it causes too many of your curves to disappear. So instead of using this import method, you should always use the legacy AutoCAD file type to import. So I'm going to reset this and import the proper way. So I select import, and the file type I want is legacy AutoCAD DWG. Legacy AutoCAD DWG. And the file that I'm going to import is the one that I created and placed on my desktop. It's called new block. It asks me if I want to merge objects with the current scene. Select OK. Now here's a much less complicated looking dialog box for importing. You have the ability to derive objects by layer, color, or entity. That simply means that all the objects on the same layer can be made to be placed on the same object. All the objects that have the same color can be made to be placed on the same object, and all the same object types, like all the circles, all the lines, all the arcs, can be made to be part of the same object. And they are made part of the same object if you decide to convert to single objects. If you have this option enabled, all of the line work on the same layer will be part of the same object. If not, then there will be a unique object for each unique line, and they will be shown with the same color that the layers are showing inside AutoCAD. The only option you ever need to change is this option here, convert to single objects. The very first time you use this import method, you will have to disable group common objects. This is on by default, and there's no reason why you need to group common objects. You don't want to create groups of line work that you import. So the first time you will have to disable this. But every other time, the only one that you will ever have to change is this setting right here. And notice that there is a weld option. Even though there is a weld option, and that weld option is set to 0.1, you should never rely on this option. For whatever reason, the weld option in this method, in this AutoCAD file type, as well as all the other file types, simply is not reliable. In other words, you can expect that a drawing of any size, like the one that I'm importing right now, will always have weld endpoints that don't weld. Those endpoints could be on the exact same spot. They can occupy the exact same point, and they will still not weld. And because of that, you have to weld manually, which I'll do in just a moment. So in this particular file, there's no reason for me to convert objects or convert all the line work on the same layer to single objects. There's no reason why I would want to have all of these lines on the same layer, or I'm sorry, all these lines which are on the same layer, part of the same object. I have line work right here. This is all on the same layer, but the line work that I saw hidden underneath the floor plan, the layers that I created, paths, path 2, path 3, they are all on a separate layer, and each of those layers are a different color. Why? Because I want to have those objects created with a different color so I can see where one starts and where one ends. And I want to see where the line work starts and ends. And if I made everything part of the same layer or the same color, I wouldn't see where one wall ends, where another wall begins. So regardless, I get to this point, turn off, convert to single objects, and select OK. Now, I am in perspective view, and if I want to zoom into this area, I should probably start using user view or orthographic view. And just in case, I know you guys should have some fundamental level of knowledge of Macs, and I don't want to insult your intelligence, but just to make sure that you have a particular customization setting set up, I just want to show this to you. Under the Customize menu, under Preferences, you should have a setting enabled all the time, and by default it's not enabled. It is under the Viewports tab, and it is the Zoom About Mouse Point, Orthographic, and Perspective. And it's surprising when I see how many people don't have that option enabled. What that simply means is wherever my mouse is, that's where I'm going to zoom in. If I switch to user view, which I should be doing right now, because rotating, panning around, zooming in and out with perspective view is not usually very easy to do. If I put my mouse over one of these areas and I want to zoom into that place, all I got to do is scroll with my middle mouse button. If I didn't have those options enabled, it would always zoom in to the center of my viewport, which I don't want. If I want to zoom into an area down here, put my cursor over there, I just scroll and it zooms in right there. Let's turn off the home grid because we don't need to see this home grid. So we simply want to create lofts using the line work that we see here, which includes the paths and the profiles. The paths and the profiles. All right. Before we start doing any wall creation, let's back up and take a step back and start looking at some important things about 2D modeling. We're going to come back to this point. We're going to come back to creating walls in a moment, in a little bit, but I want to show you proper 2D modeling. I want to show you how to actually work with your lines or splines. So if you haven't followed along up to this point, that's fine, because I haven't really started to build anything. I'm just showing you the approach that you should use. Now, if you want to follow along, this would be a good point to do it, because now we're going to start working on some line work that we create from scratch. Okay, if you would, please create a circle somewhere in your perspective view. When you create a circle, notice that there are four vertices that you can see. You can see 4 vertices here. But as soon as you let go, those vertices disappear. And if you want to see those vertices, which you really should for this next exercise, you should go to the display panel and turn on Vertex Ticks. That allows you to see the Vertex Ticks or the vertices of the line that you're creating or the line that you have selected. Okay? And I want to switch to top view so that I can see this a little bit easier. So I have a circle, and I want to see what I can do with this. The circle is a shape. A shape is not the same thing as a spline. Under the Create Shapes panel, I see lines, circles, arcs, n-gons, rectangles. All of these are shapes. They allow me to build something very quickly. It's a parametric object that allows me to build splines in a certain configuration. For example, text. If I draw text, I can have that text say something specific. For example, I could type my name out. And creating line work like this would be a lot more difficult if I didn't have this shape to help me along. I can't really do much with a shape. I have to turn it into a spline. So if I have a circle, I need to turn it into a spline. And the 2 ways to do that is adding the Edit Spline modifier or converting to Editable Spline. So I can add the Edit Spline modifier here and make sure you have the shortcut set up using the configure modifier sets icon. So make sure you have shortcuts set up here to access modifiers that you use on a regular basis. I can also collapse to Editable Spline. If I collapse to an Editable Spline, I now have access to all the sub-object levels: vertex, segment, spline. Okay. Now, as I said before, there are 4 vertices, but how can I see this shape defined as a curve if there are only 4 vertices? What is allowing me to see this curvature properly? So I want to, at this point, from this point on, I want to start asking some questions. And I want to address both people in person and online and start asking some questions. When I ask a question, the people online won't be able to hear the people in class and vice versa, so I will have to repeat the answer. But I want to make this interactive, and I want to start asking questions and start picking your brains and see how much you know about this, how much you're retaining. So can somebody, whether it's somebody here in class or somebody online, if you want to type in your question or type in your answer, I'm sorry, can somebody tell me why I am seeing a curve when I only have 4 vertices. What allows me to see this curve properly? Since it's a spline curve, it works on a Bezier. Yes, that's true. Okay, if I select a vertex, I can see these. I can see each vertex is a Bezier, and I can select these handles and move them around and change the shape. And that's true. There's some sort of algorithm that derives this shape, so I can with 4 vertices create the shape of a circle using this Bezier function. That is true, but there's another component to this that allows me to see this curve smoothly. That defines the shape that it wants to be. So the Bezier tells Max to display this as a curve, but there's one other component that's missing. I know you know the answer, Novell. Interpolation. Right here, this rollout interpolation signifies or specifies how many steps to have between all these vertices. If I right-click, which takes my sliders to the lowest possible value, which is 0, if I right-click, I can see I can turn that circle into a square or rectangle. So I've just removed all the steps that were previously allowing the Bezier to allow that Bezier curve to be displayed. The curve wants to be displayed. It wants to be in there, but we're taking all of these steps away so it can't display it. If I add a step, you can see that the curve starts to come back. I add another step, it comes back more. And by default, we have an option set to 6. And in some cases, that's fine. That's enough. But the point is, when you start working with line work, whether you're building walls, windows, doors, site plans, whenever you're taking line work from AutoCAD and bringing it into Max, or whenever you build line work inside Max and use it to create 3D models, you have to put some thought into how many vertices should I see on each one of these curves. If it's a straight line segment, you don't need to see anything. If I just had a rectangle, you don't need to add any steps. You don't need to add any vertices because there's no curvature to display. But if I want to have part of this circle have one set of steps and another part of the circle have another set of steps, I need to specify that here. You should never simply just leave the steps option on or leave the steps set to some arbitrary value and use the extrude command or whatever type of command you're going to use to create your mesh. If I hit extrude here, I see all the vertices that were added by way of the steps. I can extrude this, turn on faceted mode, and see all those additional steps that were created. And that's fine, but you should never just arbitrarily set this value to something or let Max determine that for you. If I go to the Edit Spline and increase the interpolation to something like 20 and go back to the Extrude modifier, I will see all those extra steps added. But if I go back to the circle and enter, if I go back to the circle, change the steps back to 1, I can manually specify by selecting an individual segment, I can manually specify how many vertices to place in that segment. The best way to do this, the best way to specify how many segments or how many steps or how many vertices, whatever you want to call it, best way to tell Max how many you want is by selecting the segment that you want and dividing it. If I just click the divide button, it's going to divide the current segment into 2 segments. If you have 2 segments, it divides it into 4, and it simply adds 1 division along every segment. And so you can use this method by clicking divide over and over again, make your circle as divided as you want, add as many steps as you want. I can also just specify an amount by typing in 10 next to divide and clicking the divide button. And by doing that, I can add a specific number of steps. And the reason why you would want to do this is when you're working on objects, sometimes you'll have very sharp curves, sometimes you'll have very gradual curves. Sometimes those curves will be very small and occur over a few inches. Sometimes they will occur over several feet. And depending on the distance from the objects, you need to put the proper amount of vertices or the proper amount of accuracy into your models. It would be pointless to put this many vertices in your shape or your spline when you can get away with this number of vertices. So some thought needs to be put into how close you're going to be to these objects and how much detail you're going to be able to see. But the point is, I now have a circle that looks like a teardrop because I specified exactly how many steps to put in this. I specified how many vertices to put in this. And now I can loft this shape, or I can use something like the sweep modifier to project the shape along a path. Or I could just do a simple extrusion and see the same thing. Let's reset this, or yeah, let's go ahead and reset. If I create a circle again and go to the Edit Spline modifier, add the Edit Spline modifier, notice that there is no interpolation within the Edit Spline modifier. The reason why is because it's stored in the circle. Anytime you create a shape, it's going to have an interpolation rollout, and that interpolation rollout will always be in the bottom part of your modifier stack. It'll always be on the lowest level. But as soon as I collapse to an editable spline, that interpolation will be bumped up into the Edit Spline modifier. I don't have an Edit Spline modifier, but it exists right here. If I were to add another Edit Spline modifier, notice that it doesn't have interpolation. But as soon as I collapse this again to an editable spline, there it is right there. Now, if I had a rectangle, if I drew a rectangle, let's turn off the home grid. I like to turn off the home grid just because it's a little bit of an eyesore. If I have a rectangle, I could turn this rectangle into some amount. I could have some amount of curvature applied to it. I go to the modifier stack. I see a rectangle. I see interpolation here. It says 6 steps, but when I extrude this, it doesn't actually give me 6 extra steps between each vertex. It doesn't because this optimize option is turned on. If I turn this off and look at this in faceted mode, I see that with the optimize turned off, there are extra steps added. You don't need extra steps in between straight line segments. So this option should be turned off all the time. I'm sorry, turned on all the time. It should be left turned on. If I were to go if I add an edit spline to the rectangle below the extrude but above the rectangle, I do that by selecting rectangle and selecting edit spline. You see that I've added the edit spline right in between the rectangle and the extrude. And I can now manipulate individual vertices to create this curvature, which when projected up to the extrude modifier suddenly throws in those extra steps because it assumes that I now need those extra steps. Okay. So one of the most fundamental things about working with splines is that you use this divide feature to add the steps or add the vertices manually and reduce the number of steps to 0. Take your number of steps to 0, and that will save a lot of heartache. Okay? Does anybody have any questions about anything I've covered up to this point? Okay, in a few minutes we're going to take a 10-minute break. We typically take a 10-minute break every 90 minutes, and any questions that you have during the break, please ask them. If you have any questions now, please type them into the question field. For example, somebody just asked, software algorithm creates the curved segments. That was a comment from before. Somebody typed in number of sides. Those were answers to comments. If you have comments, if you want to answer questions that I'm posting, please do so. If you would like to raise your hand and ask a question, please just raise your hand. All right, so let's continue on. Let's look a little bit closer at the Edit Spline modifier. If you are not intimately familiar with the Edit Spline modifier, I suggest becoming familiar because this is, again, the foundation of good 3D modeling. So in Vertex Subobject mode, we see some things that are not available in Segment Subobject mode and Spline Subobject mode and so on. In Vertex Subobject mode, we can manually add, we can manually refine segments or splines by adding vertices wherever we want. If I were to add curvature to some portion of this spline, I can improve that curvature by adding vertices after I've manipulated the Bezier handles. Okay, I can't, however, start deleting vertices, because when I do that, it starts to create a straight line segment between all those vertices. What I can do, however, is add the Normalized Spline modifier to remove the vertices that are there by default and replace them with vertices. I can't see them now because I need to turn on Vertex Ticks. I can see it replaced with vertices that are spaced a certain distance apart. And that certain distance is specified by the segment length. So by applying the Normalized Spline modifier, I can rearrange the vertices to a certain distance, and I can increase that distance or decrease that distance however I want. And this is very helpful for creating contour lines. If you would open a file under your 3ds Max 01 folder. Actually, I'm sorry, it's under 3ds Max 02. It's under a folder called 06-sites. And we're not really getting into sites at this point, but I'm just going to show an application for this Normalized Spline modifier that we'll look at a little bit later. It's under 3ds Max-02 06-sites. And the file I want is contour lines. If you open this up, you see that there are two objects. One represents the contour lines, and another represents a road that we are going to, later on in the day, cut out from this terrain and modify very precisely. But right now, all I'm concerned about is this 3D terrain. This terrain is comprised, it's not, I say it's terrain, it's actually simply contour lines that we will turn into terrain. But this object is made up of many different splines, and these splines were created in AutoCAD. And in AutoCAD, if you were to create a spline and bring that into Max, first thing you would notice is an enormous number of vertices created. If I go to Vertex Ticks right now, if I turn on the Vertex Ticks option, I see a lot of vertices making up these splines. A lot of vertices making up these splines. Now, if I were to add the Normalized Spline modifier right now, don't do it right now because you might do something bad. If I were to add the Normalized Spline modifier right now, I might bring the computer to its knees, because the last time I entered the Normalized Spline modifier, if I entered a distance that was too low and applied it to this object, it might crash Max. This object represents a quarter square mile of space. If I did a distance measure from one side of this object to the next, you would see that the length is 1,300 feet. That's a quarter of a mile long. And these vertices are spaced out probably a couple of feet apart from each other. When I add the Normalized Spline modifier, by default it defaults to a segment length of 20. If I divide these lines into vertices that are 20 units apart from each other, then I'm going to have a lot of additional vertices created. I want to add the Edit Spline modifier to this to normalize the splines and make the vertices more spread out. But before I do that here, I want to do it to a circle and make sure that the Normalized Spline modifier has a reasonable setting applied to it, because if it's set to 20 or something even lower, if I applied it like I did just a moment ago and reapply it to this terrain or this contour line object, then I could crash max. So I want to apply to a simple circle, and with Vertex Ticks turned on, I can see that these vertices are very tight, but applied to one little circle like this, it's no problem. So I can change it here. I can set it to something much higher. I can set it to something like 500, and it shows me the vertices, how far apart these vertices are. So when I apply to this larger object, it'll be a lot easier for this object to handle than if it was at the default 20 or whatever I last entered in. I can even copy it from this modifier to the next. I can right-click, select copy, right-click the Normalized Spline modifier, select the new object, and right-click inside the modifier stack and paste that Normalized Spline modifier, and then delete the circle that I created. So I just normalize this particular object. I just normalized the object and made fewer vertices. When we start building sites, we'll look at all the different ways to work with splines building sites. But I wanted to point out the Normalized Spline modifier at this point because it's very helpful working with lines, working with splines, either for sites or for walls, windows, doors, for building all the line work that you need to create your models from. Does anybody have any questions at this point about working with splines, creating, editing splines? Okay, let's go ahead and reset. Okay, let's go back to creating a few more different splines. Let's create a simple text. Create some text, and I want to change the color of this so it shows up a little bit better. So I'll leave this text as is. I have text, it's called max text. I have a lot of straight segments. I have some straight line segments, and I have some curves. So let's pretend that this is a site, and I want to adjust this. You have to determine how far away you're going to be from this object. If you're going to be really close to this object and see a lot of detail like this, then you need to build in more steps, more vertices than you would from this distance out here. So first thing you need to do is figure out how close you're going to be to your object and how much detail you need. Once you figure that out, you need to look at all the different curves and set up a reasonable number of steps for each one of these curves. So I need to turn on Vertex Ticks so I can see all these vertices that I'm creating, and I'm looking to figure out which are all the similar areas. What curves in here have similar lengths, similar angles, and I'm going to try to select similar or like parts of this object and divide those parts the same amount. So with Vertex Ticks turned on, I want to collapse this to an editable spline, and if you don't already use keyboard shortcuts, get into the habit of using keyboard shortcuts, because instead of having to come down here selecting a sub-object mode, which might not even be available because it might be up here, and my modifier stack might be so big that I might not have quick access to all these modifiers, I can just use the keyboard shortcuts 1, 2, 3, 4 to switch from vertex, segment, and spline sub-object mode. Do you have a question? Okay, Vertex Ticks is under the display panel, under the display properties of the display panel. You could also right-click, go to object properties, and see it here. Anything that you see in the display properties of, you don't see that panel? You got it? Okay. Any properties you see under display properties within an object properties dialog box, you will see that in the display panel. So you can change anything here or here. Okay? And you can probably even set up a shortcut for it. Set up a shortcut to execute these commands really quickly and easily. Okay, so here's another example. I'm in the display panel, right? I'm in the display panel, and I want to quickly go to vertex sub-object mode within this object. Instead of having to go up to the modify panel and then opening up this modifier or finding the selection sub-object modes down here, within the display panel, I can quickly press the keyboard shortcut 1, and I'm already there. I don't have to switch. I don't have to do anything. Or 2 for segment subobject mode, which is what I really want right now. So I want to pick all these segments and divide them up properly. If I go to the smallest segment that has some curvature, that would be this one right here. If I were to divide this segment 20 times or something like that, that would be a waste of time, because from any reasonable distance away, I'm not going to see the result of adding 20 steps. If I scroll down, go to the divide command, and type in 20, click on divide, I see way more steps than what I really need. Okay, I want to back off this and divide this reasonably. And until you have some sort of scale to your objects, and until we start working in sites where you can say this object represents this many feet, and I'm not going to be within 100 feet of this object. Until then, it's probably not easy to say that we need to divide this object a certain amount. But regardless, I'm just going to pick 6. I'm going to divide this 6 times, and from this, what I'm going to try to do with all my other objects or all my other segments is create the same kind of vertex density and angle. And what I mean by that is, what's really important in setting up these extra segments and dividing these segments is trying to figure out not the size of the segment, not the number of vertices that I need to add to get. I don't need to get necessarily the same spacing between vertices. What matters is the angle from one segment to another. So if one segment is very similar to another segment's angle, if the angle between one segment and another is very small, then that's all I care about. So if on this segment, for example, if I divide this 6 times, that might be sufficient, because what really matters is the angle changing between one segment and another. Because when I turn this into when I extrude this or loft this, or I turn this into a model, what I'm concerned about is not seeing the facets. I will have some shading or some smoothing applied, and the smoothing is going to look better when the angle between one segment and another is smaller. Did you have a question? Okay. So I'm going to, with some thought, go through this and divide these segments up properly. So looking at this, I would figure about 6 segments gives me a proper amount of curvature there, or a proper number of steps there. And this one has a little slightly bigger turn, but it's smaller, so 6 steps would probably work there. I could probably get away with 6 there. That's fine. 6 there would be fine. That would be fine there. And I could go ahead and hit divide. There's 6. This segment, that segment, all these segments probably need a little bit more division, maybe go up to something like 10, and so on. So that is my methodology in trying to divide these segments properly. And once I've got these segments divided properly, of course we need to turn off interpolation. So steps can be set to 0, and if I see any straight line segments reappear, that means that I missed something, and I need to go back in and divide those segments. Okay. Couple more things about the edit spline. Within the Vertex subobject mode, I can do some pretty cool things. And during the discussion this afternoon on advanced poly modeling, you're going to see Alex do a lot of this stuff and do a lot better than me at this. He's really good at poly modeling, but for him also, poly modeling starts in many cases with 2D modeling. And so what you'll see him do, and sometimes you'll see this on models, but you'll also see him do this on splines, it's important to know how to do things like add curvature to a corner like this. So let's say we have a corner and we want to turn, let's do this with the letter T up here. Let's say we want to add a little bit of curvature to this T. How do we do it? Well, there's some commands down here, somewhere here, fillet. I can add a fillet and do that. Now it doesn't look like a fillet because I've taken away the interpolation. So if I want to see that curve as I'm doing the fillet, I need to temporarily turn that curvature back on. I need to set that steps back to 6 during the time that I'm applying that fillet. Instead of adding a fillet, I can add a chamfer. And a chamfer is going to be a straight line. It's not going to have a curvature, but a fillet will. You can type in an exact amount, or you can just click and drag. You'll see that when we start creating some lofts, it's very important to understand where in your path and where in your shape the first vertex is, second vertex, and in order to see that, we can use this show vertex numbers. If I click show vertex numbers, I can see that the first vertex in this particular polyline or spline is right here. That's the first vertex, and it's always going to be denoted with a yellow square, and every other square is going to be white. So that's the first vertex, second, third, and fourth. If I have a problem with a model that started with a spline, if I had a problem with, say, an extrusion that I do, then I can turn on show vertex numbers and figure out where the problem exists. Because if I have the second vertex here, third vertex here, and then I see I have a fourth and fifth sitting on top of each other, or if I have the fourth here, and then it goes back here for the fifth, and then back here for the sixth, that's going to be a problem too. So showing the vertex numbers allows me to go around this and see which vertices are numbered in what way, and I can quickly identify any problems. Lastly, with a closed spline, we're able to create a solid object. But let's say we want to, for whatever reason, we want to separate some vertices. Let's just say, for example, we want to separate this segment from this segment over here. We can select a vertex and click the break command, which will give us a vertex there, a vertex there. If we then want to reconnect them, we can turn on snaps mode, snap from one vertex to another, but doing that doesn't make this object, or doesn't make this spline closed. It looks like it's closed, but it's not. We have to select both vertices, and notice that it says 2 vertices here. We have to select both vertices and use the weld command to weld these vertices. As soon as I do that, notice that the vertex changes to 1. Whenever we import line work into Max, regardless of where it came from, it's a very good idea to manually weld vertices. And what I mean by that is, if I import this line work, I will always go into Vertex Subobject mode, select all the vertices, and hit the weld command. You will see in some of the drawings that we're going to work in, virtually all the drawings that we work in, whatever line work we bring into Max is not going to have all the endpoints welded. There will be some problems in all the drawings, and if some of these endpoints don't weld, the result will be an object that doesn't extrude properly or loft properly, and it will just look really weird. Okay, so when we come back, we will look at we will start creating some walls using the shapes and the paths that we bring in from AutoCAD, and we will clean up in Max. We will clean up that line work and figure out where all the problems in the splines are, and then start building some lofts to turn our line work into some walls. Before we go on a 10-minute break, does anybody have any questions about anything we've talked about up to this point, either online or in class? Is everybody able to follow along and understand everything so far? Okay. All right, with that, let's take a 10-minute break, and we'll be back in 10 minutes. Okay, so let's keep going and let's get into some wall modeling. Let's figure out how to start building some walls. Okay, let's go ahead and reset max. And let's get a nice clean max scene. Let's, for a moment, go back into base 03, and I want to address something that was identified during the break. I used 2004, AutoCAD 2004, and have just recently installed 2011 on this machine. This is a new machine. Haven't had too long, but the main workstation I work on is has AutoCAD 2004, and some of the features are significantly different in here. And one of the features that I use on AutoCAD 2004 is this layer isolate and unisolate. And inside 2004, the command for 2004 and I assume 2007 is lay ISO to isolate a layer and lay on to turn all those layers back on. But I guess with 2010 and 2011, they've implemented a new command called lay uniso, which is why when I was trying to turn back all the layers, turn all the layers back on and display them properly, it wasn't displaying them properly. So the method that I use to isolate layers, the method I was talking about before, you simply type in lay ISO, select an object on the layer you want to isolate, hit enter, and it does this. And this feature I don't like because I don't like seeing all these objects in the background. Even though I'm not supposed to be able to delete them, even though I can't delete them, I really don't like seeing all these elements here in the background. But to get this all this line work to show back up properly, you need to type in lay uniso to make them return to their full bright and selectable quality. So to import this line work, we have to isolate these objects and get them into a new file, which is what I did before. I created a file by going into Layer Manager, selecting all the layers, turning all these layers off, and then selecting just the layers that I want to bring into a new drawing. So however you want to do this, I would suggest doing the same method I'm doing here, which is going into Layer Manager, turn all the layers off, and then turning back on just those layers that have the prefix 0-. So these are all the layers that I created myself. And then we can save this file, or a file with this line work, by using the wblock command. And if you're not able to do that, if you don't want to follow along, there's a file already. It's called temp. It's in the same folder, and you can see right here it has the paths and profiles already saved. So at the very least, we're going to create walls right now, and if you don't want to create this wblock that I'm creating right now, you can just use this temp file that's already stored in here. But I want to create a wblock of this line work, and instead of actually importing these windows and doors right now, I'm going to concentrate on the paths and profiles. So I will select just these objects, type in wblock. I've got my objects already selected. I have my pick point established as my origin, and I've got my file name set up as new block. I'm going to replace the file that's already sitting on my desktop. I want to override it. So I just created that file. So that file is sitting on my desktop right there. So that's the file that I want to bring in. Are you guys able to do this? Okay. Is anyone online having any trouble getting to this point where you have an AutoCAD file with just that line work created? Again, if you have a problem, you can just import this object or this file called temp. So we need to go to File. We need to go to the File menu, Import, and we want to select the Legacy AutoCAD DWG file type, and then select whatever block you created, whatever file you created. We want to merge objects with current scene. And the only setting we need to worry about, we need to decide if we want to change, is convert to single objects. All of the lines that represent the paths on the floor plan, the paths that we're going to loft, are on separate layers. So it doesn't matter whether we have that option to combine objects into a single, combine elements into a single object. These lines, the green lines here and the red lines, are on one particular layer and another layer. So the green lines are on one layer, the red lines are on another layer. So if we were to select convert to single objects, all those green lines would be part of the same object, and we would have to detach them individually, and there's no reason to do that. So we need to convert to single objects turned off. So select OK, and moving around in user view is not too easy, so we're going to switch to, moving around in perspective view is not too easy, so let's switch to user view, and then let's go into top view. Let's just go ahead and create a loft right off the bat. So I want to create a loft using this circle here. I want to create this curved portion of the wall that you see right here. This is a curved wall holding a staircase. So that's the wall that we're going to create first. And we're going to use this profile, this far left profile, to create it. So in order to create a loft, select the path. We're going to go to Create Geometry, select the drop-down list, and select Compound Objects from the drop-down list. Now this class assumes that you have a fundamental level of knowledge of Mac, so it assumes you know how to find the loft and find things like the scatter and find certain modifiers. So I typically like to say everything that I do, but if I'm going fast, it assumes that you know where to find a particular feature like the loft. So create geometry, compound objects, select loft, get shape, and then click on that shape that we want to create. There are many things wrong with this particular loft that we just created. Can somebody identify some of the problems, either online or in person? If you have a comment online, simply type your comment in the question field and I will see it pop up. So 1 second, somebody has a question online. Jacqueline, I just unmuted your phone. Do you have a question?
Oh, no, I'm very sorry.
Oh, no problem. All right, I'll put your hand down. Okay, go ahead. Do you have a far right shape that I selected? Right? No, I selected the far left shape. The loft that I just created was used, or the shape that I used for the shape was this one right here. So, all right. With the exception of you, Novell, who you've already seen me do this particular exercise, can somebody tell me some of the things that are wrong with this loft? Either online, you can type in your comment, or in person. Let's see, Rachel, you're saying the pivot point is the wrong spot. Yes, that's one thing. Donald, you're saying the loft is backwards and not at the right elevation. Yep, you're both right. There are a few more things wrong. Let's just fix those things at this point. Let's fix the pivot point. The loft has to have a shape that has the pivot point created in the right location. Let's turn off this home grid. We don't need to see the home grid, and we don't need to have this snaps mode turned on. So every object has a pivot point, and that pivot point is usually the center of the object. You see, as I select each one of these shapes, the pivot point is at the center of the object. Some objects, like the box, will have the pivot point at the bottom center of the object, whereas like a sphere will have it right in the center of the sphere. But when you create something like a rectangle or import a spline into AutoCAD or from AutoCAD into Max, it will always have the pivot point right at the center of the object. So we need to adjust this, because this pivot point is the point at which the object is going to be lofted or projected along the path. So you have to establish the pivot point, and the pivot point should be the bottom of the wall where it meets the ground outside. It shouldn't be the inside of the wall, it should be the outside, because the path that we're using to loft is the outside of the wall. It is, in this case, right here. It's not the inside of the wall, it's the outside. Okay. Notice also this bounding box that appears. When you create an object, that object is going to have a bounding box. If I create a simple teapot, you can see the bounding box is going to be to the extent of this object. When I select these shapes over here, the bounding box of the shape is connected up here. So this sort of indicates that there's something up here. There's some reason why there is a bounding box up here, and it usually indicates that there's something up here, like maybe a hidden vertex or some part of an object that wasn't deleted. But I honestly don't know what that reason is. For some reason, when these lines were translated from AutoCAD into Max, they retained something like perhaps the origin, which is right up here. Something is causing Max to think that this object exists way up here. It doesn't matter. In reality, when we create a loft, it's not going to have any effect on the object. So I'm just pointing that out in case you're wondering why that bounding box is so large. But we need to make this pivot point down here at this bottom corner of the wall. And this is why I have these helper objects. These helper objects allow me to use a feature called Align to align the pivot point to the corner of the wall very easily. Now, if I were to use the Align feature to set the pivot point to a certain point on this object, I need to be able to do it by aligning the pivot point to a certain maximum and minimum point on this object. But unfortunately, there is no point on this object, this green shape, that I can say set the pivot point to the maximum x and y value of this object. This is this point right here that I'm trying to set the pivot point to is the minimum y value of the object, but it is not the maximum x value of the object. If I scroll up and look at the top of the shape, I notice that the shape goes farther out. This would actually be the maximum x value of the object right up here. So if I set the pivot point to the minimum y and the maximum x, the pivot point would actually be out here. So I create this line that goes from the top right to the bottom left, and I say I want to establish the pivot point of this green shape, this green line, by setting its pivot point to the maximum xy value of this red line. The maximum x and y value of this red line is right here. So it makes it very easy to do. So to set a pivot point, we need to go into the hierarchy panel. Inside the hierarchy panel, we see the effect pivot only. That's where we adjust pivot points. And we can manually move around the pivot point and get it close. We can zoom in. We can try to get it nice and close. But when it comes to walls, that should be exact, and you should make the pivot point exactly where it needs to go, at least for the walls, because the walls is where everything else is going to be built around. So I want to use this Align feature found in the main toolbar. I want to click on the Align icon and then click on this red line. And when I do, this window opens up and it says, how do you want to align? How do you want to do the alignment? I want to set the pivot points. I want to set the current object's pivot point to the maximum x, y value of the target object. The current object is the green shape, or the green spline, I should say. The target object is the red line. So I want to set the current object's pivot point to the target object's maximum x, y value. When I select OK, you see the pivot point is right at the corner of this red spline. And the best part is I can now select another shape or another spline. I can select that other spline, select the Align feature again, click on its helper object, and the gizmo or the pivot point automatically snaps to that point because everything is set up in here automatically. So I can keep going from one shape to another using the Align tool, and it very quickly allows me to set up the pivot points properly. And then this object up here also has a pivot point in the center of the object, but it also needs to have a pivot point that's the same as the wall that it's sitting on top of. So the roof up here has the same pivot point as the wall. And now that that's done, everything with the pivot points are fine. I need to get out of pivot point mode and look at what's going on now with the wall. Nothing happened, nothing changed with this wall. The lofts will not update when you update a pivot point. You can't just change the pivot point and expect to see the wall update. We have to delete this loft and start over. I want to select that curved portion again, click on Create Geometry, Compound Objects, Loft, Get Shape, click on the shape, and now the loft is created such that the bottom of the loft is sitting at the, keep hitting the wrong command, the bottom of the loft is sitting at the home grid, which is what we want. But as somebody pointed out, the wall is pointed inside out. You can't actually see this from every view, but the wall is pointed inside out. And that is certainly something that's wrong with it, but what else is wrong with this wall? It's clearly doesn't look right. It's not being displayed right. It's black. Anybody know why it's black? No, the object's not flipped inside out. If I pan around or rotate around and zoom in, the object is pointed the wrong direction. It's pointing inward, meaning the direction of the profile is oriented in the wrong way, but the object itself, it's not like the normal of the faces are pointed in the wrong way. If somebody wants to answer online, you can answer online. If not, I'll just go ahead and mention it. The object is black because it is not the shape that is being projected is not a closed spline. It looks like a closed spline from top view, zoomed in really close. It looks like everything's fine, but it's not. Inside AutoCAD, it looked like a closed spline. In fact, when I move one part of the line, they all move. You know, when I go into AutoCAD and analyze what's going on here, I can select the object and move it, and the whole thing moves. So it looks like everything's fine. But when I look closer, I will see that there's some vertices that didn't weld properly. And this is why anytime you import line work, you need to weld endpoints. You need to go into the object and weld the endpoints. So I need to add the Edit Spline modifier. Well, actually, the Edit Spline modifier is automatically there. Whenever you import a polyline from AutoCAD into Max, it's always going to import as an editable spline. So I need to go into Vertex Subobject mode, and the quickest way to do it is to hit the keyboard shortcut 1. I can hit Control-A, and I can hit Weld to weld all the endpoints. The Weld feature is right here in the middle of the Edit Spline modifier. And a quick note about keyboard shortcuts. If you ever watch really fast modelers or people that work in Max in general that do really fast work, for example, when you watch Alexander this afternoon, he uses a lot of keyboard shortcuts, and he may back off of that a little so that you can see what he's doing. But really good fast artists will use keyboard shortcuts, so they never even have to touch the command panel for some of the things that they're doing. So if I can set a keyboard shortcut up for the weld command, I can literally, without even going into the command panel, I can access Vertex Subobject mode. I can by hitting the keyboard shortcut 1. I can hit Control-A to select all my vertices, and I can weld my vertices by pressing one more keyboard shortcut. And I never even have to spend time navigating in the command panel. But regardless, you got to weld all these endpoints. So I would just go in here and, I would go into Vertex Subobject mode, select all the vertices, Weld. Go into the next shape or next spline, go into Vertex Subobject mode, select all the vertices, Weld. Next shape, Vertex Subobject mode, Control A, Weld. And every one of those shapes had a problem. Now, when I look at the loft, it looks proper. As soon as I weld those endpoints of the shape, the loft updates. Any change I make to the shape or the path updates the loft. Now let's zoom in closely to this loft and look what's going on here. So clearly the loft is pointing in the wrong direction. It's not pointed outward, it's pointed inward. How can we fix that loft? How do we make the loft oriented outward? How do we change the way that the loft is facing? I'm sorry? Well, how do we flip it? How do we make this trim feature point outwards? Okay, anybody online? Donald, do you remember what we showed this same type of example in the other class? Do you remember what was discussed? Okay, we need to reverse the direction of the path. Thank you, Rachel. That's exactly what we need to do. So we need to reverse the direction of the path. How do we reverse the direction of the path? How do we make that path be reversed? Would there be a modifier? I don't think there's a modifier that can reverse the direction of this loft. Somebody's saying, Donald's saying spline mode, or yep. Well, I know you know the answer, but spline mode or Control Q when selecting shape. So we need to go into the path and reverse the direction of the path. How do we do that? How do we reverse the direction of the path? What is the path? Is the path a mesh object? Is it a compound object? Is it a spline? It's a spline, right? So how do you suppose we modify the path? We go into the Edit Spline modifier. We have to select that shape. Or I'm sorry, we select that path. We need to select that path, which is an arc. It's currently an arc. It was brought in as in AutoCAD. It was an arc, so it transferred as an arc. And you can see how we can adjust the loft just by updating the radius of the arc. But we need to reverse the direction of this arc. How do we reverse the direction of the arc? Spline mode. Okay, Donald's saying spline mode. Select the path under geometry, hit reverse. Okay. Convert to spline. Yes, we need to convert to spline. So we're going to, with that path selected, 0-paths 5, with that path selected, we add the Edit Spline modifier, and we need to go into Spline Subobject mode and click the reverse button. As soon as we click the reverse button, you see that the loft updates. And now looking very closely, that shape for the wall starts at one point and is projected along the path, and it goes from one vertex to another. Okay? Are you able to do that? You selected the point to do what? Okay, so have you added the Edit Spline modifier? Well, you can right-click Convert to Editable Spline or add the Edit Spline modifier. Okay. So you're there? Okay. Now, where is, if you don't already know, wherever you have your little hand feature inside the command panel, you can right-click and select Close All to close all these rollouts. Where is my interpolation rollout? No. Where is that rollout that I normally see here that allows me to change the interpolation and change the number of steps of this path? Anyone online know? Remember what I said about where the interpolation is? Yes, it's on the arc. How do we, if we go down right now, notice that it says this error message, a modifier exists in the stack that depends on topology. Changing parameters may have an undesirable effect. The dependent modifier is the edit spline modifier. Are you sure you want to continue? If I say yes, I run the risk of doing something that can't be undone. I run the risk of destroying my loft, destroying the spline, because what you're telling Max to do is that you want to go down to the arc and let you change the arc's settings, like radius, while still maintaining the change that you made to the edit spline. So that might be something it can't do. So you shouldn't go down to the arc. What can you do to bring the interpolation up to the editable spline? Or you collapse it. So we need to convert to editable spline. And when we do, we can see the interpolation right there. Okay, any of you guys having trouble? Okay, so you've got all right. Okay, I'm going to show this process one more time because some people are having a problem with it. So I've got a shape, and I'm going to make this color a little bit easier to see. I'm going to make this a dark blue. So there's my path. I've got my path, and let's make this a 4 viewport layout so we can see both the path and the shape at the same time. All right, so we have the shape and we have the path. Let's make it really simple. Let's make sure that we collapse the arc into an editable spline. So if you haven't already done so, convert to editable spline. So you should see what I see right now. You should see interpolation and geometry, and you've got only one modifier inside the modifier stack. Everybody there? Okay. So go into the selection rollout. Go into selection and turn on vertex sub-object mode, and then turn on show vertex numbers. This shows you which one is vertex 1, which is vertex 2, vertex 3, and 4, and so on. Now, in order to get that loft to reverse direction, we have to make number 4 be the first vertex and number 3 be the second vertex. We have to make this go in the opposite direction, so it should be 1, 2, 3, 4 in the opposite direction. So we need to reverse the direction of this spline. This is, what do you mean? Okay. I think I might have already reversed it myself. I think I had already reversed it. So if you want to reverse the spline, all you have to do is go into spline sub-object mode, select that spline, and click the reverse button found under the geometry rollout. So you click reverse, and you see the spline change direction. Regardless of how it is, as long as you can change the reverse of the direction of the spline, that's the important thing. You all can do that? You all there? Okay. So regardless of which way it should be, let's just get there. Now, with that path selected, loft the same shape again. And mine is in the wrong direction, so I could just delete this loft and start again by selecting the spline and reversing the direction of the spline. So instead of it being 1, 2, 3, 4 this way, instead of going counterclockwise as seen from top view, it would go clockwise. So I need to reverse the direction, and now vertex 1 is right there. And now when I loft, it's going to loft properly. So click loft again, get shape, click on the shape, and now I should see the loft pointed outward. And here's a little trick, here's a little shortcut if you don't already know. If instead of going down into the edit spline modifier and reversing the direction of the loft by reversing the direction of the spline, you can just hold down the control key when you're clicking on the shape that you're lofting. So I have get shape enabled. I have the get shape button enabled. I hold down the control button on my keyboard and I press the shape, and notice that it reverses the direction of the loft. I let go of the control button. I press again. There's the shape converted to be pointed outward. No question? Okay, Jacqueline, I'm unmuting your microphone. Do you have a question that you want to ask? Okay. Again, if you want me to unmute your microphone, if you want to ask a question, please feel free. I will unmute your microphone. You can ask a question. Jacqueline, you're saying, could you please repeat the control command technique you just performed? Could you please repeat the control command that you just performed? Okay. So I've got my wall, and it's pointed the wrong direction. So I can, instead of, and by the way, if you see my mouse moving over here on the right-hand side, and you're wondering what I'm doing, if you don't see me clicking on buttons, there's an interface over here on the left-hand side that I constantly have to minimize and expand, and sometimes I need to move it out of the way in order to see what's going on. And when somebody has a question, I have to expand it and then click on the question to see what somebody's asking. So if I'm ever doing something over here and I'm not talking about what I'm doing, then you can assume that I'm just manipulating the interface. So I have a loft, and it's pointed in the wrong direction. As long as I have the Get Shape button selected, I can keep clicking on different shapes over and over again. It's not like I can't switch from one shape to another. I can select any one of these shapes. I can even select one of these lines down here. I can select one of these lines, and it creates a loft according to the shape that I've selected. But if I get to a shape that I like, but it's pointed in the wrong direction, I can hold down the control button and change the direction. For example, this particular shape right here was used to create this loft. If I don't like the fact that it's pointed in the direction it is, I hold down Control on my keyboard, click the shape again, and now the loft gets created in the opposite direction. If I click this shape up here, the loft is created like so. If I hold down Control, click the shape again, it gets created in the opposite direction. Okay, does everybody get that? Everybody able to produce that? Okay. Now let's do something really cool. Delete that loft entirely. Just flat out delete that loft and go into either top view or user view. And what I would like you to do is take this blue curve that you have, that you should have, take that and attach the red line to it. And I'll show you how to do it once. If you don't know how to do it, just watch me and then you can do it. I'm going to select that blue spline. I'm going to go to the Modify panel. I've got the Edit Spline right there in my modifier stack. The Edit Spline modifier, just like the Edit Mesh and Edit Poly, have an Attach feature, and I can attach the red line to the blue spline. So I can click Attach, click on the red spline, and I've just attached both splines together. But I can't loft right now. I can't just loft this because I wouldn't see anything more than I saw before. I would not see this portion of the wall as a loft. Anybody want to venture a guess why? Because the reference of the loft doesn't have that aspect. I'm not sure what you mean. Somebody beat you to it. Donald says the endpoints need to be welded. So yes, we need to go into vertex subobject mode, and notice how you got two vertices. It's pretty small, you can barely see it, but you got a vertex 1 and a vertex, looks like vertex 4, sitting on top of each other. Even though they're part of the same object, they are separate splines. In fact, if I went to spline subobject mode, notice how I can select one spline and then select the other. They're two completely separate splines. I have to have them welded. I have to go into vertex subobject mode and weld those endpoints. So I click on Weld. Now notice that what was previously two different splines is now one spline. And it goes from vertex 1 all the way to vertex 7. Okay, so can everybody do that? Incidentally, while you guys are working on this, if anybody has if anybody feels frustrated, if anybody has problems building any of these objects we build, I can make you the presenter so that everybody can see your screen, and I can watch you manipulate some, or I can even take control of your mouse and show you how to do something right on your screen. So we could do that if you wanted to. So feel free at any time to show your screen. All right. So Cliff, did you get it? Okay. Now let's loft this again. Create another loft. And you should have something that looks like mine right now, where you have a wall that now connects the curved portion with the straight portion. The reason why I love the Loft so much better than the Edit Poly is because trying to do this with the Edit Poly would be so much work, and it would never be as accurate. This is absolutely perfectly accurate. You cannot get this kind of accuracy with the Edit Poly. It's just not possible. But even if you get it to the point that it looks the same, it takes so much longer to get here, to build the curves into this and to get it to update, and to give you the flexibility to be able to change things like the shape on the fly. There's just no faster way to do it than this. And I don't think there ever will be. I don't think 20 years from now there will be a faster way to do this. Again, if you're using Revit or Desktop or some other program and you already have your models built, then perhaps this is not the right way to go. But if I was a visualizer, we were talking about this in class, if I was a visualizer and you gave me a Revit model, I would look at your Revit model, and chances are I would probably start over and build the models from scratch, because I can't be sure that, one, you built your model correctly. Even assuming that you do, I can't be. Chances are those models are going to be a lot heavier than what you create here. You can't create a model cleaner than what you can create with this method we're going through right now. I can specifically delete some faces or remove some faces that I don't need, but when you build a Revit drawing or architectural desktop drawing, it's going to create a lot more faces than you need sometimes. Correct me if I'm wrong, but when you Jim, when you work in when you're building a window, for example, and you put that window inside a wall, it's going to create a face on the underside of that window frame, right? A face that you can't even see. Am I correct? It will cut it. Okay. Okay. Well, I know in desktop, when I worked as a draftsman in desktop, that wasn't the case. So maybe it's a little more efficient right now, but regardless, I would venture a guess that the models that you create in Revit could be problematic, and I think I would always want to start from scratch. So regardless, let's go ahead and continue on. So we have this loft, and we fixed the pivot point, we fixed the direction of the spline, the path, and we fixed the fact that the endpoints on the shape were not welded. Now it's time to fix another problem, which you can't see right now until you turn on faceted mode inside shaded view, and that is the fact that there's far too many vertices on this object. Just like with interpolation on a spline, we need to tell the loft not to interpolate this loft. There is a rollout called skin parameters on the loft, and by default, the shape steps and path steps is set to 5 and 5. You should never, ever set these shape and path steps to anything other than 0 and 0. And I'll explain why in a second. Let's right-click on each one of these sliders to turn the shape steps and path steps to their lowest possible value. And now we get a loft that doesn't have all these extra faces, but clearly it doesn't have the curvature that we want. And to demonstrate this, you don't have to do this. It probably would be easier if you did. I want to just move this loft off of the shapes that it is currently sitting on, just so I can see the shapes, so I can see the path and the loft a little bit easier. So you can leave it on. You can leave it where it was if you want. If you want to move it off so you can select the path a little bit easier, that's up to you. But I want to modify this loft and add the path steps back in here. But if I just select this loft and go to the Modify panel and add the path steps manually, if I go in here to the path steps of the loft and add steps, it'll fix this curved portion, but it's also adding steps along the straight portions that I don't want. So I bring the path steps down to 0 and instead update the spline that is used for the path. So we use the same process we looked at last hour where we divide these segments up. And a quick, easy way to see the number of steps is to turn on Vertex Ticks, which is found in the display panel, or right-click Object Properties. Just turn on Vertex Ticks for this path so that we can see the vertices that are being used for this loft. And notice that wherever there is a vertex, there is a vertex on the loft. So we need to divide these three segments. So we need to go into Segment Sub-Object mode, press 2 to get to Segment Sub-Object mode, and select the three segments that make up that curved portion of the path. And simply click the Divide button. Let's maximize this viewport. Click the Divide button to add more and more steps to this path, which adds more steps and vertices to the loft. And I just want to keep clicking Divide until I get the loft smooth enough, or to appear to be have enough vertices to do what I want to do, to get that smoothness to come back. Now once I do that, I can close out of Segment Sub-Object mode, and I've just fixed the path steps. I've just updated the path, and it has the proper number of vertices. But if I go back to a 4 viewport configuration, okay, if I zoom in closely to the loft, the model of the loft, and compare it to the shape, let's look at the other side of the loft over here, and compare it to the shape right over here, we see that the loft does not have the curvature that it's supposed to have, and it's because, of course, we modified the shape steps. If we click up on the shape steps and add shape steps, the curvature will come back, but all these extra steps will be created vertically along the length of the wall, the vertical length of the wall. So we don't want to add shape steps here. We need to refine the shape of the profile. So we need to go into each one of these curves and divide the curves as well. So I want to go to Edit Spline, click on Segment Sub-Object mode, and notice, for whatever reasons, I don't know why, but this arc, when it translated, when this curve portion was brought in, it only had 2 vertices. This arc down here has 3 vertices. So if I want to be really precise, I'll select this set of segments, divide it separately than this, because if I select all 3 segments, if I select both of these curves, the one that already has an extra vertex is going to be divided faster than the one that doesn't. So I'll select that segment, and let's go ahead and select that one right there. Divide each one of these a couple of times, and just click on Divide over here until I see the shape update and the model update. And then I can do the same thing with the other curved area that has a vertex to begin with. Click on Divide, it updates, and now I've got the proper amount of curvature built into all the curved portions of my wall. And I can just quickly check anywhere else to see if there's any other lost curves. I can't really check the loft because I might not know, looking at the loft, if there's supposed to be a curve or not. But if I look at the shape and I see a curve on the shape and don't see it on the loft, then I know that something's wrong. And if you're wondering what's going on with this curve at some point must have been created by, instead of having an arc, that must have been created by the polyline command, where you just click once and then click again, click again, click again. So this line must have been traced, which is why it doesn't look like it's curved. And you can check this. If you were to divide, if you want to check to see if a straight line segment is supposed to look curved, when you divide that straight line segment, if it doesn't update, if the curve doesn't update, then you know it wasn't supposed to be straight, and you should delete that vertex that you added because it's not supposed to be there. It's not going to help. I could go in here and manually replace these lines with an arc if I wanted to, but I don't have to. Okay? So we fixed the shape steps and path steps of this loft, and there's one more thing to fix. Okay, Reggie is asking one more time. Okay, no problem. Let's demonstrate this one more time, and let's do it with a different shape. Let's do it with this shape right here. So let's apply this shape to this loft, and then I'll go back and do it. I'll set it back up one more time. So I've got this loft. When the loft is selected, I can just update it by clicking Get Shape and clicking the shape that I want it to have, that I want updated. I click right there, and there's my loft. It's pointed in the wrong direction, so what can I do to quickly update it? Reverse it by holding down the Control button, clicking the shape again. It reverses the direction, and looking at this in front view, I see that that curve is lost right there. Let's move it over to the left-hand side so it's the same as the viewport over here. If I want to bring that curve back, I've got to subdivide this segment right here. All I need to do is go into Segment Subobject mode. Again, I can open this up. I can scroll down here and look for the Segment Subobject mode, but it's a lot easier just to press the keyboard shortcut 2 to access Segment Subobject mode. Click on that segment and manually divide this segment here. So I got to scroll all the way down within my Edit Spline modifier. I'm in the Geometry Rollout, and I click on Divide, click it again, and one more time to get that curvature back the way I need it to be. And just to update this and make this the proper wall, I'll go ahead and select that wall, Get Shape, and then update it with the shape I was working on before over here. So now that loft updates. Reggie, does that do it for you? There's one last thing to fix with this wall. Let's maximize this viewport and see what that last problem is. We can turn off faceted mode because we don't need to see the facets anymore. What appears to be a little odd with this wall? What's the last thing that you don't like about this wall, besides the color being not set properly? But does the wall look like it's shaded funny? What's causing it to appear to be shaded like this? He's saying that it's because maybe we don't have enough vertices along the corner. If I go into faceted mode, you can see that we don't have but one corner here, one set of vertices or one set of edges. I can go into wireframe mode, F3, wireframe mode, and look at this in wireframe mode. Is this not what it should look like? Should it have more vertices right here? Okay, I'm not sure I understand. You're saying that you're saying I have one corner and one set of edges, one set of vertices. So you're saying that we should have vertices just on either side of the corner for what purpose? So I'm just asking what's causing this wall not to look like a corner. Yes, Donald's saying surface parameter shading is turned on now. Surface parameter shading is turned on. Yep, if you open up the surface parameters rollout, you will see a smooth length and smooth width. By default, all lofts are going to be set to smooth length and smooth width. It should not be turned on by default. But notice how when I turn off the smooth length and smooth width, look really closely at what's going on with this wall. Hopefully you can see it on the screen here. Do you see these facets in here? These facets are showing up, and if you don't subdivide the segments like I did, and if you have less vertices than what I have here, it's going to be even more noticeable. When you turn, the reason why that smooth length and width is turned on is so that it removes what you see here, all these facets. When I turn on smooth width and smooth length, it removes those facets. It does that by looking at two angles or two different faces. Let's say, for example, that face right there, or I should say polygon, and that polygon right there. Looks at two polygons next to each other and figures out the angle between them, and it decides these angles are so close together that instead of letting each polygon be shaded in their own unique way, it's going to blur it's going to take the average of the two of them and blur them together. So if you look at the color of this polygon and the color of this polygon, when I turn on smooth length, it's going to take the average color. I say average color, it's the average shading. It's going to take the average color and make both of those be that, and it sort of updates. It goes around the path of the wall and does the same thing. The problem is it gives us curved portions where we want what looks like corners. It gives us curves where we want corners. So we have to turn this off, or I shouldn't say we have to turn this off. We have to remove smoothing. But how do we get the corners to appear properly while still maintaining the smoothness here? How do we get the corners to look like this and get the facets to go away? Does anybody online know? Anybody want to venture a guess here? The smooth modifier, yes. All we have to do is add the smooth modifier. If you have smoothing turned on here under surface parameters and add the smooth modifier, it's going to override the smoothing that you have applied automatically. It's going to override that smoothing and replace it with its own smoothing. So by adding the smooth modifier, it essentially overrides what we had, which was smoothing, and replaces it with nothing. We've added the smooth modifier, but we've actually turned it off. We've actually turned off smoothing. Why? Because just by adding the smooth modifier, it doesn't automatically smooth. It just sets you up to get ready to smooth. In order to actually perform the smoothing, you need to select Auto Smooth. And when you click Auto Smooth, it then smooths those facets that we were previously seeing. It's important that you realize that. By adding the smooth modifier, it overrides the smoothing that was there and replaces it with nothing, and it lets you auto smooth yourself. And anything that's within this 30-degree threshold angle gets smoothed. So if I wanted to smooth these corners, what do you think I have to type here under threshold to get these corners to smooth properly? 90? 90 or 91? So I type in 91, and now all the right corners, all the straight corners are trying to smooth, which obviously is not going to give good results. So hopefully everybody has gotten to this point, and that's it. This is a perfectly modeled, this is the most efficiently modeled wall that you can have. The only thing that you could possibly do to make this any better is do things like delete the polygons on the underside that you'll never see. Or if you're only rendering an exterior view, you could possibly delete the faces on the inside. Now, if you would, save this somewhere to your desktop, save it somewhere where we can access it later, and just call it something like wall. And let's do something with materials with this wall, just because we're at this point where we can see this. Let's add some materials to this wall, but let's do it in a pretty unique way. How can we apply unique materials to different portions of this wall? Sub-object, multi-sub-object, yes. Can you walk me through the process? Okay, Donald is having a problem here. He's saying the second profile in my file is not incorrect. The top edge is not horizontal. The second profile. Okay, I'm going to unmute your microphone, Don. I'm not sure what you're talking about. Can you tell me what you're talking about with that profile?
Yeah. Yes. If actually it's a third profile. I was wrong about that. But the third profile has on yours it has
this one right here.
Concave. Yeah, it has a concave radius right there where your mouse is.
Yep.
And right above that is a vertical line.
Right above this one right here?
Yeah, that vertical line is missing on mine.
That vertical line is missing on yours?
Yep. And the top edge is connected to the upper part of the radius.
Did anybody else have that problem? Did Donald saying that when he imported this line work, this vertical line did not import? That would be really odd. And you're sure you didn't go into sub-object mode and And when you divide, was this missing before you ever like tried to divide this curve?
I think when I was doing the welding, I may have set the weld distance too high and inadvertently welded those two vertices together.
You adjusted the weld threshold when you were doing the you got to be really careful with that when you select all these vertices and click on weld. If you click weld and adjust that 0.1 too much, you can make that you can accidentally do that. That's a good point. I'm glad you had that problem because I didn't mention that. But when you import your line work, just don't automatically assume that the weld threshold is going to work, because if you're working in a drawing that has very small geometry or very small splines, then you might need to adjust that to prevent what happened to you, which is these two endpoints welding together. Okay. All right, let's continue on. So we know that if we add the multi-subobject material to this loft, we can apply different materials to different portions of the loft. Now, that's true, but how specifically can we do that? Can you walk me through this process, Jim, and go to the material editor, highlight a slot, click the standard button, go to multi-subobject material, okay, discard old material, okay. Now let's create 3 subobject materials, and to change it to 3, we need to change the set number to 3 by clicking set number, type it in 3, press enter. Well, I guess you can't press enter. You can click OK. Now we got 3 subobject IDs. Let's just apply 3 different colors to the 3 different subobject materials. Cliff, are you able to do it? Okay, you got it. You can leave it at 10. You can have the set number be anything you want, but we're not going to create that many subobject materials. Okay, now what do we do, Jim, to make this? What else do? We have to apply this, obviously. We obviously have to drag and drop this onto the object. Okay. Look at an object's channel. How do we look at an object's channel? What do you mean by that? Okay, we have to look at what material ID is applied to each portion of the loft. Okay. Novell, is that correct? Yes. You can't look at the loft and apply unique material IDs like material ID number 1, 2, 3. You can't say I want this portion of the loft to be material ID number 1, this portion to be 2. You can't do that within the loft. You have to do it within the shape. So you need to go inside the shape and go into each individual segment. Each individual segment, let's scroll in here really close. Actually, let's switch to a 4 viewport configuration. So there's our loft up here. Let's close the material editor. You need to go into each specific shape or each specific segment on the shape and change the material ID of that shape or of that segment. So I've got the bottom segment of this shape selected. Within segment subobject mode, at the very bottom of segment subobject mode, there is a surface properties rollout. If we change the set ID, if we set the ID to a certain amount or change it to something else, currently it's set to 1. I'm not sure why 1's not even shown here, but it's currently set to 1. And you can see that in the material editor because material ID number 1 is set to blue. But if we come in here to the set ID field and type in 2, oops, I accidentally deleted that. Okay. I had accidentally deleted that that segment, so I'm going to do this again. So if I have the set ID field set to number 1 and change it to 2 and hit enter, I see that that part of the loft updates. I can go into another portion of the loft. It doesn't matter what parts you do this to. I can go into another portion of the loft, change the set ID field to something else, and have it update. So I'm just clicking up and down on this set ID field to find the right one that I want. Now, what could I do from what I see on my screen, or maybe you see the same thing on your screen. From what I see on my screen, can somebody tell me what I can do to detach these objects from each other, or these submaterial parts to each other, detach them from each other? And the reason why I would suggest doing this is, if you're going to apply materials to these objects, it would make sense to make each object that has a unique material be a unique object, meaning the top portion of my wall where you see it blue, that might be white. The green portion down here might be, you know, a different color. And applying mapping to objects becomes much easier when you have each object that is a unique material be its own unique object. So I always like to have objects with different materials be different objects. So this green portion of the wall, or this bottom portion of the wall, will be one object. The blue trim portion of this wall will be another object, and so on. How can I quickly separate different portions of my wall? How can I make, you know, how can I create an object really quickly from this portion of the wall, or, you know, this portion and this portion? Anybody online know how I can quickly select all of one particular face, one particular type of, or one particular part of this loft? Okay, well, notice this little Select ID button right under the Set ID button. Instead of setting the ID, we want to select ID. So you can type in whatever you want for Select ID. I'm going to type in 1 and then hit the Select ID button, and notice when I do, it's selecting all of, in this case, it selects all of the shape that I have set to that particular ID. But I don't want to do that. I want to select the loft, the portions of the loft that have that particular material applied. So instead of selecting the ID within the shape, I got to go to the loft and do it. I got to go to this loft and select this particular ID. Now, how can I go into this loft and do the same thing I just did a moment ago with the shape? How can I go into the loft, select everything of a particular material ID? Do you know, Novell? Add the Edit Mesh Modifier. Okay, I'm going to add the Edit Mesh Modifier, and then what do I do? How do I select all of the polygons or faces of a particular material ID? Now that I've got a material ID of 1 assigned to, you know, wherever you see this blue, this is material ID number 1. How do I select all of those faces? And this, you know, go into Face Subobject mode. Okay, let's go into Face Subobject mode. And then what? Okay, you added the Mesh Select feature. Mesh Select. Go into Face. Okay. Okay, that's a good way to do it. That is a very good way to do it, and I've never done it that way. But I mean, I've never done it this way applied to a loft. But yes, you can do it through the Mesh Select modifier, or you can just add an Edit Mesh modifier. Go to Face or Polygon Subobject mode. Doesn't really matter which. Go to Face or Polygon Subobject mode. Go down to where it says Select ID. Notice that this is the same thing as it is as it was for the Edit Spline over here for this shape. I can type in number 1 for Select ID, click on Select ID, and now all those elements that are part of material ID number 1 get selected. And I could literally come in here and do a window selection around these, but that's sort of cheating. I mean, for this particular model, it might work, but for models where you have a lot of faces of a different material ID in different areas of the models and on objects where it would be too hard to select faces like that, this is the best way to do it. So I can click on Select ID, type in 1, click Select ID, and now I can detach these faces. I can click Detach, give it a name. I'll call it Trim, hit OK, close out of subobject mode, and now I can select that object and move that object wherever I want. Oh, yeah, you're right. Good point. With just the mesh select, you can't detach. So it's sort of pointless to add the mesh select modifier if you can't detach. That's a good point. The mesh select modifier does not have anything in here that allows you to detach. Okay, so let's see. Somebody has a question. Can you filter? Can you filter? I'm not sure what filter means. Can I filter? Anyone know what Jacqueline might mean by that? A selection filter? Oh, no, yeah. If you mean selection filter, no. It's the loft was all one object, and I don't think there's a way. No, there's no way to use a filter to select those. Why would you use face and not polygon subobject mode? There's no reason why. It doesn't. They will both give you the same result. I could go into here and select faces, select all these faces. I can go in here to select all the polygons. It doesn't matter whatsoever. There's no reason. I mean, if I go in here and select an individual face like that, that'd be one thing versus a polygon. But there's no reason why you can't use either one, because you're selecting them all, so it doesn't matter which it is. Okay. Rachel, I'm going to put your hand down because I assume I answered your question. If you want me to unmute your microphone, you can raise your hand again. And let me clean this up a little bit. Okay. So that is how to build a wall. That is the right way to build a wall. So there's 5 things you got to do when you create a loft. You need to set the pivot point. You need to make sure the loft is facing the right way. You have to weld all the vertices of the shape. You have to set the shape steps and path steps of the loft to 0 and manually update the number of vertices you want on the path. And what was the last thing? There was a 5th thing. Oh, the smoothing. You have to add the smooth modifier to override that automatic smoothing with your own smoothing. So 5 things you got to do each time. And if you want to be nitpicky, you can say there's a 6th thing, and that would be adjust the Edit Spline modifier for each shape and set material IDs for each shape. This is a very important thing, actually. Even if it's a good idea to go through your shape early on and set material IDs early on, even if you don't go through the process of applying the multi-subobject material and doing all that stuff, because right now I still have a lot of work to do on this wall, in the sense that I got to add windows, I got to do some booleans and make some cuts and all that stuff. But I have to do that before I have to make this adjustment to the material IDs before I do that. Because if I were to do a boolean on this, the shape is no longer connected to the loft. While the shape is connected to the loft, I have to do that. Because right now, I can go into this loft or into the shape, make all the adjustments I want, and it's not going to update the entire model. It'll only update that portion that is still part of that loft. But as soon as I start doing booleans, as soon as I start right-clicking these objects, converting to editable mesh or doing booleans or whatever, any change that I make to this path is not going to update, or any change I make to the shape is not going to update. Okay? Let's go ahead and take a 10-minute break, and when we come back, we will start looking at windows and doors. And if you have any questions during the break, please write them down or raise your hand, and I will address the questions when we come back. So getting back into this model, you're saying that the last thing you saw me do is apply material IDs, and you didn't see me attach any of these faces?
It was going in to grab those faces, and then you detach them.
Okay. So
and that was the part I didn't see.
So you're asking how I detach them.
Right.
So all I do is I select the loft.
Okay.
Oh, I select the loft, go in either to polygon or face subobject mode.
Okay.
And then figure out which material ID I want to detach. In this case, the material ID that I want is tied to material ID number 2. So,
green.
well, yeah, green. So I type in material ID number 2 for select. I click 2, and there it is. I've selected those IDs.
Right.
We're going to do this one more time when we create sites. When we create sites, you'll see that we need to sort of do the same thing with material IDs, but do it to a site rather than to a loft. But we'll also do one more loft when we're creating the curbs for our site. So if you hadn't been able to create the loft yet, since you said you have the book, you can look back to the book. But we're going to create one more loft, and I'll make sure I go really slow so you can understand it.
Okay. So anyway, you selected it. You got it to turn red.
Yep.
And then under Edit Geometry, did you click that Detach button?
Yep. Click Detach. Give it a name. Hit OK. And it's just been detached. So it had just been detached from that object, and the one you saw me not detach, the one where you were logged off, I had detached these faces from the object. So right now I just detached this object from the loft.
Now, once you've done this detach, does that go back to the point that any manipulations now
Yes.
that you make shape no longer affects the loft?
Yeah, yes. Yeah, you didn't hear me say that because you were logged off. But now if I try to adjust this profile, it does not update the shape. The minute that I turn this loft into a collapsed object, or the minute I start doing something like a Boolean, if I had Booleaned out some windows, that connection would be broken and I would not be able to make the change. So it's very important that you set your material IDs up here, even if you don't think you're going to need them, even if you don't think you're going to just be on the safe side. It's good to apply some material IDs, and you'll see when we work on the site, it's a good idea when we're going to do a demonstration where we cut a road out of some grass, and while the road is still part of the grass, while they're both still part of the same object, I'm going to apply material IDs to the road so that later we can make them, we can detach them, but later put them back to the same object for some unique modeling things we're going to do to it, and then quickly select those faces by using the select by ID element. So it's a good idea just to set IDs up for any portion of your shape that you think you might want to separate later.
Okay, very, very good then. All right, and so in this upcoming session, just so that I could move a little more quickly with you guys, what file folders will I need to open?
Okay.
Heads up. I'll get them open now.
We're going to stay in the same folder that we have been in. We're going to stay in this 03-walls. We're going to stay in 3S Max-01, and we're going to stay in 03-walls.
In the building, a 4-story house, or are we going to move to another building?
We're going to move into some different. We're going to look at a few different files in here, but the next one we're going to do is inside Marco Island Medical. So we're going to go in here next.
Okay. All right.
All right.
So at least I have a heads up. I can set a little window on my screen.
Okay.
Okay.
All right. I'm going to go ahead.
So yay, very good so far, Brian.
Thanks. All right, I'll go ahead and mute your microphone or your phone. Rachel, I'm unmuting your microphone. Did you have a question?
Yes. Well, first of all, I'm not Rachel. I'm
Oh,
sold. My wife signed me up for the class.
I'm sorry.
It's no problem. You couldn't know. I'm just wondering, when I detach polygons or faces from an object, it does keep the material ID, right?
When you detach faces from an object, yes, it does keep the same material ID. So, yes.
Do you later on separate out materials? Like, do you create individual materials for your individual objects, or do you just, because you already created the material that has multiple?
Yes, good point. I always create separate material for a separate object. So I would, at this point, throw material on this object, I would throw material on that object, throw material on this object. And the reason why is, even though they have separate material IDs, even though that I could apply one material to, have all of these be part of one object and have unique material IDs and manipulate one object, I like to have the ability to very precisely control the mapping of these objects. Now, if you tried to map this object while it's attached to this object, while it's attached to this object, there's a lot of problems that induces. One, you have to use map channels, which we'll look at. You have to apply multiple UVW maps to the same object, where you have one material ID set to map channel 1, another material ID set to map channel 2, and so on. So each material ID would get its own UVW map modifier. The problem becomes that's you could work with that. You can make that work, but then when you want to start doing things like unwrap UVW, and you want to split your geometry up so that you can unwrap it, then it's much, much harder to do with one object, and it's just, for so many reasons, it's not a good way to work.
Okay. I actually came across that problem before when I was trying to model a TV, and I struggled a lot getting that to have the right mapping.
Okay.
Do you separate the objects out, but then you group them together later, or how do you keep an object together?
How do I keep an object together? Do I group them later? So let's look at. Well, how about no. I'd rather show you rather than just tell you. But did you have any other questions? Because in the next set of files we will look at, you will actually see that. Do you have any other questions before we?
No, that's it.
Okay. Anybody else have any other questions? I went ahead and muted your microphone. Let me unmute your microphone one more time. What did you say your name was?
Toby.
Toby.
You want me to type it in?
No. Well, I don't know if you can change it, but if you can. No, I thought you meant you were going to change it here in your actual name display.
No, I don't think I can.
Okay, yeah, I don't think you can either. All right, I'll remember that next time. So I just muted your microphone. Let's go ahead and continue on. Okay, let's go into a folder. Well, let's look at the AutoCAD file first instead of looking at the Max file first. If you would, open up a file inside 3ds Max 01, and the folder within that you need to go into is 03-walls. And the file that you're going to be looking at is, you have to go into 3ds Max 01, 03-walls, and then Building B Marco Island Medical. So this should be the path up here that you're looking for. And open up a file called Marco Base. So this particular file is a little more simplistic. There are 4 elevations, obviously, and there's 2 floors, there's a site, and this is the dirty version of the file. This is the one that has all those extra layers that we would delete. So we would go through, we'd select all the dimensions, isolate them, delete them, select all the notes, isolate them, delete them, select all the hatches, and so on. I can close out of this, and then the next one that I want to go into is base 2, Marco base 2. So this just shows the next version of the file where everything is clean and oriented. So we have the site plan over here that's cleaned up a little bit. We have the first floor plan in the center, located at the origin with the 4 elevations wrapped around it. We have a second floor sitting over here for reference if we need to use it. And let's close out of this. Let's close out of this one and open up the last one, which is Marco base 3. So here's the final one. This one is basically the same file. The only difference here is I set up some paths and profiles for the walls, and I also made some copies of the doors and windows. So if I go into Layer Manager, turn all the layers off except for the ones that start with 0 dash. Those are the ones that I created. So I have 4 paths, 4 path layers, a roof layer, and a window layer. This is the line work that I would import into Max. We're going to come back here when we look at roof plans, and we're going to build this roof. But for right now, I want to focus on creating some windows and doors. Real quick look at the lines that make up the walls. These lines here do not yet are not really set for import into Max. Notice that each one of these are separate. They would have to be closed polylines. So I would have to use the pedit command to join all these polylines together. Okay. Let's look at one of these windows over here. This window right here, or this line work, I should say, this line work right here is the line work that's needed to create the window that you saw in the previous file, the one that is sitting right here. So all you would need to do is select one of these windows, make a copy of it, and place that copy somewhere down at the bottom, and then either use the line work that's here or trace the line work that you have to work with. Now this line work is not completely usable as is. First of all, what are we seeing? We're seeing a windowsill, and we could look at a window section to see the cross-section of this windowsill if we wanted to be really careful and ensure that we're creating it just correctly. And we see a trim feature here where we see these light lines that to me indicate that there's some curvature applied to this. And in fact there is. And if you look at the window section, you would see the curvature, and I'll show you in a minute what it looks like. But we also have these window mullions. Importing these lines like this into Max wouldn't do you any good. You have to create an offset and some thickness to these lines to have them be usable inside Max. So starting, this is the process that I would go through to create these windows. And if you can imagine all these windows lined up, all the different window types, all the different door types, I would do this all at once. So to start with, I would go into Layer Manager, and I would create a new layer. I would create a new layer, and I would call it 0 dash, let's call it frames 1. Let's give it a color blue. Let's create another layer, call it 0 dash frames 2. Give it another layer or another color, call it, let's make it red. And let's do another layer, 0 dash frames 3. And give it a color purple. Okay, so we got 3 frame layers, and the reason why I created 3 is because I'm going to have 3 separate objects making up the frame. Because if you look closely here, if you want to be really precise, and I always like to show whatever details in the architectural drawings, because if it's worth putting in the architectural drawings, if it's a big enough detail to see in your elevations, chances are it's a big enough detail that you need to model. But if I want to be really accurate here, this area here represents the outer portion of the window frame, the outermost window frame that sits just inside the masonry opening. This portion here is a thicker part that is going to be not as wide, not in terms of depth into the window. It's not going to be as wide, but it's thicker in terms of how we see it in the elevation. And this will be the third part here, which will also be part of the mullion. So the mullions, if you can imagine the thickness of the mullion running down here into this would all be one solid piece, all of this mullion here. So we want to create 3 separate parts to the window frame. So how do we do it? Let's start by offsetting these lines that represent the windows, and you can watch, you can follow along if you want to try. But I have to do this at some decent amount of speed, so I would suggest just watching this unless you are really good with AutoCAD and you want to try to keep up. So I'm just want to create a, whoops, that didn't work. Let's undo that. I want to create an offset, and when I'm looking at this, if I see my thickness down here at a certain amount, I want to keep that same amount for the window mullions. So if I do a distance measure, if I type in DIST and do a distance measure from that point to that point, and look at the change along the y-axis, the change along the y-axis is this amount here, 1/2 inch. So it's a 1/2 inch thick mullion here. So chances are I should probably have 1/2 inch thickness in mullion right here. So I need to offset both of these lines 1/4 inch. So I type in O for offset, 0.25 for my thickness. I click on the line, offset it to that side, click it over here, offset it to that side. I repeat the command over here. I repeat it over here. And finally over here. Now I've got my window mullions. And now it's very simple to create the line work that I need inside Max. I need to go to OSnap to turn on snaps for just my intersection, this right here, because I want to do, well, actually endpoint and intersection, because I want to snap from that point right there, which is the intersection of 2 lines, to the point that you see right there, which is the endpoint of some lines. So let's create a rectangle. I'm not sure what there it is, REC for rectangle. I can draw a rectangle from there to there, hit the space bar, execute the command again, type it from there to there. AutoCAD's great because you can just type in, you can just hit the space bar to execute the command over and over again. You can very quickly draw these frames that you need. So there I've got the inside lines to create those window frames. Now if I extruded these 6 or these 8 different squares or rectangles, I would have 8 big blocks, and I don't want that. But if I create another rectangle from there to there, when I extrude all these blue lines that you see, they're going to lead, all that's going to be renderable is the mullions, and the space in between is going to be empty. So that's going to be one set of line work that I import. That is going to be one part of this. The next part of this, and I would need to make copies of this, I would need to bring this over onto this side, and it would just be a matter of copying all these lines, selecting them, isolating them, copying them over here, and that's how I would do that side of the window. I'll just continue on. I've got a layer called frames 2, 0-frames 2. I can double click that layer to activate that. So now anything I draw will be on 0-frames 2 and the color will be red. So I need to draw the next window frame. I'll draw a rectangle from that point there to that point right there, and I need to draw another rectangle from that point to that point. So now these 2 red lines are going to be my next part of the window frame, and that's going to be just on the outside of the mullions. And then the final one that I need to create is for 0- frames, and let's change the name of this. Okay, 0- frames. That'll be the third frame layer, so I need to set that as my current layer. Type in REC for rectangle, click there to right there, and then do it again from right there to right there. So now I've got 3 objects, or I will have 3 objects when I import this into Max. I will have the purple lines that are right here, the red lines that are right here, and the blue lines for my mullions right here. Now that line work is ready to import into Max. I would also need to create if I want to create this windowsill and this trim feature here, the best way I can do it is by creating 2 different lofts. So I would loft the shape of this window trim feature around the masonry opening of this window, and then I would create another loft that starts at the masonry, moves out, and then over, and then back into the wall. So that would be another separate loft. So at this point, let's build the windowsill. I would need to have a proper shape for this windowsill. So I'm going to draw a polyline from, let's say, this point right here. Let's just go down. Oh, I need to create a separate layer for this, by the way. So I need to create a layer and have it called 0- trim. Let's call it 0- trim 1 because there'll be 2 trim features. And let's set this to the current layer and make this a different color. Let's make this blue. Okay, so now we got a blue layer called 0- trim, 0- trim 1. And let's delete that line and recreate it. So now we got a blue line. And let's do a fillet from that point to that point, a fillet from that point to that point. And now I can use this. Well, I got to do a couple more here. I can delete these lines. So that will be my polyline. And I need to use the poly edit command, the P edit command, to select all of these lines. And notice down here, capital M under the select polyline feature allows me to type in M so that I can select multiple lines. So all these lines I select will be part of my poly edit. Hit enter to finish selecting. And now it says, do you want to convert arcs, lines, splines to polylines? I hit enter for yes. And then notice the capital J here, which indicates if I type in J, I can join those polylines. So I type J and enter. Fuzz distance, that simply means that any endpoints that are within a certain distance will be welded together. I only want endpoints that are exactly on top of each other, so I'll leave the fuzz distance at 0. So I hit enter to accept that, and there's my line. It got placed on the wrong layer, so I can quickly change that. And let's go to, I'm not as familiar with 2011 on this. I'm sorry? Right-click properties, yep, quick properties, or properties, there you go. So select the layer that you want to change. Whoops, that's not the right ones. Select the layer you want to change it to, and it should be on trim 1. Yep. Okay. I used to be an AutoCAD whiz before I was forced to start working on 2011. Okay. So that shape, when lofted around a path that begins here, goes out and over, and then back in, will produce the windowsill that we need. We don't need to create the shape right now. I could draw a shape and actually make it something like, I could draw a shape from, say, like right here, down, and then over, and then up, and then go into Max, and then rotate that and manipulate it, but that's too much work. There's an easy way to do it inside Max, and I'll hold off on that right now. And I would use the same, I would also need to do the same thing for this trim feature up here. I would have to have a layer for it. So let's create a new layer, call it 0- trim 2. Give it a layer color like yellow. Make that the current layer. And let's draw a polyline from on the outside of the masonry opening, beginning right here Let's move it up to the other corner of the masonry opening, and let's put the other corner right there. And then the last one will be right there. So that is the line that I just created. I don't need to have a full, complete closed spline. A closed spline is not necessary because I'm only going up, over, and down the other side. Okay, so that is the two trim features. I've got the frames done, and I've got the trim features done. Now I need one for the boolean that I'm going to use to subtract from the wall. So I have to create a layer, and I need to call it 0, 0 dash boolean. And this is the layer that's going to be subtracted away from my wall. So let's give it a color of light green. Activate that layer. I'm going to create a rectangle from that point right there to that point right there. That is going to be my boolean. If I extrude that green line and push it through the wall and do a boolean, which we'll look at shortly, then I will be able to create the window opening that I need to place the rest of the objects in. And the last thing I need is a layer for my glass. So let's create a layer, call it 0 dash glass, give it a color, activate it, and let's create another rectangle. And the glass only needs to be seen in the opening space that you see here, but instead of having a separate rectangle for each one of these, it's a lot easier to just draw a rectangle from one corner of the inside frame to the other. So I've got this blue rectangle that spans the entire width of all these mullions. In real life, you wouldn't have glass that cuts through all this area here, or I guess you could if they were trim features, but that's all I need. The glass will show up in all these openings here. So once that's all done, which it is already in the other file, I am left with something like this. I have my trim feature. I guess I went ahead and added this spline right here, but I really didn't need to create this spline here. In fact, I'm going to go ahead and delete this and create it a different way. I have the frames, the objects that represent the frames. I have, let's start separating these to see what we have. Here's one object. There's another object, and these are all separate objects here. Okay. For whatever reason, when this was done the first time, there weren't separate layers created for each window feature. So I can use another technique, which I used to do, but not now. Now I create a separate layer for each component of the window frame, but this is fine. I'm going to have no problem making this work. So the line work that I want to import is this right here. And if you haven't been able to follow along with AutoCAD, or if you didn't want to follow along but now want to actually build this model inside Max, you can follow along from this point here. So you would need to go into this file, Marco-base3, and create a W block of this line work that you see here. So you would have to create a W block of this line work, and I would suggest deleting this green spline down here because there's a better way to make this windowsill than using that line. So this is the line work that you need to bring in. It's in Marco-base3. Does anybody have any questions at this point? Anybody not able to follow along? Anybody need me to demonstrate something again? If it's such a simple piece of geometry, why not make a plane in Max? Good question. If this glass feature is such a simple piece of geometry, why not make a plane? Couple things, a couple of reasons. One, you're already creating the line work here. You're already creating the line work that you need for the frames, for the mullions, for the boolean, and all that stuff. And if you're going to create it here, may as well take that one extra step to create the rectangle that you can avoid having to create in Max. I am not going to say that there's a right way and a wrong way to do this. I'm not going to say that you should do it and you should create this line work in AutoCAD or you should create it in Max. And frankly, many times they're created in Max. all this work that I'm doing here, all this tracing and stuff, can be done in Max. I can import the original line work that represented the window, the line work you saw a minute ago. I can import that and do all the same stuff in Max. And it's going to give you the exact same model. All that's important is that you create the precise number of vertices that you want. So when you create a rectangle, you should only have 4 vertices. That's what's really important. As long as you create the correct line work either here or in Max, that's all that matters. So I can decide to just bring this in Max and create all the models in Max. In fact, let's go ahead and do that. Let's create this. We've got the line work created. Let's use what we can inside Max. Let's create some other components inside Max. So the line work is selected. Type in wblock to execute the wblock command. Create a file. Let's call it window. I'm going to call mine window. Oops. Let me try that again. Select all the lines. wblock. Give it a name here called window. And everything else is set correctly. Say OK. It just created the wblock. Now we can go inside Max and create that window. I'm sorry? In the source where it says entire, okay, all I did is I selected the objects first. You can select the objects first, or you can type in the command wblock and click on, well, I guess you have to select the objects first because it's telling you, okay, there we go, select objects. So I can click that icon for select objects. There we go. I can click that icon and select them after I do the command, or I can select them first and then enter the command. Let's go ahead and reset Max. And we're just going to import that line work and build that line work. And then once we get it up to a certain point where we feel comfortable, I'm going to show you the final completed model and all the steps in between inside Max, because the files are already prepared inside Max. Let's import that line work. We know that when we import line work, we need to import the legacy AutoCAD file type. So make sure legacy AutoCAD is selected and load the wblock file that you created. The only option you need to consider is convert to single objects. I don't want to convert to single objects. All of those different unique objects that were part of the same layer, I don't want to be single objects. So I leave that off and select OK. And I want to switch to user view or orthographic view so I can zoom in nice and easy. So go ahead and zoom in. Turn off the home grid if you don't like seeing that home grid. Now this object is sitting in, this object is parallel with the home grid, but the window needs to be up, it needs to be rotated upright in order to see it properly. If you were to just select all these individual objects, and you can see that they're individual objects because inside the select from scene dialog box there's all these individual objects. If you were to select all these objects and try to rotate them, you run the risk of doing two things. One, the pivot point is way over here, and it's sort of hard to see it. It's sort of hard to see that axis, that pivot point. But when you rotate this, you run the risk of rotating objects separately from each other. And just as a matter of habit, I recommend doing this as a matter of habit, not necessarily because it'll fix this particular problem. But I like to select all these objects and just click Group to group them together into one object, just temporarily and just for a second, so that there's no possibility of the lines separating from each other if they're on a different axis or on a different plane. There's no possible way for them to separate. If any of these lines were even just a small part off of the same plane, then that would be a problem when you start to rotate. So let's just go ahead and rotate this. And just like before, there's something that's causing this object to appear to be bigger than what it really is. This group to appear bigger than what it is. There's nothing out here. There's no polygons. The only thing I can think of is that there's some sort of local grid axis or gizmo or some sort of coordinate system that is tied to the origin, which is what this area is up here. So for whatever reason, the bounding box is much larger than what it really is. All I want to do is rotate this 90 degrees about the x-axis. The x-axis is running this direction, so I need to rotate the windows 90 degrees about the x-axis. The easiest way to do that is to either right-click on top of the rotate transform or type in 90 degrees right here under the x-axis down here at the bottom of the screen. If I type in 90, or I can click and drag up to see this rotation occur. If I type in 90 or just move it to 90, there we go. And it doesn't matter where this is physically in my drawing right now. That doesn't matter. All I care right now is about modeling this window properly. So if we're in orthographic view and we just rotated this 90 degrees, we need to switch to front view to see this window properly. So I grouped it. Let's go ahead and ungroup it. Now we could use this line work that we had before, that we brought in from AutoCAD, but you asked why not just build your models in Max? Why not just create that glass inside Max? Well, let's just go ahead and do that. Let's go ahead and create this inside Max. There's no right or wrong way. To do this, we need to create a bunch of shapes. We need to do the exact same thing that we did in AutoCAD. Let's turn on snap mode. We have snaps set to endpoint so that we can snap to the endpoints nice and easy. And let's create a bunch of rectangles. Let's do a rectangle from there to there, a rectangle from there to there, and keep going, rectangle from there to there. Create all these rectangles. I can quickly knock these out too. And I also need a rectangle on the outside of this inside window frame. But I'm going to have trouble snapping up to this, so let's delete that. Let's delete this and move this up ever so slightly. Let's zoom in so we maximize this. Oops. Zoom. Trying to zoom in just right here. My screen real estate is pretty small because I'm working on a low resolution because of this particular screen that I'm on, because I'm projecting online and with a projector. I need one more rectangle from that point right there to that point right there. That snapped to the wrong point. Right there to right there. Okay, I've got all my rectangles for my first frame, and I've got one rectangle selected so I can attach all the others to it. I do the attach command with either the edit mesh or edit poly modifier. So I add the edit mesh modifier. Oops. I can't add the edit mesh modifier. If I want to attach a spline to another spline, I have to add the edit spline modifier and attach the other splines to it with the edit spline. If I were to just edit mesh like I just did, you would see that I'm going to turn that rectangle into a plane. I can click attach multiple and look for all the rectangles that I just created. There are all the rectangles I created, and attach them, and there is one object right there. If I were to extrude that object, you would see that it has some depth and it's created properly. I always extrude components of a door or window the same amount that the object is thick. You know that the mullions are ½ an inch thick. That's what we notice in AutoCAD. So if the mullions are ½ an inch thick, unless I want to reference the architectural sections or figure out exactly what thickness this is, the best and safest bet is just to set this to the same thickness as the mullions. So I'm going to type in 0.5 for my thickness, If I zoom in closely, I will notice that the thickness is the same as the cross-section of the moldings are 1/2 inch all the way around. Okay. Next, I would have to do the glass the same way. I would have to do the bowling the same way. And let's put this glass or this frame back in here, extrude it 1/2 inch one more time. And I would go through this process of, 0.5. I would go through this process of creating each frame component, creating my glass, creating my frame, and the tricky part would be the trim features. So if you haven't been able to follow along, what I'd like you to do is go into another file. It's already finished. It's already prepared. It's under the 3ds Max 01 folder, 03-walls, and the folder that this project is from is Building B Marco Island Medical. There's 5 different versions of this file, and it shows you what it looks like along the creation process. So if you would open up Medical Center 02 and take a look at what you have in this file. This file has all the different window types already prepared, and they're sitting in, you can see them in top view, and they're lined up inside top view. And I'm going to maximize this view to get a better look at what's going on here. So the window that I was creating is this window right here. If I look at this in shaded view, I see a few different things. I see an object right here that represents the boolean that I'm going to subtract from the window. I see the trim feature here that wraps around it, and I see the windowsill here. This is a group, and it's a group because I wanted to place this window all around my building, and notice these green lines here. These green lines are imported from AutoCAD. They are lines that I drew inside AutoCAD at the midpoint of the windows that I created. They are lines drawn in AutoCAD wherever my windows occurred, and I can see where the windows are by turning on the layers. If I was to draw a line from my elevation projected up to my floor plan, I could then import that line because I can see that it shows me where that window occurs on the floor plan. I can quickly draw a line for each window, import that line into Max, and then do an alignment so that each one of these groups is aligned to the line that I've imported. And it's a very quick, easy way to make this group be copied around the building. Okay, we're going to break here, and when we come back, we're going to finish modeling this window. We're going to create the loft for this windowsill. We're going to create the loft for the trim feature. We're going to look at we're going to take this group and we're going to position it around the building a little bit. Right now, these windows are already positioned around the building, but we're going to manually do that ourselves. So let's go ahead and stop right here, and we're going to break for 1 hour. And when we come back, we'll finish working on windows and doors, and then we'll move into roofs. Before we break, does anybody have any questions about anything that we've covered up to this point? Anything that you have a question about? Okay, I'll go ahead and unmute your phone. Go ahead, Toby.
I was just wondering if you use the boundary command in AutoCAD at all, or if you always use the rectangles. I feel like the boundary is a very quick and easy way to create those windows.
The boundary command? I've never heard that before. I type in boundary?
You type in boundary and you just click within a geometry and it automatically outlines.
Okay.
It creates a new polyline along the outline.
Nope, I've never heard of that before. So that's just creating a rectangle right where. Okay, I've never seen that before.
Yeah, whatever outline you have, you click within it, and it creates a new polygon.
That's fine, but unfortunately, when you get to when I'm doing this, here's sort of what I do. I create a rectangle, snap. Create a rectangle, snap, and you know I don't have the offsets already set up. Create a rectangle, snap, create a rectangle, snap. And when you get to a point like where you have to create this frame, you know, you'd have to have a separate element here. If you were to do what you're saying, you would have one rectangle there, which I guess is fine. But then when you're trying to create something like the glass, that method you're saying won't work, so you'd have to create a rectangle there. So yeah, that's cool. I mean,
I understand that. It's just you know, when you're creating your mullions, it's instead of having to click 64 times because you have to click twice for each rectangle, you just click 32 times because you just click inside your rectangles.
I'm all for speeding up things, so that's really cool. So am I able to create multiple at the same time? So how do I do this? I hit OK.
Hit OK and just click multiple times.
Oh, cool. Look at that. That is sweet. That is sweet. Thank you. Boy, you learn something every time. That's really cool. That's why it's really great when there's whenever we do these classes, the optimal class size seems to be around 15. Right now we have 5 online, 3 in class here, and that's about half the size that it really should be, because when you start getting about 15 people, somebody always seems to have a way of doing something that is a little bit better or can speed things up. So yeah, thank you for that.
Oh, no problem.
So I'll go ahead and mute your microphone. Anybody else have any questions or comments before we take a break? Okay. So let's go ahead and take a break, and we'll be back in 1 hour. Okay, so let's pick up where we left off. I have a few more minutes I want to spend on showing this particular scene we're in, working on some windows. So here is the completed product, and I want to ungroup this. This is a group. I want to ungroup this to sort of analyze this a little bit closer, to break this down a little bit more, to see what's going on. If I go to the group menu and select ungroup, I can move this boolean away, and this object is a 2-foot or 24-inch extrusion. It's simply a rectangle with an extrusion, and as long as this is pushed through a wall, and as long as that wall is not more than 2 feet wide, when you do a boolean, or I should say pro boolean, when you do a pro boolean, which we'll do in a few minutes, when you do a pro boolean on this, you'll be left with this, and this will be positioned wherever you have it in your building. So the part that I want to just quickly create right now are these 2 elements here. This is the windowsill, and this is the trim feature. Okay, so I'm going to go out and go into a different file, and this file that we're in is Medical Center 02. If I go into Medical Center 01, I will see something similar but slightly different. I will see this profile and this path that was used to create this object. But I want to show you a little bit easier way to do this rather than lofting with this line that you bring inside from AutoCAD. I'm going to delete this. I don't need that loft right now. But I have already this loft created. I want to create the loft that represents the windowsill. So here's a quick, easy way to do it. Once you have this created, which we already had the line for this loft is nothing more than the masonry opening and the profile that you see right here. I can change the color of that and make it a little bit easier to see. So that profile with a pivot point set right here, lofted around a line, the masonry opening that represented the line that represents the masonry opening. When you loft that shape around that path, you will get that object. Once you have that object created, you can create a path for the second loft by snapping a line, turning on snaps, creating a line from that point to that point to that point right there. And unfortunately you can't see it because the backside of that object was not visible, but you can create another line from right there to right there. Or to make it even easier, to make this a little bit easier to see, you can create a line from there to there using the outside of the window frame. So there's your spline. And now you can just move this spline outward and loft that shape along that path. And after the loft is created, you can just modify the path as necessary, or you can modify the path right now. If I want to make this path a little bit wider and have it stretch out a little bit farther, I can either use the scale, or even better yet, take this set of vertices, move it out a little bit farther. I can see that green line that represents where I want that path to exist. It doesn't have to be exact, but just move it out a little bit farther. And now use the loft command to loft that shape around that path. So I go to Create Compound Objects, Loft, Get Shape, and click on the shape. The shape is not going in the right direction. This is the tricky part. The shape is not going in the right direction. Anytime you create a shape like this, or a loft, and the shape is not oriented correctly, and this happens a lot if you try to create furniture, if you try to create window treatments or molding on a ceiling, crown molding, it's pretty simple to fix. All you got to do is go into the loft, into the open the loft, I should say. Anytime you see a plus sign in the modifier stack, you can go into this, and you can modify the shape and how the shape is oriented right here inside the loft. If I go into wireframe and do a window selection around this whole thing, I will see the shape highlight right here. So this is where it starts. Now notice that the shape is oriented in such a way that it is the x-axis runs this way, the z-axis runs this way, so the shape is flat against this surface right here. If I want to change the orientation of this loft, I got to rotate that shape. And I should probably do it inside the Select and Rotate dialog box, so I can manually type in an exact amount to rotate this. I want to rotate it about not that axis. Whoops. There we go. I want to rotate it, I believe, around the, nope, that didn't do it either. Let's try one more time. It's usually very easy to do this. Alrighty, that's not working. I got to rotate the shape so that it is coming out, so that is, actually I think I know what's wrong. The shape is going in the wrong direction. The shape is pointed inward. I have to point it outward, and then if I need to rotate it, I can, but I can't rotate it right now because the loft is going in the wrong direction. So what do? I hold down Control, click on the shape again, and apparently that's all I needed to do in the first place. So the shape was just pointed in on itself. Anytime you create a loft, you need to add a smooth modifier to get rid of the facets on straight ends, facets on the straight sections, and clean up the curves where there are curves. If I move this around a little bit and analyze what's going on, I can see I have far too many vertices, and just like before, we need to drop the number of shape steps and path steps and let the shape of the object define its structure. So I can change that right now. I can change the the object and add vertices, but I think we already have enough vertices. This was already done. This segment was divided already. Also, notice the extra vertex right there. We don't need that extra vertex. I can delete that. That would clean up the model just a little bit. So here's the finished clean model. I have to engage auto smooth on the smooth modifier, because if I don't, I will have those facets show up. So after all these elements are created, you just simply need to look in top view, position them correctly in top view, and if this object represents the object that's being placed on the window or on the wall, if you know that that surface right there, the top side of this object, is going to be flush with the wall, the easiest way that I've found to make all these elements match up is to place that portion of the object right in the center of the window, move it down 4 inches, use the move transform, move it down 4 inches along the y-axis. So now it will be flush with the outside of the wall, because if you're dealing with an 8-inch wall and you just move it down 4 inches, now it will be flush on the outside of the wall. And so now this line that represents the inside of the windowsill has to be at least that far in. So now that line represents where the trim feature is going to be flush on the window, and as long as this line is farther in, then you won't have any gap created between the wall and this windowsill. Once you're done creating all these elements, all you need to do is, you don't need the shape, of course, all you need to do is delete the extraneous objects and extraneous shapes that you used or that you created. Create a group, call it something, window A, and then using the line work that you bring in from AutoCAD, align this to some line that you import, align it, set it flush so that it matches so that the back side of this trim feature matches the window right there. Move it up. And you would need to look in the AutoCAD file to figure out what distance above the ground the bottom of the sill is. So if I did a distance measure from that point to that point, I see that the bottom of the windowsill is 1 foot 10 inches above the ground. Switching to front view, if I move the bottom of this windowsill 1 feet 10 inches, if I move the bottom of the windowsill flush with the ground and then move it up 1 foot 10 inches, now I have this object created in the exact proper way. And I can do a little more work to clean up how this element here intersects with the window. But when I do a Boolean and cut this mass out of the window, it'd be a lot easier dealing with that problem then. I just don't want to make this window treatment here not be visible. So this part of the green object would be cut away. So looking at the completed model, or at least the model that has these windows completed, this is Medical Center 4. And this is what it looks like. I guess all we did here is move this out a little bit farther so that it goes beyond the width of this trim feature on the wall. So the trim feature was just the vertices that make up the back of this trim feature were just pushed back a little bit. Whenever you're trying to subtract a volume from a window volume or a door volume away from a wall, use the Pro Boolean feature. If you use the Boolean feature, you will run into a couple problems. If you just did a straight boolean on this without subdividing your wall model, chances are you're going to have some erratic things happen to your model. Booleans do not like long, skinny faces, and as such, you will have some incorrect cuts using the boolean command unless you subdivide your mesh to reduce those really long, skinny triangles or long, skinny faces that get created automatically when you do the boolean. When you use the pro boolean, what happens is that Max subdivides your geometry, creates the boolean, and then reorganizes the edges for you. You never see it, but that's what happens. So if I go into Medical Center 03, I see I already have all these green boxes that represent where the windows are going to be cut. Let's turn on faceted mode. And in order to cut these windows out from this wall, I want to use the pro boolean feature. Right now, there would be too many long, skinny faces created if I use the boolean feature. So I go to Create Geometry Compound Objects, Pro Boolean, Start Picking, and just click the one set of objects. All those green boxes were one object. And there's my window voids. Turn everything back on, and now I've got my windows positioned properly. Does anybody have any questions about the methodology and the process of creating windows and doors? Whether you build your line work in Max, build it in AutoCAD, whether you use the methods I point out or not, this is the same kind of approach that most visualization artists use unless they already have a imported model from BIM software like Revit or something else. This is the most widely used, most widely accepted way of creating doors and windows. Will I ever attempt to modify one of the windows that Max provides? No. Inside the Create Geometry drop-down list, there's a standard primitives. There's a AEC extended section, and in this section you can see walls, and you can create walls pretty simply, pretty easily. And somewhere in here there is windows. Where are they? Windows right there. I can drop in windows. This is not at all, even remotely, a good way to build windows. This is there's just no variety to it. You do not have enough customization for these objects. I would never use these windows. I don't recommend ever using any of these things here. It's just not a good idea. Do I instance windows? Good question. Yes and no. If I go back into a different file, let's go back into this file right here. If I go back into the same file, notice that these green objects, the boxes, are all one object. If I go back into the previous file, right here, I will see that they are individual objects. They are individual objects that used to be groups. They're not groups now, but they used to be. And when these objects were being placed around the scene, when this group was being placed around the scene, the way it was done is you hold down the Shift key, drag to make some copies, and you can make additional copies, and then you place these copies wherever the lines are on your floor plan. But you should make these as instances, because if for whatever reason you get all these windows into place and then something on the windows changes, if you don't have a version of the scene that is saved as an instance, you have to go through this process of deleting all the windows, fixing the one that needs to be changed, and then recopy it into place. So if you do it the right way, hold down Shift, let go, and create an instance, now when you update one, the other updates. And you save a version of this before you do the next process, which is ungroup them and attach all these objects together, all the Boolean objects together, and do your Boolean. So you create all your windows as instances, place them around your scene, save that file, and then save another version of it and continue working from there. So if you ever have to go back to a point where you can change one window and have them all update, you can do that very easily. So yes, that's a good question. Anybody else? Okay, somebody's got a question. For window mullions, would you consider using the line drawing, converting to a spline, and then sweeping the mullion cross-section? For window mullions, would you consider using the line drawing, converting to a spline, and then sweeping? I'm going to unmute your microphone, Donald. I'm not sure I understand what you're saying. Can you explain that question again?
Yeah, in the AutoCAD drawing, we had the mullions, or with the insides of the window frames.
Okay.
That's what I'm talking about, is the vertical and horizontal lines that make up the insides of the individual panes of glass.
But what's your question again?
Okay, if you copy those, or however and then convert it into a spline, and then create a cross-section of the mullion, you can use a sweep command, I guess, to make those interior.
Okay. Yes. Would I use a cross-section? And by the way, I'm repeating your command because the people in class can't hear. So if I had a window mullion that warranted it, that wasn't something as simple as a square cross-section, would I use the sweep modifier or something else to create that intricate geometry? Yes. The way that I showed was the easiest way, because these windows didn't require that level of detail. And I could look at the sections. Well, this doesn't have it, but I could look at the section drawings of a window, and if that window is going to be seen close enough, if you're going to see that detail, and there is some fine details to that window mullion, then yes, that would be the sweep modifier would be a good option. No, you won't. Someone's asking if you have two window mullions, one going one direction, the other going another direction. You're saying, will it create artifacts? If they're the exact same height, but that's a simple fix. You just don't make them the exact same height. Yep. Well, you can use a different shape for each sweep. What someone is asking is if you sweep one set of lines and then sweep another set of lines using the same cross section, they're going to occupy the same space. Actually, I'm not sure if I actually don't know if this is possible. So I'm going to do a quick test. If you do a line from here to here, and then do another line from here to here, and then attach these two lines together, and then do a rectangle shape over here that you sweep along this object, I am not sure if I think it's going to create a proper cross-section meet. I'm not sure, but I'll find out in a second. I'm going to add the sweep modifier to this X and see how it handles this. Yep. So it knows how to create. No problem. Yeah. And you're talking about an area, in most cases, an area that's like half an inch. Even if you did see something, you'd have to be really close to see it. So yeah, it knows how to handle this properly. So there's no overlapping faces, I believe, here. And what's so cool about this sweep is I can use this show end result here to show the end result of having the sweep modifier applied to the line, and I can manipulate the individual vertices and see it update the sweep in real time. That's pretty cool. Okay. Let's see. Anybody else have any other questions? Okay. Let's go ahead and move on. Next, we're going to discuss roofs. And this one will probably only take about 45 minutes. And at the top of the hour, I'm going to hand the computer over to, I'm going to hand over the webinar to somebody else who's going to be demonstrating the advanced modeling, using creating some furniture, and using advanced poly modeling techniques to do it. Go into a file, Building C Preserve Clubhouse, Building C Preserve Clubhouse, and base 02. Here we see sort of the same approach where we have a floor plan, a second floor plan off to the side, elevations wrapped around. We have some lines that we're using for lofts. And let's see if there's a roof plan in here. Let's go to Layer Manager, turn everything on, and no roof plan in this either. Oh, there we go. There's the roof plan. This roof plan is a little more complex, and I'm not sure this would be a good idea to show this. I don't know why the roof plan was taken out of that last set of files. So here's what we're going to do. Change of plans. Let's go one more time back in. I'm sorry to spin your wheels like this. Let's go back one more time into the Marco Island Medical base 3 file. And we're going to just duplicate the work that's in there. Marco Island, or Marco base 3. I already have this file open, so I got to close this out. Go back in here. Okay, this is the file that we're going to work in. So what was done on this project, I assume, is that since there was no roof plan placed in here, a roof plan was quickly fabricated for the purpose of building this 3D model based off of the elevations. And creating a roof plan for this is about as easy as it can get. It doesn't get much easier in this. So what we're going to create is a series of polylines, closed polylines that we're going to import into Max, turn into an edit mesh, and adjust the vertices of to certain heights. So we're going to create a bunch of closed rectangles and import them into Max, elevate them up to a certain height, and then adjust the ridge lines as necessary. So we would need to create a new layer. This one is already created, 0-roofs. And we would simply go around and use the polyline command to trace some polylines inside Autocad to create this roof. Now you could, again, just like the windows and doors, you can do this inside Max. You can just click and click, 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 and create your polylines here in Autocad, or you can create them in Max. It really doesn't matter. But the idea is that you create a bunch of closed splines like this right here, import that into Max, turn it into an edit mesh, and then adjust the vertices at the top of the roof, the vertices at the ridge. Okay? Whenever you have the opportunity to mirror some parts, you can use the mirror tool to quickly build other parts of the roof. I think for the most part we can just import this in, but just to be a little bit more accurate, what I want to do is create this roof over here, the roof for this elevation that is currently not shown. So I can just project. I first need to set the layer to the same layer that the rest of the roof is on. So I'm going to set my layer to 0-roofs and draw a line up from the endpoint of the roof defined by the the roof defined by this blue line. And I can project from this point on that elevation over here to start my roof. Now all roofs are going to have these all hip roofs, and this is a hip roof because it comes down at an angle from the center, comes down, as opposed to being a gable, which is going to have a type of roof where it doesn't slope down on the front side towards the side of the building here. We know that we need to draw a 45-degree angle from that point outward. So I can quickly draw a line from that point to right there. Well, this is just not working here. Yep, this is not working. Let's not worry about that. This AutoCAD version is just not behaving very well. So we're going to just go ahead and import this line work into Max as is. So what you would need to do is select all this line work, so you can isolate this layer, lay ISO, select just this line work on the layer that you have isolated, and create a W block. Save this to your desktop. Let's call this roof. And I just created a file on my desktop that has just the line work in it that you see right here. Just this line work. That's all you need to import into Max. So select and isolate those lines, create a W block, put it on your desktop, and let's bring that line work in. Okay, let's open up the file called Medical Center 02. Building B, Marco Island Medical, Medical Center 02. Okay, and what I would like you to do, if you want to follow along, is delete the roofs that are currently in there, and let's recreate them from scratch. Delete those roofs that are in there, and let's recreate them from scratch. So you delete the roof, and then import that line work using the same process we looked at before. Let's import the file called roof. It doesn't matter right now if you convert to single objects or not. I am going to choose to convert to single objects because I want the entire set of line work on that roof layer to be brought in and be part of one object. Now if you look closely and isolate this layer, it looks like one of the lines or two parts of the polyline were not put in at the right elevation. Inside the AutoCAD drawing, you can't see it, but some of these lines were given a certain elevation and some were not. If I right-click and go to the properties, I can see the elevation as defined right here. You can set up the elevation of the line here inside AutoCAD. I would actually recommend leaving it at an elevation of 0 and setting that up inside Max. But regardless, we're just simply going to use the building walls to best place these lines. I'm going to isolate the walls and I'm going to isolate the roof layer. So this is all I need to do this. This is all I need to build these walls. I've got the lines set up and I want to snap these two lines down here, these two polylines that did not go to the right elevation, and I need to bring them up to the proper elevation. So I need to get them aligned with the other roof lines, so I snap them to the other set of roof lines like this. I just took those two polylines that were down at an elevation of 0 and snapped them up to the lines that were at the correct elevation. If I look at the AutoCAD elevation, I can do a quick distance measure. Let's lay un-ISO. I can do a quick elevation or a distance measure from the ground to where the roof is right here. I do a distance measure from any point along the ground to any point along where the bottom part of the roof is. I see it is in fact 24 inches or 24 feet 3 inches off the ground. It's 24 feet 3 inches off the ground. I could also just come into my elevation or come into my side view and set it properly there. But I want to be exact, and I want to drop this set of line work down to the ground level and then elevate it up 24 feet 3 inches. Using my transform type in, I can type in 24 feet 3 inches, move it up. So that roof line that defines the main roof is at the proper elevation. That roof is now at the proper elevation. The main roof is at the proper elevation. And I can check to see what the difference between the main roof and the secondary roof is. So do a distance measure from the first main roof to the second roof. It says 5 feet 3 inches. So I know that that secondary roof has got to be 5 foot 3 inches off the primary roof. So I can select those splines, move them down to match the main roof, and then move them up 5 foot 3 inches. 5 foot 3 inches. Now I know all sets of lines are created at the proper elevation. We have a line that defines the main roof and a few lines that define the secondary roof. And all that's left to be done is edit mesh. And it doesn't look like much, but we've just added the edit mesh, and I go into faceted mode to turn on the edges, and I can select each individual vertex and move them up however much I need to create the roof. And I just simply need to refer back to the AutoCAD file to figure out what the height of each roof is. I do a distance measure from the bottom to the top of the roof. It says 5 feet 1 inch. So I simply use the move transform type in to type in 5 feet 1 inch, and now that roof is created properly. And do the same thing with the ridge. Do the same thing with the main ridge. These lines that I imported are individual. They were individual polylines, and because they are separated. These polygons are separate polygons that use their own vertices. These endpoints did not weld, so I can't just click and drag up like that. I have to do a window selection around them and drag up. I'm going to do a distance measure from the bottom of the main roof to the top of the main roof, and I see it's 11 feet from the bottom of the main roof to the top of the main roof. So I need to displace these vertices exactly 11 feet. Oops. Displace them 11 feet. And now my main roof is created at the proper elevation. I can check this in left view, and I can see the lines for the main roof and the secondary roof are parallel, so that's an indication that it worked. Now, if you're wondering why things look weird here, it's because I know that when I built these lines in AutoCAD, I knew that I was just going to have these hip roofs on the side just fuse into the roof of the main roof. I don't care about the fact that in real life, that line wouldn't exist out to there, and that wouldn't exist out to there. I'm not going to see any of those in the 3D world, so I don't care about that. I'm just going to select these lines. I have to make sure that I always use the view coordinate system and not local, so that I use the right axis. I'm just going to push these into the roof, like so. So when I created these lines in AutoCAD, I wasn't concerned about creating them at the right length. It would be a bad idea to try to get this secondary roof to match the main roof. It would be a bad idea to try to get this angle correct and have the lines match like that, because then I run the risk of having a gap show up. I don't want to take that chance. I'm just going to push this inside the main roof, and that's all I care about. Does anybody have any questions at this point about creating the base object on which the tiles will lay? Somebody says, where is the roof temp file to insert if you didn't make a W block? Where is the roof temp file since you didn't make a W block? There is no roof temp file. Unfortunately, you would need to make a W block of this. You could always use, you could actually, as much as I don't like to do it, there's no problem, since there are no curves on this, you could use, in this one rare example, you could use an import and import a specific set of, let me do this again, you could, I want to reset this and show you something here. This would be one rare exception when you can use the AutoCAD legacy file type to insert lines. Use the AutoCAD DWG file type to insert lines that you select by layer. If I go to import and select the Marco base 3 file. I used the wrong file type. Import, AutoCAD drawing, Marco base 3 file type. I can now select by layer and import just those layers that I want, the roof layer. And now just that layer imports. And I just realized as I was doing that I was working in the wrong folder, and this is why the exercise that I was trying to demonstrate was not working. Everything I just did in the last 30 minutes should have been actually done in this folder, 04-roof, so my apologies there. Everything is in this file for you already. So the folder that we should have started in was the same folder that was used in the intermediate book. This is chapter 5 from our intermediate to advanced book, and this file has all the line work created properly, and this temp folder here, this file is where it has the full complete set of line work that you can import. Why don't you, somebody asked, why don't you give the roof thickness? The reason why you don't give the roof thickness is because you won't see any thickness. I want to go into a file with the completed model already done. It's in 3ds Max 01 04-roofs. And the file that I want to use, or the file that I want to open, is chapter 5-03. When you look at this, you'll see this is a different file, but you'll see that the roof sits right on top of the fascia. It sits right on top of the fascia, so there's no need for thickness. This roof is positioned so it's exactly on top of the fascia. It would be pointless to have a thickness in this particular instance. Now, let me just mention about the methodology of this. There's two ways to create roofs using this method. You can trace the line work inside AutoCAD and import it at an elevation of 0, and then use the endpoints of the fascia or the walls or whatever you need to snap to, use the endpoints of the fascia to quickly snap to quickly have a roof snap to the proper endpoint. Every roof plan that you see in AutoCAD, chances are there is going to be some tiny small discrepancy from where the lines that you create in AutoCAD, the lines that you trace the roof plan from, where those points actually exist. There will always be some discrepancy between this and where the actual model shows that that point exists. The loft that gets created for the fascia or the walls or anything else, chances are it's not going to exactly line up. What I typically like to do is import the line work into Max at an elevation of 0 and then elevate each vertex up so that it snaps to the proper place. Because I know these walls are created properly. I know that the fascia is created at the right location. So why not use that? Why not go off of that? Turn this line work into a mesh or elevate the line work up first. But point is, select each individual vertex and snap it to the endpoint of the fascia. If you were using BIM software, if you were using Revit, you can certainly create roofs like this in seconds, but the real problem comes when you start creating complexity to your roofs and have a lot of complicated roofs with some curved surfaces. Sometimes it's easier to just simplify things and build one roof at a time and then build other roofs going into it instead of trying to work with one massive roof plan all at once. So if you're really having difficulties, what you could do is just work with a rectangle that represents the main roof, turn that rectangle into 4 smaller polylines, closed polylines, and bring that into Max, elevate it to the right place, snap it to the endpoints of the walls, and then start working on some of the smaller roofs. Notice this loft down here. This is a loft. Notice that this loft actually incorporates the roof because of because of the nature of this particular roof. You can have the loft, that is the shape that is used to create the fascia, also incorporate the shape of the roof. And that right there is the shape that was lofted for the fascia and the roof. And that's all you need to create that roof that you just saw. The only difficult part is making the endpoints of the top of the roof merge together and weld together at one point, like you see right here. Whenever you can have the roof included as part of your loft, as part of your fascia, that is nice, but it is not worth struggling over. And if you have to build one loft for your wall, another loft for your fascia, and a roof that is separate from your fascia, then that's the approach you should use. Does anybody have any questions so far about this portion of building roofs? This is just to build the foundation of the roof on which the tiles are going to lay. Now, there are 3 main types of roofs. There are roofs that you will apply textures to, roofs that you will apply a tile to, a 3D tile, and then there's roofs that are what is called standing seams, where you cut different elements into, and by that I mean create these ridges, these standing seam ridges, by using the different Boolean features available and elevate these ridges up. If I wanted to turn this roof into a standing seam roof, all I would need to do is make a series of boxes, have those boxes cut into the roof, have them copy to a certain distance apart from each other, attach these boxes together, and use the Boolean cut split feature to cut a set of edges into this roof that I could then extrude. I could select this roof, use the Boolean cut split, one of my favorite features in Max, the Boolean cut split feature, to cut those edges into the roof, and then using either the edit mesh or the edit poly feature, extrude those faces, extrude those edges that I just cut. Okay. That is a quick, easy way to create a standing seam roof. There's a file in here that you can use for your 3D tiles. It's called 3D Tile Roof Sample. And this is the file that I would merge into any scene where I had the need for a 3D tile roof. And I would simply place this and orient it, position it, orient it properly on my 3D roof. The 3D roof that is just nothing more than the small those polygons that I created from the line work in AutoCAD. I place this properly on my roof object, position it, rotate it, get it positioned just correctly, and then do the Boolean feature to cut part of this roof out. If I had my roof, if I had this sitting on top of my roof, I could just trace the roof plan, create an extrusion of a polyline that simulates the same shape of my roof, and then cut that portion of the roof out. I can select this roof, use the Boolean subtraction method to Boolean out this portion of the roof, and that is the proper way to cut and to shape your roof using 3D tiles. Pick operand B, click on the operand, and I'm left with just that portion of the roof that I want. And I think I might have not pushed that roof. I don't think I intersected this properly. Oh, I did the cut split. I shouldn't have done the cut split. I should have done a subtraction. Subtraction A minus B, pick operand B, pick the operand, and should trim away that portion of the roof that I don't need. How would I fill in the area that's closest to the fascia? I'm going to have a gap. How would I fill in this area right here? I know what you're asking. How do you prevent it looking? How do you make the tile not look like it's an infinitely thin surface? The question is how do we? The issue is, what about the holes between the roof tiles? In a second, as soon as this finishes cutting, this is a very complex operation I've just told it to do. I'm trying to tell it to cut through thousands and thousands of faces. This object has about 850,000 faces, and I'm trying to cut away a massive part of this. So it should only take a moment to do. It only takes about a minute. I'm not sure why it's still taking this long. But you're asking if the 3D tiles have a front to it. The 3D tiles aren't just a flat surface. They do have a front to it. If I go into this file, if you look at this roof tile, you will actually see a front edge, front lip to each one of these roof tiles. So you won't be able to look up into, or, well, as soon as this finishes, I think I might have to just stop this. One note while this is loading up about these roof tiles. The bottom side of these roof tiles has been deleted. When these roof tiles were made, a single individual tile was created, and the bottom side of the tile was removed so that when it's placed on this roof and not seen, there's not a bunch of extra faces that are sitting there useless that take up RAM, and it's a very efficient, very streamlined model. So if I zoom in really closely, this is what it looks like. There's no gap. These roof tiles are sitting. Go to the end of the assembly. The gap. I know what you're saying. If this was sitting on a roof, you would see a gap here. I don't think that would be. I do not think that will be an issue at all. I've never noticed that in a rendering. Well, I can show you a rendering with that in it, and I don't believe you will see any issues whatsoever. All you're going to see, now from a distance you can argue about the gaps here, but you're just not going to see this from a rendering like this. From this distance, not a big deal. You could argue about the gap in here, and you could create a thicker extrusion so that the model doesn't show any space. But no, I see what you're saying, but I just don't think it's that big a deal. If you're worried about it, then you can have some sort of you can make this thicker, have these faces be thicker and push down a little bit farther. I just don't think it's necessary. Well, yeah, this object has 850,000 faces. So yeah, it slows it down. But this object, this is a huge object. It spans a pretty large area. So, and placed on this roof that we were looking at before, there's probably going to be even more than 850,000 faces. This would be a good candidate for a proxy. Turning this object into a proxy would be a good idea, but if you want realistic tile, this is what you need. Okay. Let's turn this over to Alex. Alex, are you online?
Yes, Brian, I am.
Okay, I'm going to go ahead and make you the presenter for the next portion of this.
Hello again, everybody. I am Alex Gormanov. I am the instructor of 3ds Max Advanced Modeling class at CG School and 3 Dots. And today we have 1 hour, so I can demonstrate to you one particular example of modeling furniture piece for the interior project. And today it's going to be this white chair that you can see in the middle of the screen. And let's take a look at all reference images that we have available for this project. And right away from the beginning, let me tell you that because we're limited in time, I'm going to be going a little faster than I normally would in a class. So you might not be able to follow, but you can take notes. When you see I'm explaining some new technique or new tool, just write it down, and later when you will be watching this video, you can always refer to your notes and try to follow them. And also, again, this is a presentation of 3ds Max Advanced Modeling class, and this is what we normally would learn in that class to create complex models like that for interior or exterior projects. So let's continue watching all these reference images, and as you can see, they give us enough information to understand what this object looks like, what size it has, how many elements is it made of. And as a next step, we always need to take another look at the image and decide which is the order of the elements. Actually, what is the best order to create of these elements that this chair made of to be able to make this efficiently and fast. And I suggest we use the following order, and I always call it modeling plan. We're going to start making rear and the front legs of this chair, and we'll create this frame of the seat. Then we will model this top element of the back of the chair. Then we will model the rest of the back of the chair, and then we will create these reinforcement bars at the bottom. And I am not sure if we will have enough time, but we will try to model this seat of this chair. So with that in mind, let's go ahead and switch to 3ds Max. And before we start doing anything, let's reset it so we can start working with nice and clean interface, and make sure that we work with generic units. So go to Customize Unit Setup and switch to generic units. Make sure it's not meters or inches, It's just basically just the numbers. So click OK. We can also go to front view and hide the grid because we're not going to need it. Now what we need to do is to bring reference image of this chair into 3D Studio Max so we can always see it on a background and constantly refer to it while making these elements of this chair according to our modeling plan. So as you remember, first elements of this chair that we're going to model are the rear and the front legs. So let's find the image that we can use for that. I suggest we use this one. And what you need to do is to use any your favorite image editing software. It can be Adobe Photoshop or anything else to crop this image this much and save it out in a JPEG format. So now we can import this JPEG image into 3ds Max and use it as a reference. So let's actually go ahead and do it. So on our Create panel, go to the Standard Primitives menu and create plane object of any size. So go to Wireframe, and then on Modify panel, we need to adjust a couple parameters of this object. Set number of length and width segments to 1. Now open Material Editor and pick any empty material sample slot, and for the diffuse channel of this material, we're going to apply that JPEG image that we just saved out. So let me go ahead and do this. That's our image. Now before we click Open here on the Select Bitmap Image File dialog, memorize dimensions of the image in pixels, which is 118 by 350 pixels. And set size of the plane object to the same size in units that the illustration has in pixels. So it's 118 by 350. So set 118 here, 350. Now we can apply this material to this object and make it visible. Now we have reference image that we can use to create first element, and it's proportionally correct. That's actually why we matched the size of the plane in in units to the size of the image in pixels. And last thing we want to do to this reference object is just from the top view, drag it along y-axis back. Okay, so that now if we create any object in the front view, it's not going to be coplanar to it. So go to front view, and let's outline this rear leg of the chair on this reference illustration with spline. So go to Create panel, go to Shapes menu, and create line object. Now use your favorite technique to outline this object. I basically going to use my favorite technique, and if you want you can do the same. I start using as few vertices as possible to create some rough outline with the straight lines. So you can see I used 6 vertices. Now let me close the spline, and let me also change its color so that you can see it a little bit better. Yeah, something like this would be good. Now with this object, we can go to Modify panel, go to Vertex Subobject level, select all vertices, and convert their type from corner to Bezier corner. So that will give us these tangents, these Bezier control handles, with which we can adjust the curvature of each of these segments individually and create nice and smooth outline of the rear leg of a chair. So this is going to take some time, maybe a minute or minute and a half, depends how fast the splines you are, and we limit it with time. So don't spend too much time adjusting the curvature of these segments, and open the scene where that operation already finished. Okay. This is a file where you can see the outline of the rear leg of a chair is already finished. Now it's time to give it some volume. So for that we're going to use Extrude Modifier. So go to Modifier list, to the list of modifiers on the Modify panel, and pick Extrude Modifier and apply it to this object. So adjust this amount so that you can see it better. Okay. Now some people would stop right there because obviously this object already looks good. But I always tell him, you know, I say it looks good, but it doesn't look good enough because level of detail of this object could be improved. And let's go ahead and improve it. So for that, we want to go back to original line object and click this Show End Result button so we can always see this object as if all modifiers would have been applied to it. So go to Interpolation Rollout, uncheck this Adaptive checkbox, and increase number of steps until you're happy with the level of detail of this object. So I'd say something like this looks good enough. Maybe switch it down to 18. Yep, that looks good. Now we want to smooth out the edges of this object because we're trying to make photorealistic object for the photorealistic renders. And you know, like in real life, when chair like that is manufactured on a factory, all the edges are always smoothed out on with this sand belt, so they look nice. And we're going to replicate the same effect in our 3D model. So when we render it, it will catch some nice reflections, some nice highlights. So let's go ahead and do it. So in order to do it, in this particular case, in order to make all the edges of this object nice and filleted, let's convert it to editable poly and go to Edge Subobject mode and select these two edges at the top, this one edge in the middle, and these two edges at the bottom. So now, while having these edges selected, we can go to Chamfer. We can use the Chamfer tool to create the fillet. So you can click this Settings button next to it, and that will give you this Chamfer Edges dialog. On that dialog, first set number of segments. I think 4 would be just fine in this case. And actually, let me zoom into these edges at the top. So, and then adjust the chamfer amount that defines the radius of these fillets. So I think something like this would look just fine. So click OK to confirm. Now it's time to smooth out all the vertical edges of this rear leg of the chair. And before we do that, we need to go to Polygon Subobject mode and select this large polygon in front and this large polygon on the rear side of the of this object. Then go to Front View, maybe zoom in, and use Insert tool to inset these polygons, these selected polygons, to some small amount. Just use your eye judgment. Something like this would be good. So again, click OK to confirm. Now, before we do anything else, I want to show you something. Let me just zoom in, and you can see that all these vertices, all these edges, they are just they're not right. They just pile up, they're intersecting. So before we do anything else to this model, we need to fix this problem. And in this case, the quickest way to fix would be to go to Vertex Subobject mode, select this group of problematic vertices, and weld them together using Weld tool. So bring up Weld Vertices dialog and increase Weld threshold parameter until you can see all those vertices, they welded into one. So click OK, select second group of problematic vertices, and repeat this operation. And obviously, we can expect the same problem here at the bottom of the object. So select this group of vertices, weld them, and select the second group of vertices at the bottom and weld them as well. So maybe reposition this new vertex a little bit. Okay, now we're ready to apply fillets to the vertical edges of this object. So I'm going to go back to Edge Subobject mode, select this edge on the front and this edge on the back of this model. And to make a selection of all vertical edges quick, we can use this loop command to select all adjacent edges. And you can see after I click the button, it automatically selected all the edges that we're going to smooth out. And now, having these edges selected, we're going to use Chamfer tool one more time to create fillets. So bring up Settings dialog, this Chamfer Edges dialog by clicking that little Settings button. And you can see this Chamfer Edges dialog already remember last set of parameters that we used to create fillets. So basically, just click OK here and exit from subobject mode, and you can see we've created nice fillets to this object. But the problem is that these fillets that we created, they are faceted. They don't look smooth. So there are many ways to smooth it out, but in this particular case, I want to show you how you can do it quickly with smooth modifiers. So go to Modify panel and apply smooth modifier, and set this Auto Smooth checkbox, and that will do the job for you. It will automatically assign all the smoothing groups to this object. Now you can see this rear leg of a chair looks nice and smooth. So we can say that this object is done now. Later, of course, we will create the second rear leg of this chair bolt by just simply, copying it. Okay, now according to our modeling plan, let me refer to it real quick. Yeah, the next element that we're going to model is this front leg of a chair. And let me continue from pre-saved file. Okay. Now we need to update this reference image that we have on the background with the new one that will show us the front leg of a chair. And I'm going to use the same reference image here to extract the reference information that I need. So I'm going to crop it this much this time, and again save it out in a JPEG. And on a 3D Studio Max, you don't need to delete this plane object and then create it from scratch again. We can just go to Material Editor, and for the material applied to this plane object, we're going to substitute this JPEG that's currently used for the diffuse channel with this new JPEG image that we just saved out. And again, before you click OK, just memorize the dimensions of this file in pixels, which is 228 by 337. So click OK, and now change the size of this plane object to the size of that new reference image in pixels, which is, I think, 228 by 337. Yes, looks like, let me double check. 228, 337. Yes, those numbers are correct, so we can also reposition it a little bit. Okay, so let's go ahead and create the front leg. So this is something relatively easy if you know the tools. And let me show you how we can do it. So we would start with going to Create Panel, go to Extended Primitives, and there you can find Chamfer box, which is the same thing as the regular box, except you can give it some filleted edges. So create chamfer box. Actually, well, it's something that's it's easier to do from the perspective view. So let me delete this one and show you the process one more time. So create this chamfer box button, and in a perspective view, just create chamfer box of any size. That's just make it remotely, resemble the front leg of a chair, something like this, because now we can go to front view and fine adjust the size of this object in some parameters. So first I would adjust the width of this object. Then, because the cross section is square from the top view, basically the width is the same as the length. So I'm just going to copy this number over here, and now I want to adjust the height of this object. And also adjust the fillet radius. Maybe I can temporarily move it closer to the rear leg. That will help me to get the radius for the fillet right. Something like this, maybe increase number of fillet segments. Yeah, that looks good. So now I want to increase number of height segments for this object, probably to 22. The reason why I want to do this is because if we look at the reference image one more time, let me see which one we can, yeah, this one will give us better idea. The reason why I want to increase number of height segments is because you can see, first, this object, this front leg of a chair, is tapered toward the bottom, and then it's curved away from the virtual center of the chair. So to make this, to make the tapering of this object and then curving of it possible, I need to have these vertical segments. So now for this, to this chamfer box, I want to apply FFD freeform deformation modifier. So I'm going to increase number of dimensions for the height up to 8. So I will get some more control points. So go to control points subobject mode of this modifier and select this first group of control points at the bottom of the object. So while having them selected, go to the select and scale mode and scale the selection of control points down. You will see that we start tapering this bottom, tapering this object at the bottom. And I'm going to select the second group of control points and do the same thing. I'm going to scale them down. I'm going to do the same to this third group of control points, and I'm going to scale them down as well. So you can see that I'm creating this nice tapered look to this object toward the bottom. And maybe I also want to scale this one down just a bit. Okay, so, and maybe also scale this one up. Okay, so now after I've tapered this object toward the bottom, it's time to curve it away from the virtual center of the chair. So the part of this front leg that is actually curved is about the lower half of it. So I'm going to go to vertex subobject mode and select this many vertices. Okay, and now while having this selection of vertices active, I'm going to apply freeform deformation 4x4x4 modifier, and you can see when I apply it, it only applies to the currently selected vertices. So now whatever whatever modification I apply using this freeform deformation modifier, it will be only applied to those selected vertices. So I'm going to go to control point subobject mode of this modifier. I'm going to select this bottom group of control points, and I'm going to shift them to the right along x-axis. And then I'm going to select this second group of control points and shift it to the left. So you can see I'm already created some curved look to it. But the problem right now is that the subject only curved along x-axis right now. But in reality, this object needs to be curved along y-axis as well. So I need to fix that. So I'm going to go back to control point subobject mode, select this lower group of control points, and this time this is actually something easier to do from the top view. Here you can see in the front view, because we moved these vertices to the right along x-axis, at the top view I want to move them down along y-axis. Then I go to front view, select this second group of control points. Because I moved them to the left from the front view, I want to compensate this by moving them along y-axis in the front view. Okay, so now you can see if I collapse this object into editable poly, it is properly curved. It's curved along x and along y-axis. Now I want to get rid of these extra horizontal subdivisions of this object, because I'm not going to need this much edges right here, because it's just this part is straight, and this is something that will help you to save computer memory and make this model render a little faster. So go to edge subobject mode, select all of these edges like this, and let me switch to perspective view so you can see it better. Okay, now I'm going to click this loop button again to finish the selection of all adjacent edges. So you can see after I click it, I got all other horizontal edges selected. Now I want to remove them. So I'm going to hold Control on my keyboard, and I'm going to push backspace, and you can see that command removes all those edges from the structure of this object. So now it's optimized, it's properly curved. So now it's what I only need to do is just align it along the bottom of the rear leg, For that, I'm going to use Align tool. So I'm going to click it, and I'm going to choose my target objects and tell it that I want to align this current object along y-axis minimum to the minimum of the target object. So click OK, and now using this reference image, I'm going to put it to the proper distance from the rear leg. Okay, and also what I can do is right away I can say that maybe it's too high. So I'm going to go to Vertex Subobject mode, select these vertices at the top of the object, and just manually move them down a little bit. Okay, so now after we've got rear and the front legs of this chair, it's time to properly space them. Actually, it's time to copy them to create front and rear legs of this chair on the other side of the chair and space them, between each other. So actually, the copying of it's something very simple. You can just select these two objects and use mirror tool to mirror them along y-axis as instance. Okay, so click OK. Now it's time to space them out. So some of you, I don't know, who has a good eye judgment can basically, eyeball it, and some of you probably doesn't feel confident, using eye judgment. I suggest to do this trick. And I actually have this illustration that can help you to understand what I'm trying to explain. See this image right here? You can see by looking at this illustration that the height of the front leg of the chair is equally the same as the distance between the outer edges on the front, between the front leg of the chair. So, and we can use this information to properly space them. So just try to move this object along y-axis until you see that the distance between the outer edges of the front legs is equally the same as the height of the front leg itself. So I think that looks good. And again, I don't want to spend too much time doing that because we even though we're making this object real fast, but still we have only 1 hour. And let me move on and quickly show you now how we can space the rear legs. Now this is something we don't need reference image for because we know that usually for the chairs of this type, the distance between the rear legs is smaller than the distance between the front legs. So let's just eyeball it, and maybe something like this would look just fine. And you can see that the rear legs, they also slightly rotated. So we need to rotate them right here. So in order to, and this is why we copied these objects as instances, because we're going to save time right now. Instead of rotating this object to some angle and then matching the rotation of the rear leg on the other side of the chair by either, I don't know, memorizing those numbers or just, I don't know, some other way. Because they are instances which we can just go to edge subobject mode, element subobject mode, select this entire element by which this rear leg is made, and rotate that element, and you can see the rotation of the second rear leg is the same. So again, use your eye judgment. Something like this looks good. Now we can exit from subobject mode, select all of these elements, and convert them into editable poly. So here we go. We've got the front and rear legs finished and properly spaced. And let me continue from a pre-saved file where I spent a little bit more time doing that, and those objects look a little nicer. Okay. All right, so we see the same thing that you saw 1 minute ago. The rear and the front legs are finished and properly spaced. Now it's time to create the frame of the seat that connects all of those legs together. So this is something, again, not very complicated. Go to top view, go to create panel, go to shapes menu, and create a rectangle that will connect all of these objects together. Just roughly connect, something like this, so that now we can convert this rectangle into editable spline. Go to vertex subobject mode, switch all of these. Sorry, before we do that, let's just optimize the shape a little bit. Go to segment subobject mode, select this segment on the back, and scale it down along y-axis. Okay, so now we can go to vertex subobject mode, select all vertices, and just obviously they're already Bezier corner, but let me just confirm it by right mouse clicking over any of these vertices, and you can see this checkbox next to Bezier corner, so that's what we want. Now using these tangents control handles, we can adjust the curvature of each of these segments, and basically what we're trying to do, we're trying to make this shape to really look like the outline of the seat frame from a top view. Something like this would look good. Maybe it's too much curved. But again, like I mentioned, we don't have too much time to perfecting these curves. I'm just trying to give you an idea how it's done. And when you will be repeating this exercise, you can take your time and make it look much better. But anyways, it looks nice. So now it's time to give it some volume. So first, I want to give this spline, give this outline some thickness. So I want to go to spline subobject mode, select the spline, and I'm going to use outline tool just interactively in the viewport. So I'm clicking this button, it's highlighted in yellow, means now in the viewport I can just click this line and give it some outline. Something like this would look just fine. Now you can see if I try to extrude this object, extrude it, now it looks like a seat frame. Okay, so something like this looks good. Maybe I want to use negative values so it extrudes down. Yeah, that looks great. Now again, you can see on this wireframe mode that the level of detail of this object is not very nice. It could be a little bit more detailed. And again, this is easy to fix. Go to Editable Spline subobject mode. Make sure you click this Show End Result button. And on the Interpolation Rollout, uncheck this Optimize checkbox and increase number of steps until you like the result. So something like this looks perfect. So collapse it into editable poly, and now it's time to create fillets along all the edges. So for that, I want to go to Polygon subobject mode, select this polygon at the top and this polygon at the bottom. I want to insert these polygons using Insert tool. Then I want to go to Edge subobject mode and select 4 edges like that, and use Loop command to finish selection of edges. And now I'm going to use Chamfer tool to create the fillets along those edges. Again, you're already familiar with that technique from the beginning of this exercise, so I'm not going to say too much about it. I'm just going to do it real quick. Okay, and again, let me isolate this object to show you something. Now again, you can expect some faceted polygons right here, and in order to get rid of it, as you remember, we can apply smooth modifier without a smooth checkbox, and yeah, that does a good job by smoothing everything out, but looks like it did too good with that. You can see some dark areas right here and some bright areas right here. This is because computer now, or 3ds Max now, thinks that after we applied smooth modifier, this is one continuously smooth object, when in reality it is not. This is quite a sharp turn right here, and we need to fix that by applying different smoothing groups to the sides and to the back and the front of this object. So let's go ahead and do it. Go to Polygon subobject mode, go to Top View, and select all these polygons that belong to the back and to the front surfaces of this object, and unselect these large polygons at the top and at the bottom. Now scroll down here on the Modify panel, and in this Polygon Smoothing Groups Rollout, just click Auto Smooth button without changing anything, and you can see that automatically assigns different smoothing groups to those selected polygons, and that fixed that problem in the corner. So now this object looks perfect, and it's time to just fit it into place a little bit better. Now let's improvise a little bit here and see, okay, I like the way the frame enters and exits from into the front legs of the chair, but obviously on the back, it doesn't look nice. The way this frame enters and exits from the rear legs is not really nice. And let's fix that with using this almighty freeform deformation modifier. And as you can see, I applied FFD 2x2x2 modifier, so I can have less control points. That's pretty much what I need. Go to control points of object mode. Now select these control points on the back and use non-uniform scale to scale them along y-axis, and you can see that push them away from each other, those selected control points. Now go to move mode and maybe move them back a little bit. Now you can see that this line formed by intersection of the seat of the frame with the rear leg, it's not parallel to the edge of the rear leg, so we need to fix that. And again, something very easy. Select this bottom control point and this bottom control point of freeform deformation modifier, and again using non-uniform scale tool, scale them down this time along y-axis, so you will push them toward each other, and now you can see this line looks good. So now we have finished the seat frame of this object, and according to our modeling plan, it's time to create this top part of the back of the chair. And let me show you reference image, and maybe this one. Okay, and what's unique about this element is that it you know, besides having this unique design, it also has two types of fillets. It has nice small radius fillets along all the edges, because, like I mentioned, the objects like that, they get sanded on the sand belt, but it also has this a large radius fillet along the top edge of this object. The reason why is because definitely the designer and manufacturer of this chair, they wanted, you know, person who sit in this chair feel comfortable, so that he's not going to be irritated by this sharp edge. So this is why they smoothed it so heavily. And I personally believe we should not ignore this design feature, because it's one of the unique personality features of this chair, and we need to find a way to model it exactly that way. So this backrest will have two types of fillets. And let me demonstrate you how you can do it using Loft compound object. And as you remember, some of you from a beginner class, and obviously probably, I'm not sure, but probably by now Brian already mentioned Loft compound object, how powerful it is several times. And believe it or not, we can use this object, compound object, to create the back, the top element of the backrest of this chair. So let me demonstrate you how we can do it. I'm going to continue from pre-saved file. Let me see. Okay, this one. And now I'm going to first select all these elements that I finished so far and rotate them 90 degrees. Now I'm going to go to front view, and I want to bring the new reference image into 3D Studio Max. So I'm going to use, let me see, I'm going to use this one. So again, crop it this much, save it out in a JPEG format, and use this plane object to stretch new material over it. So bring up material editor, let me open the current material, and replace this diffuse bitmap with the new one that I just saved out. And again, memorize the size of this image in pixels, which is 264 by 234, and input it right here, 264,234. And now we're going to use this reference image to create the 3D model of the back top element of the backrest of the chair. So before we do anything else, let's match the scale of this reference image to the current scale of the chair model. So I'm going to use this, probably I can use uniform scale tool, and just scale it down like that. So now obviously, if I use this reference image to create 3D model of the backrest of the chair, when I finish it, the size will be already correct. So I can just position it into place, and I'll be done with it. So, okay, let's move on. And because we're going to do it with the loft object, we need some splines. So let's go to Create Panel, Splines menu, and create a line with which we want to outline the half of this object. So I would start here at probably at the bottom. And again, I'm going to use my favorite technique, but I seriously suggest you try to do the same. So roughly place these vertices so that now, then you can switch to go to Modify panel, go to Vertex Subobject mode of this Editable Spline object, convert all vertices into Bezier corner, and manually adjust all of these Bezier control handles to define the curvature of this object. So let me do it real quick. Yes, you can see that it's very quick and efficient technique of creating outlines like that. So okay, so we've got our outline that we're going to use as a profile. Now it's time to create, to give it some shapes, because loft object needs the path and needs the shape that you can loft along the path. So let's create those shapes. Let's go to Create Panel and create a rectangle like this. Let me change its color so you can see it better. Okay. All right. Now, what we're going to do is to convert it into Editable Spline, go to Vertex Subobject mode. Oh, I'm sorry. Actually, for the loft compound objects, it's very important to have pivot point of the shape in a proper place. So this is the moment when we need to define proper pivot point for the shape. So let me go to Hierarchy menu, Adjust Pivot Point mode, and instead of just manually position it, I'm going to use this Align tool and align it, the pivot point of this object, to the object itself, just telling it that I want to align its pivot point to the maximum X and maximum Y position. Click OK. So now we've got this pivot point in the proper place. Now we need to go to Vertex Subobject mode, select these two vertices at the top. Actually, you know what? Sorry, we need to select just one here at the left top corner of this object and use Fillet tool to create nice small radius fillet. Just like that is fine. Okay, now copy this object down. Make sure you copy in this time as copy. Make sure it's not instance. It should be copy. Click OK. Go to Vertex Subobject mode, and now fillet this top right corner of this object to approximately the same radius. Okay, now go back to this top shape and go to Vertex Subobject mode. Use Fillet tool but this time fillet it some more. Create some nice large radius. Okay, and let's also optimize this shape. Delete these 3 straight segments at the bottom and do the same for this bottom shape. 3 straight segments at the bottom. Okay, now we've got all the shapes and we're ready to create a loft object. Let me isolate these shapes so we can see it a little bit better. Okay, now select this shape that represents the path. Go to Create Compound Objects, Loft, click Get Shape and pick first shape. Now you can see that, yeah, it's lofted, but the orientation of this shape is not right, and this is something we need to fix right away. So go to Shape Subobject mode, select the shape from the structure of this new loft object, and it's right there in the beginning. And make sure you click this Angle Snaps toggle button, and you can rotate this shape 90 degrees. Make sure it's exactly 90. It's not 85 or 95. And be careful because you cannot, once you improperly turn it, for example, you accidentally turn it to 95 degrees, you will not be able to undo it. So, you should get it right from the first try. Okay, anyways, we've got this, something that already resembles the top element of the backrest of a chair. Now, we need to optimize it a little bit because obviously you can see there's just too many, edges in the right here along the length. Along the length of this object, and there's just not enough segments that define this curvature of these large curves. And let's go ahead and optimize it. So go to Skin Parameters Rollout, and first click this Optimize Shapes button that will optimize the shapes. Now it's time to optimize the curvature of these large curves. And this is something easier to do like this. Set number of shape steps to, number of path steps to 0, and that will make this object look a little bit funny. But now we can use, we can go to path subobject mode and see that this path is made up by this line object. Go to this line object, segment subobject mode, and manually define the level of detail of this curve. So select this segment and subdivide it using this divide tool. Just click it once, twice, 3 or 4 times until you're happy with this, with the level of detail of this curve. So something like that looks good. And then go to the next curve. So do the same thing, just eyeball it. Do the same thing to the next curve, and you don't need to do anything to the straight line because it's straight line, doesn't require any horizontal edges subdividing it. So that looks good. Now it's time to create a transition from the small radius into the large radius, and that's why we created the second profile. So let's go ahead and go back to original Loft object, and as you remember, if I click Get Shape button right now and pick this shape, it will be inserted into the structure of this Loft object here at the beginning. And you can see this little yellow cross tells you that. We need to position this yellow cross into a different place. So let's first reposition this little yellow cross approximately here, because the transition would start right there. Now click Get Shape and pick this first shape with the small radius fillets. Again, you will have to rotate it 90 degrees. Okay, like that. Now exit from subobject mode and reposition this yellow cross probably right here. This is where transition would stop. Click Get Shape and pick this second shape. That looks good. Now again, it's not oriented correct, so reorient it. 90 degrees. Okay, now I don't want to spend time optimizing the level of detail of this large radius fillet, but I want to take time and show you how we can adjust this transition. So go to front view. If you don't like this transition that happens right there, it's very easy to adjust. You just need to go to Shapes subobject mode of Loft compound object and drag it along Z axis, and you can see you can tweak this transitional moment, this transition. And I might want to, I wish I could spend more time doing that, but anyways, that gives you the idea how you can do it. So when you have time, when you'll be practicing, just give it a little bit more time and make it better. Okay, anyways, let me continue from preset file and where that shape is already finished. Okay, right here. Now, when we finish this Loft object, it's time to mirror it to create another half of the backrest. So this is very easy to do, convert it into editable poly. Now, I want to use Symmetry tool, and this is actually a modifier. And using that modifier, I'm going to create the second half of this object. And what's good about it is that it creates the second half, mirrored second half, but it also welds the vertices, welds two halves of the object together right there. You can see it's not welded, and now it's automatically welded right here. So collapse it into editable poly, and now it's time to seal these openings. And for that, we're going to go to border subobject mode of this object, just select all borders and click this cap button, and that will cap the holes, the openings. And now this object is no longer see-through, it's a solid object. So now it's time to curve it, because obviously, here this object is, you can see there is a curvature to it, so you can position your back into it nicely. Okay, Now we cannot bend this object just like that, and let me demonstrate you why. Because let me position the pivot point into the center. You can see if I apply bend modifier, yes, it bends the wireframe nicely. But if I look at the polygonal structure of this object, see, it doesn't look nice. And the reason why is because this large polygon in the front and on the back, they don't have any sort of, subdivision. So we need to find a way to subdivide. There are a couple ways to do it, but I'm going to show you at this time the quickest way. So for that, and actually before I do this, let me create fillets to these two corners of this object. So I'm going to go to Edge Subobject Mode, select couple edges, click Loop button to finish selection for you, and use that tool that you're already familiar with, Chamfer tool, to do something like this. Okay, that should work just fine. Okay, now we're going to subdivide this object with subdivide modifier. You can see it breaks it down into triangles, and you can control the size of the triangle. So let's maybe set it to 5 or maybe 4. You can see that it looks nice, and it's ready to be bent. So if I bend this object right now, it would look correct. You can see there is no longer problems with the polygon, and it looks perfect. So after that, I don't want to perfect this curvature of this object right now, so I'm just going to show you that after you finish this top element of the chair, you just can put it into place just like that. Just drag it and position it where it's supposed to be, adjust its position from the side view like that. And now it's time to move on to the next element. And according to our modeling plan, that was, let me see, that was these other elements of the back of the chair, which is this horizontal bar and this decorative element. And those are also simple to make. For that, we already have reference image, and this horizontal bar can be made by just creating this chamfer box object like that. Don't forget to give some radius to the fillets. Yeah, something like that looks good. And because we're gonna bend it, also make sure you hold on a second. Let me adjust a couple parameters here. Make sure you subdivide it along the length like this, so that now we can apply bend modifier to this object, bend it like that, and position it into place like this. All right. Okay, well, again, because we're limited in time, I don't want to spend too much time positioning the horizontal bar. And this element, this decorative element, very easy to make too, because all you need to do is just go to Shapes menu, create something as a start, maybe an ellipse. Yeah, let's do the ellipse. Outline this opening right here. Okay, now then use all other shapes that you're familiar with, and so use all the tools that you know to build the outline of this decorative element, and you will end up with, let me just demonstrate you just a couple of tools. So I'm going to use chamfer right here. I'm going to delete this segment. I'm going to do the same thing right here. Use the chamfer. I'm going to delete this segment right here. And you can see now I can touch these guys together. I can select these vertices and I can weld them. Then I can use fillet command to do something like this, and sometimes it requires a little bit manual adjustment. So the bottom line here, so that with splines you need to create outline, and then you can do the same thing that we did for the rear leg, for the seat frame. You can just extrude it, optimize level of detail of this object, and then convert it into editable poly and smooth out the edges to create some nice fillets. And here you can see the object is already finished and in place. So there you go. And that looks good. And according to our modeling plan, only elements that left to create are the reinforcement bars at the bottom and the seat of the chair. So apparently we're not going to have enough time to create the seat, but because we started, I think at 1:05, I think I've got 5 more minutes. So let me demonstrate you how you can create the reinforcement bars at the bottom of this chair. And that is something can be done very easy. Go to Create Panel, create a line object with which you can connect the rear and the front legs of the chair. Now, just hold on a second. Let me reposition this. Go to Webinar Panel. All right. Okay. Now, let me also change the color of this line so you can see it better. All right. So we've got this line, which now we can turn into geometry by, on the Modify panel, going to Rendering Rollout and setting this checkbox, enabling Viewport, and that turned this object from spline into geometry. Actually, it doesn't actually turn it into geometry until you collapse it into editable mesh or editable poly, but it gives give it this geometric appearance. So you can control thickness of this object and number of sides. So let me set number of sides to 18 and thickness to something like this. Okay, now we need to, because these reinforcement bars, which image is better to look at? Let me see, probably this one. You can see it's tapered toward the end. So to do that, we need to subdivide this object and uncheck this optimize checkbox, and you can see we've got these extra segments that dividing this object. Maybe increase this number. I guess 25 is just fine. Convert it into editable poly or editable mesh, it's up to you. Then apply FFD 4x4x4 modifier, with which now we can select this group control points on one side and just scale it down. Whoops. Sorry. And scale it down, and you can see by doing so, we are tapering this object toward the ends. So, and do the same on the other side of this object. So now you can see, looks nice. And to adjust the placement of this object is something very simple. Just on perspective view, just position it to align it with the front leg like that, because by looking at the reference image, you can see that all of those reinforcement bars, they are aligned to the middle of the front leg here. And then apply FFD 2x2x2 modifier, go to control points of object mode, select this group of control points on the back, and just move them, and you can see you sort of rotating this object, you changing the direction and which this bar is pointing to. So align it to the rear leg, and something like that looks great. And now, using the same technique, you can just copy all of these reinforcement bars, then create the reinforcement bars on the other side by just mirroring this and position it to where it's supposed to be, and just basically use this technique to create all other reinforcement bars. And there you go, you will end up with object like this. And now we're already running out of time, so I'm sorry. Maybe next time, maybe you can attend my class, and I will demonstrate you how we can create a seat of this chair and explain you, with and take a little more time doing so. So thank you very much. I hope you enjoyed this little demonstration, and let me give controls back to Brian.
So we're going to look at 2D and 3D sites. let's go ahead and reset max. And then let's go into, this is going to be more of a hands-on where you're going to be able to follow me, and I'm not going to go too fast. We're not going to lose anybody on this demonstration. I can pretty much guarantee that. There are files, there are folders in the 3ds Max 2 folder, one called furniture, one called sites, one called vegetation. And we're going to focus on the one called 06 sites at this point. There's a lot of different files in here. There's a lot of different things that we'll look at. Some of the things we won't have time to touch on. But the scene that we're going to look at is called Pizzeria Site. And this is a restaurant that was done 5 or 6 years ago. And I want to start just by looking at the original AutoCAD drawing. Uno Initial. It's in a folder called Pizzeria Site. Again, it's 3ds Max 2, 06 Sites, Pizzeria Site. And I want to open up the original AutoCAD drawing, Uno Initial. And this is the quote-unquote dirty AutoCAD file that I received. If you examine this drawing, you'll notice that something unusual with these lines. Every single object in the scene is part of the same layer. Well, virtually every. I think there's maybe 2 layers or something like this. There says it says there's a lot of layers, but virtually everything is on one particular layer. All these parking lines, all of the hatch patterns, everything is on the same layer, a site. All these different lines are on a site. So that in and of itself is pretty bad. So this drawing had to be cleaned up. But if you examine the scene and look around, what you'll see on the site, something that was problematic was that there's a lot of instances where you have little irregularities where you have lines overlap instead of endpoints welding, little lines overlapping like that. And look at that, there was 2 lines on top of each other. I didn't even notice it until right now, but there were 2 lines sitting right on top of each other. Those sort of things make working with AutoCAD drawings or architectural drawings or civil engineering drawings, whatever, make it really difficult. When you're not the creator of some of these drawings, it's sometimes very hard to make this stuff work. Cleaning up my interface here. Okay, so this was the dirty version of this file. Now I'm going to open up the clean version, and that clean version is called Uno Clean, and this is the one we're going to work off of. This is the one we're going to modify. First thing I want you to notice is look at the layers that I created. I cleaned up everything so much that all you have is about 7 or 8 layers to work with, and importing this line work is so much easier to do, and working in Max is so much easier to do when you only have this line work to deal with. So we're going to start with a 2D site. We're going to turn this into a 2D site, and then we're going to turn it into a 3D site. We're going to create a ground object, a road object. We're going to create the parking lines. We're going to create curbs and paver patterns. We're going to do the whole kit and caboodle from start to finish. Okay, so first thing we need to do is start with a clean Max and import that entire drawing. That entire drawing can be imported as is because everything that drawing is going to be used. There's nothing else missing. So I would suggest trying to follow along with this because this demonstration is going to sort of hit home all the different features we looked at up to this point. So go to Import and select the Legacy AutoCAD file type and import that drawing that we looked at, 3ds Max 2 folder, 06 Sites, Pizzeria Site. And again, the file we want is Uno Cleaned. We want the Uno Cleaned file. It asks us if we want to merge. Sure, let's merge. And the option to convert to single objects, the decision whether or not to convert those objects rests in whether or not we want all of these different layers, all the objects on the same layer to be part of the same object. Notice that there is one layer for the road, one layer for the curbs. There is one layer for all these different objects. There's no reason why we should have multiple objects on the same layer. So I want all these parking lines on the same layer. I want all these pavers on the same layer. And if you build your AutoCAD drawing right and separate lines by layer, then you don't have to worry about this option. You can convert to single objects, and you won't have to worry about doing any attaching or anything like that. Everything comes in just the way you want it. So there's the line work. Everything inserted in just a second. It just took a split second to insert. And in top view, I want to start like I do with every site and create a bounding box, so to speak. I want to create a rectangle that encompasses my entire scene from which everything else is going to be subtracted and booleaned out of. And perhaps the easiest way to do this would be to create a plane object. You could do a rectangle and turn the rectangle into an edit mesh. Create a plane object, like so, and turn on faceted mode so you can see all these facets running behind the scenes. And let's turn the length and width segments to 1. And you can reposition this. You can make this exactly centered on the scene if you want by going into wireframe mode. All you need to do is create a rectangle, or a plane, I'm sorry, create a plane with one polygon encompassing the entire scene. And all we want to focus on right now is the road and this polygon. The road and the polygon. We know that whenever we import line work, we have to do what? What's the first thing we do when we import line work? Weld endpoints, yes, because the weld points did not end properly when we did the import. And it looks like somebody's asking a question. Jacqueline, where is faceted mode? Faceted mode is F4. If I go into shaded mode, which is F3, I'm toggling on shaded mode right now. Faceted mode is F4. So if I have facets in an object like a teapot, F4 will allow me to toggle on and off those facets. Okay? And I only wanted to see facet mode so I can see the segments that was part of this plane that I added. But set the length and width segments to 1. So we know that we need to, let me go ahead and lower your hand for a moment. So we know we need to weld endpoints of all this line work, but we only want to do this one object at a time. We're dealing with the road right now, so enter Vertex Subobject mode. Keyboard shortcut 1 is the quickest way to do it. Select all these vertices. You can just do a window selection, or you can just hit Control-A to select them all. And taking note of the weld distance here and making sure that the vertices that you see on the screen aren't within 0.1 units apart, and it's clear that if this drawing was drawn to scale, as long as this thing is not really way out of scale, these vertices are going to be much farther apart than 0.1. So knowing that, assuming that, we can just go ahead and hit the weld button, and when we see a little flash, then that indicates that there are some vertices that were welded. There were some vertices that went away. Now notice on many different parts of the straight line segments that there's extra vertices. And these were vertices that were created by the architect. I'm not sure why they were there. They probably had something to do with a light pole or some feature that they wanted to create, but we don't need these vertices here. So we can just, while still in Vertex Subobject mode, we can delete all these. All this does is add unnecessary polygons to the final mesh. So we can delete all of these. You don't have to do them all, but just as long as you understand the process that I'm doing and why. This spline is pretty clean right now, but it doesn't have the segments that we need. Everybody should know by now that in order to properly create this spline, we need to divide all the curved segments. And once we divide all the curved segments, we're going to turn the interpolation, which is currently up to, I believe, 6, the default value of 16, okay, 16. we need to turn the interpolation down to 0. If I turn it down right now, of course, everything will become a straight line segment, and we won't even know where the curves are supposed to be, so we won't even know what places to add additional steps. So it needs to be kept at 16 at this point, and we just need to go through and pick all the different areas that we need to subdivide. And of course, we need to do this in segment subobject mode. So all you need to do, and you don't need to do this to the entire spline right now, just do it to a few if you can't do it quickly. Just find all the appropriately sized or similar all the segments of similar size, highlight those together and execute the command at the same time. So for example, I just highlighted these two segments, that segment and that segment, because while at a different length, they all have the same appropriate need for the same number of vertices. And that number for this particular stretch of segments, I would say, would be about 15. So I'm going to divide this about 15 times, and the density of vertices up here at this segment is higher than down here, of course, but I think it works, and the mesh will look just fine like this. And so then I'll go into a different area and try to find more segments of the same size. So I'll pick all of these islands, the curved areas of these islands, and notice I'm not going to pick these two that have an extra vertice in the middle, because that would give those two segments more vertices than anywhere else. So I'm going in and I'm just looking for all the segments that have roughly the same length, and I believe on these islands I'm going to add something like 10. You can always come back and add more later. You can always add more division later, as long as it's still a spline. Once you edit mesh it, there's nothing you can do, because an edit mesh is not the same type of object as an editable spline. Then I'm going to pick the last curves in here and do the same thing with these last few curves. I'm holding down Control, and notice when I hold down Control, I get that little plus sign on my cursor. I'm holding down Control and selecting all these shapes. I should say segments, not shapes. And let's do a smaller amount here. Let's do 6. We'll divide 6 times for this curve here. I've got a couple of big curves here, and I could probably actually divide this 6 times, and that would be enough for those. And that curved section, they could probably use about 12, something like 12. And I think I'm done. Yep, that's all I need. I've just added all the vertices that I need for this object. And since I've added all the vertices I need, I can turn interpolation to 0. Anybody have any trouble keeping up? Anyone not able to either follow along or to continue doing the same exercise? Jacqueline, I keep seeing you raise your hand. I'm going to unmute your phone for a second. Jacqueline, do you have any question right now?
In my notes, I just wanted to recap. You went in, the first thing you did was weld.
Yep, first thing I did is weld.
What was the second thing? You did something, and then you moved on to selecting the segments to divide them. Okay. And what was that something? I'm sorry.
Okay. So after I did the weld, I wanted to all I've done since the weld command is divide segments. So I went in and I temporarily set these steps to 0 to show you all the segments that were curved, and then I mentioned that you can't set it to 0 yet. You have to leave it set to something like 16 so that you can see those curves that you have to divide. But ever since the weld command, the only thing that I've done, oh, no, I remember now, I deleted some additional vertices that were here and here. That's all I did.
Okay.
That was it. Yep.
All right. Okay. Thank you.
You're welcome. Okay. So now we have a good spline to work with. Now you could make a copy of this, just in case you ever wanted to come back to it. You could make a copy of this by pressing the shortcut Control V, or you can come up to this edit window here and hit Control V and just create a copy of this. I'm just going to call this site roads-copy. And I don't know if I'll ever need this again, but I like to create a copy of this so that when I start moving this object around and start doing something with it, I can always come back to it. So I just created a copy, and I want to hide it, so I'll go to the display panel and hide it. So that's all I did. Create a copy, display panel, hide it. Okay, what do we do with this now? How do we actually create our site? Well, we know that we have a mesh that represents the grass, and this is a two-dimensional site, by the way. We'll turn this into a three-dimensional site right after we're done with this, but this is two-dimensional. If you're working on a site that is nearly flat, and I say nearly, meaning that if over the course of this entire development the terrain only changed about 1 foot, maybe even 2 feet, that is something I would never worry about trying to create in 3D. It's far easier to make a two-dimensional site than it is to worry about a couple feet change in elevation and worry about all the things that have to be done to accommodate that, which we'll do in a minute, but we're going to keep this simple for right now and make it a two-dimensional site. So let's select that spline. Let's select the spline for the road and extrude that some amount. It doesn't really matter how much. It's just an amount that we need to have to be pushed through the road. So we just want to extrude this road some undetermined amount. So add the extrude modifier, and using the transform gizmo, push it down through the terrain, push it down through the plane object. Okay, and before you do anything else, before we do the next step, what I would like you to do, if you're following along, is go to the edit menu and select hold, or just hit Control H, and that's going to save your scene in RAM so that in a minute when we need to go back to this point, we can retrieve what we have. I'm going to show you the wrong way to do this site and then the right way. This is the wrong way, and I say the wrong way because I want you to avoid doing this particular mistake. So whenever you create sites, you should use this process of starting with a larger object and cutting smaller objects out of it. So we have a larger terrain object, and we're going to cut this road out of it. So we select the terrain, and then we use the Boolean cut split feature to cut out the road. The Boolean, of course, is found in the compound objects. Compound objects, Boolean, cut split, and we pick operand B and click on that road, and there is our cut and split. Okay, so you should have something similar to this, where you have the edges cut into the terrain that show you where that road object was pushed through the terrain. But it's all still one object. It's all one object, and in order to actually extract the faces or polygons that make up this space on the inside, we have to add the edit mesh or edit poly modifier and grab those polygons. So all you need to do at this point is go to the modify panel and add either an edit mesh or edit poly modifier and go into polygon subobject mode or face subobject mode or even element subobject mode. Okay? And just to make things simple, just go ahead and delete those polygons. We wouldn't normally delete them. We would detach them to another object, but just delete them for now because I want to demonstrate something, and it's a little easier to see when those faces are deleted. So if you go into top view or just look around your scene at where those cuts took place, notice how rough those cuts are. Nothing cut properly. There's a lot of erratic cuts and a lot of curves that were missed. Everything just, nothing looks right. Even the shading of the object looks a little weird at times. So what happened? What went wrong? It wasn't able to subdivide. That the Boolean did not happen properly because we did not have enough vertices, enough polygons in this main object to make the cut. Jacqueline, I'll get to your question in just a second. In order to use the Boolean properly, you have to avoid long skinny faces, and by long skinny faces I mean the edges that you can't see that make up the object that you just cut. You have to avoid long skinny faces, and when you start with nothing more than one polygon with 4 vertices and you try to cut something out, something complex is what we did. When we try to cut something like this out of the road or out of the terrain, it's not going to happen because all these long skinny faces that get created, which you can see if you turn off edges only, all these long skinny faces, Max does not like this. It can't create these. Every one of these lines represents the edge of a face that was created. And so all this stuff was created because we only had 4 vertices that define the outside of the plane. Okay, so that is the wrong way to do it. Now, Jacqueline, you wanted me to repeat the extrude command. That's fine. We have to do it anyway because we're going to do this the proper way now. So I'm going to go back to the edit and select fetch, or you can hit Alt Control F to fetch that file that you had just previously saved. It says about to fetch. Okay, yes, let's fetch this. So we're back here, and all I did for the extrude, Jacqueline, is I added the extrude modifier that you find. You don't see it when you've got a mesh selected. You can only extrude a spline, so I don't see it right now, but that's the extrude modifier right there, and that's what I added to this object. So that's how to deal with that's how you create that object there. Yeah, you have to make sure that this extrusion is large enough that it pushes through the terrain, and that's especially important when you deal with 3D terrain, which we'll look at next. This is a flat surface, so it doesn't have to be that large. Now, to do this properly, we should have a certain number of divisions in this main object here. And since we have a plane, which is a parametric object, since we have a plane that we have a couple settings that we can adjust so easily, we can just add extra vertices, extra polygons by adding extra length and width segments. And so for an object this size, about 20 length and width segments would be more than enough to create the extra geometry that we need to create good cuts. All you're trying to avoid is having a cut where the faces that get created are long and skinny and connected to from vertices at one spot to vertices that are way far away. So if you were to try to cut this curve portion of the road out of this square, it's much easier than doing it with the 4 original polygons that made up this object during the first iteration. Okay, so let's do the exact same thing we did before. Let's use the Boolean cut split, and now with this set of with all these extra divisions in this plane, it will be a piece of cake. So we go to Create, Geometry, Compound Objects, Boolean, Cut Split, pick operand B, and pick that operand. So there's the cut and split faces. It looks exactly the same here, but it's not. It's far more accurate. If we look very closely at the cuts, you will see, if I zoom in really close, you'll see all these cuts are just fine. Every one of them are just fine. And this chiseledness or this jagged edge, whatever you want to call it here, this faceted edge, that's just because I didn't divide that curve more than that. So if I wanted even more accurate curves, I could divide those curves a little bit more accurately there. It looks like I missed a curve when I was trying to find all the curves that I needed to divide. I missed a curve. So that's why it's very important to spend some time investigating your line work to make sure the cut is right. Because right now, fixing this will be a lot more difficult than it would be to just go back to the extrusion, fix the spline within the extruded object, and then do the Boolean cut split again. So I need to add the edit mesh or the edit poly modifier and separate this or detach this as a separate object. This method that I just used is not possible with the Pro Boolean, because what this did that the Pro Boolean could not do is split faces, hence the term Boolean cut split. when I did the Boolean, I selected the cut split option, and that split these faces, which simply meant all the vertices that were previously shared during the cut were then split. So it basically broke the vertices and split them, and you're left with two different elements. Now, if I were to deselect these faces, selecting all these individual polygons would be very difficult, but I could just select the element and just click on this element here, and there you go. I've got this element selected, and I can do anything I want with this. But I want to detach this as a separate object. So I'm going to click the detach button and call this site-road. And I should give it a new color just so I can see the different elements together. I'm sorry? No. I did not detach to an element. When you make the Boolean cut split, you're creating two separate elements. By virtue of splitting faces, you automatically create two separate elements. So the road was one element and the terrain was one element. Had I done a pro Boolean, it would have cut the shape of the road into the terrain, but it would not have split the faces. And if it doesn't split the faces, it won't create separate elements. So the whole entire road and terrain object would have been one element. And another downside to that is if you accidentally deselect the faces that you cut, then you can't reselect them. There's no way to reselect them. Let me just, don't bother following along. Let me just show you this because I really think it's so important. I want to fetch the scene that I had before. I want to increase the number of length and width segments from 1 to 20 and 20. And I'm going to do it the wrong way. I'm going to do it the pro Boolean way. When I select pro Boolean and click start picking and pick that object, notice how it creates this indentation. You can change that very easily by clicking imprint and selecting the road object here as one of the operands and clicking change operation. And that looks like it does the same thing. And it gives you nice good cuts, but it doesn't split the faces. And you'll see that when I add the edit mesh modifier and go to polygon subobject mode or element subobject mode, I can't select these faces on the inside. It split them, but I can't select them. So this is all one element. Because if you look right at where the cut happened, if I go into polygon subobject mode and look right at where the cut happened, it never split those faces. The pro Boolean can't do that. So that is the wrong way to do it. The right way to do it, and I'll demonstrate this one more time, about to fetch, yes, is to, of course, set the correct number of length and width segments, 20 and 20, Boolean cut split, probably one of my favorite features in Max. Pick operand B, click that operand, add either the edit mesh or edit poly modifier, it doesn't matter which, and I can select face, polygon, or edge, face, polygon, or element subobject mode, it doesn't matter which, and detach, call it site-roads, give my terrain a different color, and there we go. Now, let's do sort of the same thing, but with 3D terrain, and you'll see just how easy. Before I do that, let me just mention something about these parking lines. If I wanted to create parking lines for this road, since I was working with Autocad polylines and I imported these Autocad polylines, they were nothing more than polylines with a certain width. They were polylines with a 6-inch width. Notice that they only have 2 vertices. There's only 2 vertices on each of these, and they have a certain width. But when you import a polyline with a width, the width of that polyline translates to a spline with 4 vertices. So that's how easy it is to bring these in. And in order to create these parking lines, it's very simple. Add the edit mesh modifier and just elevate this object, this one singular object, about 1/4 of an inch above the road. So I'm going into the move transform type in, simply right click the move transform type in, and type in 0.25. So the object is 0.25 inches floating right above the road. And now, no matter where I render, I will see a nice, crisp, clean parking line floating right above my road. I won't see it. I won't notice it floating above the road. It won't look like it's floating as long as you turn off shadow casting for that object. If you right-click inside the viewport and select Object Properties, you will be able to turn off the ability for this object to cast shadows. So no matter what, this object will not cast shadows, and it won't look like it's hovering above the road. Okay. Now, hopefully you were able to follow along. You got a question? Cast shadows. Every object has an Object Properties dialog. If you right-click and select Object Properties, you can see Cast Shadows. Okay, let's see. Please redo the detach again. Okay, no problem. I'm not gonna hit you. I'm gonna fetch this one more time and show you really quickly how to do this one more time. Divide this into 20 and 20. Let's do the Boolean. Cut split is selected. Pick operand B. Pick that operand. Now you have to add the edit mesh or edit poly modifier in order to get to the polygons of this model. Edit mesh. Let's pick polygon subobject mode, and under the edit geometry, right next to attach is detach. Select detach. Give it a name. Site-roads. Hit OK. And it looks like it's still part of the same object just because it's got the same color. We'll change the color, and there we go. So hopefully you're able to follow along in that. It says your parking lines. I didn't understand the polyline for the parking lot. My max model shows each parking lot line to have 4 vertices. Yep. Your max model should have, the parking lines of your max model should have 4 vertices. As I was saying, when you import a polyline with a width in AutoCAD, when you take an AutoCAD polyline that has a width of 6 inches and import that into max, that model will translate into a spline with 6 inches. Now, let's do this with a 3D site. Let's fetch this one more time, and let's turn this into a 3D site. So get back to where you are, get back to where I am right now, and instead of 20 by 20, you're going to need something much more than this. If you're going to do a 3D site, and you want this 3D site to be smooth and not be all chiseled and jagged and rough looking, if you want the terrain to be nice and smooth and flowing, you got to do something much higher than this. Let's just set it to 100 by 100. So that'll give us 10,000 polygons. Actually, better yet, let's do 200 by 200. Hopefully everybody can everybody can do that. If you don't think your computer's good enough for something like that, you can always just set it to something lower. But I'm going to use 200 by 200. Okay. Now, add the noise modifier just to quickly create a little bit of relief. The noise modifier, add the noise modifier to your plane to create a little bit of relief. And this file is, this site is not very big. If you add just a couple of feet, it would probably be more than enough. But to really exaggerate this, I'm gonna make this displacement really large, just to exaggerate the effect and the importance of doing what I'm going to show you here. So I'm dragging up on this z-axis to change the height of the noise displacement, and then the scale can be adjusted. The scale can be increased to make the displacement less, to basically take the frequency down of that displacement. The important thing to get right here is to make sure that the road object that you create cuts through the entire development. So in this case, it looks like mine doesn't, so I have to be very careful. I don't want to see something like this where I see the site here where I should see the road. So I'm going to have to add some more extrusion to this road, make the extrusion larger, and push the road down through the extrusion. Doing this process is the exact same for 2D as it is for 3D. Everything I'm doing is the same for 2D and 3D. Anybody have trouble keeping up so far? Okay. So I've got my 3D terrain, and this was just with the noise modifier. It was just a quick way to add a little bit of relief. I got my noise modifier, and I've got my road that's extruded. I do the same thing I've been doing. I add the Boolean cut split, and it might take a few moments longer to make this cut just because it's a more complex object. And if you have any doubts on whether or not it's going to crash your computer, if your computer can handle it, you might want to save this. You might want to do something, but I'm going to save this. I'm going to hold this, actually. I'll just hold this in RAM so I can repeat this if somebody needs me to repeat this. I select hold. I just saved it to RAM, and I can go back to this point if I want to. Pick operand B, click on the operand, and I just cut my road into this object. Okay? Now, I got to do the same thing I did before. I got to go to Edit Mesh, select the polygons, and now I've got this road object, which is really bumpy. And if you were going to try to park your car, in this restaurant, you probably wouldn't have much luck because you'd probably roll into one of these hills or ditches. So, what's the solution? How can you fix this? Anybody have any idea? Anyone that's I'm sorry? I want to ask you, how do you flatten this road out? How do you flatten the road while simultaneously flattening the area around the road? I just want to make the parking lot flat, or very close to flat. Okay. Select all the vertices, you said? Okay. Here's a little trick. Here's a little trick if you want to select all the vertices inside this object. So I've got polygon subobject mode selected, right? This is my element that I've got, and I can detach it if I want. I can do anything I want, but I really don't want to do that right now. I want to select, as Novell said, I want to select all the vertices that make up this object. There's a number of ways I could do it, but the easiest way to do this would be to go to close out of the Edit Mesh modifier and add the Edit Poly modifier. And if you select those same polygons that you had selected, but this time select them in the Edit Poly modifier, the Edit Poly modifier has a really cool tool where you can translate one selection of one type of subobject to another. In other words, unlike the Edit Mesh, when I went from polygon to vertex, it didn't select all these vertices. It selected all the vertices that made up the cut. If I want to select all the vertices that are selected by these polygons, I can hold down Control and click on Vertex. And now all the vertices that are part of the selection that I previously just had, which was the polygon, all of those vertices are selected. But the problem is, if I move up on these vertices, notice that they all move. How do I flatten this road and have the terrain flatten along with it? Remove the noise. Okay, how do I remove noise? Okay, well, let me just show you. I've got all these vertices selected. It doesn't matter whether I have vertices selected or I have polygons selected. All I need to do is use a scale along the z-axis. I can do a select, and I can use this option, select and non-uniform scale, but I don't even really need to do that. I can just leave it on uniform scale, put my cursor over the z-axis, and drag down and flatten my road. But you thought this was how to do it? Well, it's really not completely correct because of the gap now. What do I do about this gap? How do I fix that? Select the what? Select the surrounding landscape. Yes, that's how I do it. How exactly do I do it? With these polygons selected, go to Soft Selection, turn off Soft Selection. Soft Selection is in this Edit Poly modifier. It's also in Edit Mesh. It doesn't matter if I do this in Edit Mesh or Edit Poly. Turn off Soft Selection, and notice when I do that, what it's what I'm telling Max to do is everything within 20 units of the selected polygons that I currently have get partially selected and get affected by whatever I do to these polygons. I can increase this fall off so that it encompasses a larger area, and notice that this fall off distance is increasing as I drag up on this mouse. So now everything within 112.8 units of the selected polygons will be affected. And now when I drag this down, everything flattens out. And if I wanted to be completely flat, all I need to do is apply a non-uniform scale and just right-click the z-axis here. And if I right-click the z-axis, everything flattens. And you don't have to, you probably shouldn't make it 100% flat, but drag it down until it's flat enough. And you can make, you can look at the road and say the road is flat enough, but I want the parking lot to be completely flat. Well, just using the Alt key, hold down Alt and deselect these polygons so that they're not part of the selection anymore, and then completely flatten the parking lot by right-clicking the z-axis over here. So the parking lot should be flat, but maybe the road could still be a little bit bumpy. Okay, does anybody want me to demonstrate that again? Anybody not able to follow along or keep up or at least understand what I'm doing? Do all you guys understand that? Okay, anyone online? Please repeat that, no problem. I'm going to do it fast, but I will repeat it. Let's fetch it. Okay, we got this object fetched, so we got our plain object with a noise modifier on it. We got our, well, actually we had that we had the plain modifier with the noise modifier. We had the plain object with the noise modifier, but I just selected Boolean. Now it's at the point where I pick the operand to subtract or to do the cut split with. So I click on pick operand, click that operand, and now I've got my cut split faces. What do? I add the edit mesh modifier, go to polygon subobject mode, and now I've got my cut split polygons, and I need to increase the effect of those selected polygons. I need to select more than just the road that you currently see selected. That is all done through the soft selection. If you're not already using soft selection, start using it. It's really any type of mesh modeling you use, soft selection is valuable. Some of the things that Alex was doing in his furniture modeling using the freeform and deformation modifier, he could have used soft selection and selected a bunch of vertices and modified a group of vertices in a soft selection mode just to provide that gradual fall-off effect to whatever he's adjusting. So I increase this fall-off to something higher. Let's make a much larger area affected here. Sort of looks like the graph of an earthquake or something. And we can just right-click, scale, apply a non-uniform scale along the z-axis. So I'm clicking and dragging down on this z-axis, and that's pretty much it. And then you can detach your faces. I can then go to detach, mesh, and have two separate objects. And perhaps the best part of this, since this is a road and many roads have curbs or some sort of feature that you would want to apply to the edge of the road, I can do something really cool. This is really cool here. I can isolate, I can isolate the road, select and isolate the road, which I do by pressing Alt-Q. Alt-Q isolates your selection. And then I can use this very cool feature that you only find in the Edit Mesh. It's not in the Edit Poly. And that is within Edge Subobject Mode, you can scroll down to the bottom and select Create Shape from Edges. Select Open Edges, and just the edges on the outside or the perimeter of this object will get selected. So I'm going to undo that and do it again. If I click Select Open Edges, just the edges that are on the outside of the object get selected. I can then create shape from edges, select linear because I want all my vertices to be, I want all my lines, all my segments to be linear, and I don't want any curving, so I'm going to set this to linear. I've never not used linear before. And let's call this Road Curbs Line. And if I look in my Select from Scene dialog box, I have a shape that I can now use as a loft path. And I can loft a profile along this to create some effect. I can loft a curb. I can loft a lot of things. I can even use the spacing tool under the Tools menu, spacing tool right here, to make objects to randomly place objects along the length of this. If I wanted to add a little bit of grass, I can scatter or space out a little bit of grass, patches of grass or whatever, along the length of this object. So that was under the Tools, Align, Spacing tool. So, okay. Okay, Jacqueline, I'm going to unmute your phone for just a second. What part did you say that you wanted me to repeat?
Oh, you know what, you caught it. There was one little thing when you hit Alt-Control and deselected the road.
Okay.
You did something, I thought you said Control to select the parking lot piece.
Yes, yes. Alt-Q isolates the selection. That's, I think, is that what you were talking about, or is there some other part?
No, I know the Alt-Q. It's just when you have the whole piece and you chunk off the road part, you automatically get left with the parking lot, right? And then in order to scale it, do you have to hit a Control or anything like that, or do you just have it selected and then you go for your scale and you push it down?
After you make the cut and split and add the Edit Mesh modifier, you have to add that soft selection. Remember, the soft selection spreads out the effect over an area more than just what you have selected, and then you apply the scale modifier, or not the scale, then you apply the scale transform.
Right. And in the first time that you did it, I don't know if anyone remembers, and I'll shut up if I got this wrong, I thought you said the road maybe wouldn't be perfectly flat, but the parking lot would.
Oh, yeah.
You basically unselected the road.
Oh, yeah.
Deselect. And then from there you said something about holding Control or Alt, or maybe I just made it up in my head, but you're left with the parking lot, correct? And you have to reselect the parking lot, or
so I got to
lot?
I got to this point and applied the scale along the z-axis, right? I got the road as flat as I want, but I want the parking lot flatter. So I hold the Alt button to deselect those faces. Hold the Alt button and then I can flatten the rest of this parking lot the entire amount if I want. And then I can detach this object, and in order to detach the object, the easiest way to detach this object would be to select element, click on this element, and remember this whole object is the element. I can turn off soft selection, select this element, and that's it.
Okay. And then you detach?
Yep, detach. Where's detach?
Down.
Yep, right there. Detach it. And that's it.
Okay. Thank you.
You're welcome. Okay. Since I completely flatten this parking lot, I don't have to worry about having these parking lines. I can just float these parking lines above the parking lot. But had I not flattened this road the entire amount, I would have had to do what I'm going to do now, which is extrude the parking lines and push those down through, let's make this a different color. Push those, and let's make the grass a little bit different color here. Just make everything easier to see. There we go. So I have to push these parking lines down through the road and do the same thing. This is not going to be a difficult thing for Max to do, to cut these parking lines, these thin objects, out of the road. It's the same exact thing I just did. The Boolean, cut, split, pick operand B, click that operand. I just made the cut, add the edit mesh modifier, go to polygon subobject mode. Oops, that, let's see. Why did that not select? Did I miss something? I got the Boolean cut split. Anyone see if I missed something? Convert to editable mesh. Polygon subobject mode. I'm not sure why that didn't cut. That always cuts. It's an easy thing for it to do. I'm not sure. Maybe I didn't have it pushed down far enough. Okay, someone's saying I'm having the same problem. Let me try to do that again one more time. I'm going to. I have never actually had that happen before. Okay, let's do it to the terrain when the terrain is still very rough. Boolean. Oops, wrong object. Let's do a Boolean. Pick operand B, pick the operand, edit mesh. Let's just go ahead and detach this and change the color of this object. Okay, so we got one object that we have to worry about, and we want to select these parking lines. Let's isolate the selection, extrude these. Oh, I know what I did wrong. I think I know. Well, this might be the reason. If you look at this, I think I realized what I just did wrong. It's a good practice to weld all these endpoints of any lines that you bring in, and I'm not sure if I think the problem is one of two things. It's either I didn't weld endpoints, or I've got these lines here that overlap each other, and that can cause problems. So I'm going to do a weld endpoint. I'm going to select all these. I'm going to try to weld, and if it flashes, then I know something welded. Yep, something welded there. And I can, just to be safe, just to make sure that it's not because of these lines that are intersecting the other lines. Max does not like it when lines overlap each other when you do this kind of operation. Let's just remove these. And if this was the cause, it would be a simple matter of going into the AutoCAD, the architectural drawings, and deleting these lines or cleaning them up, making a clean version, and then copying a new set of line work for those particular type of objects. I have a feeling that's what was causing the problem, so I'm just going through and deleting all of those so I don't have any chance of a problem occurring. I need to extrude them, and perhaps one of the reasons why the cut didn't happen is because I made this extrusion so tall, and I don't really need to make it that tall. And just like before when we had the site that only had, oh, that's probably why I didn't seem to push it down very far. So I probably didn't have the parking lines pushed down very far through the road as well. So I need to make sure that they're through the road, and I don't want to make them excessively large, because if I make this parking line really, really super long, it's gonna have to do the same difficult cut that I was doing before, and it's just a good idea not to make this too excessive. So that's good enough right there. That should work. Select the road. Let's collapse this to an editable mesh just to make sure that there's no strange history to this object. Let's purge the history. Create Boolean, pick operand B, pick that operand, and let's see if this cut happened. Polygon subobject mode, and it happened just fine. So the problem was those overlapping lines. Whenever you do a Boolean, and you have lines that are intersecting each other, overlapping, you can create those problems quite easily. But now, even though this is a 3D site, I've got parking lines that perfectly match the contour of my terrain. You're at the part, you got stuck at the part after I welded the endpoints, and then I started to delete those extra splines that were overlapping. You did that too? Well, after you weld the vertices, which I shouldn't have forgotten, you should always weld vertices of lines that you bring in. I deleted the lines that were intersecting each other, like these lines. Remember how these lines were overlapping each other? And this particular symbol didn't work right. So knowing what I know now, if I was going to do this again, before I bring this into AutoCAD, I would quickly trace this object here. I would just go and create a quick rough object of this guy here and just create a quick shape, bring it into Max, and you get the idea. Create this outline, and that would import a lot easier than this green line that overlaps each other. Or I could have taken this line, brought this down to here like that, so that it doesn't overlap each other. Something like that. Anybody have any questions at this point? You extracted the shape of the perimeter, okay? You mean like that you went to edge subobject mode, you extract, okay, good question, or good comment. So you went with the road, let's isolate this road. With this road, you were trying to create a spline to loft around the outer perimeter of this road. So you went to the Edit Mesh modifier, went to Edge Subobject mode. Let's zoom in nice and close here. And you went to the Select Open Edges tool. So that created the Select Open Edges. And unfortunately, I got now open edges in here, which I wouldn't have had if I had done this properly the first time. That's actually going to create a problem because now I've got to delete these. I can't loft a set of non-continuous splines, so I'd have to do this beforehand. But I know what you're getting at. So if I go to Edit Poly and select Boundary or Border, no, same thing. If I go back to Edge Subobject mode, it wouldn't take me but 30 seconds to delete all these. It wouldn't be a problem. But if I select Create Shape from Open Edges, make a linear shape from Open Edges, and then go to that shape, isolate that shape. There's my shape. I can go into Spline Subobject mode, delete all these splines, but, well, yeah, see, I cut the parking lines before making this shape. So, but your question is, what do you do with all these vertices? Because you said that there was too many vertices? Yep, you applied the normalized spline to this, and it rounded your corners. So you added the normalized spline, it rounded the corners. Let's add Vertex Ticks under the display panel. Vertex Ticks. Nothing's you can't get everything for free, so there is some amount of work involved in this. And just remember when Alex was doing his furniture, remember how I can't remember what he was doing, but he showed how like 3 or 4 vertices were, when a turn was made on the furniture, there was like, yeah, he welded. So, you know, what you do is totally dependent on whoops, shouldn't have gone down. I can add, now that I've got a normalized spline modifier, I can collapse this to an editable spline and manipulate individual vertices. So if I'm doing this, I would select that vertex, delete it, select that vertex, you know, position it right there, maybe change the vertex type from smooth to corner. Well, if you have a loft, if you're worried about a gap, your loft is going to cover that gap. So if his point is, if you move this vertice and it doesn't line up with the road object that you created, isn't that a problem? Well, no, it just means that you have to be a little careful in how you position this. So, this is actually rather simple. Just take each one of these vertices like this. It takes a little bit of work, but not much, and you get the idea. It's very simple, very easy to clean up. And I don't think there's really any other way to do this. I really don't even know if there's any other way, and I've never found somebody else that has a different way to do this. So, does anybody have any questions? If not, then we'll take a 10-minute break, and I'm going to unmute your phone, Jacqueline, and see if you have any questions. When we come back, we will look at vegetation and backgrounds in the last hour and a half. So come back in 10 minutes. All right, so let's continue on, and next we're going to talk about vegetation. Let's go into some different scenes with some vegetation. Some of these scenes are borrowed from the intermediate to advanced book that we put out a few years ago, and talks about, and some of the things I'm going to talk about are illustrated in that book. But I want to point out a few things that may not make sense or you may need some clarification on. I'm going to open up a file under 3ds Max 2 07-vegetation. 3ds Max 2 07-vegetation. And this is from our Chapter 10 of the Intermediate to Advanced book, Chapter 10-01. And that's unfortunate. Looks like I haven't mapped the paths correctly on this file, so let's try a different one. Okay, I'm not sure why it didn't map properly or didn't pull those in. Okay, let's try something else. Let's try shrubs. Okay, open up the file called shrubs. We'll start with this one. So there are two categories of vegetation. You have 2D and 3D. 2D would be nothing more than crisscross images, and 3D would be a bunch of vegetation created from a series of faces or polygons. In this demonstration, you see several different iterations of one particular leaf type. I can take any one of these objects and use the scatter command to scatter them around different parts of my terrain, and I can do that very quickly. I can just select any one of these objects. This is all one object. I can select this object and extrude it in order to create a volume of space to which I want to scatter some of these individual polygons. So if I add the extrude modifier, I can make a shape that is going to roughly resemble what it is I'm trying to my volume that I want my shrubs to be placed in. And if I want to be if I want to do this really smart, if I want to be really precise, and I want to remove any possibility of somebody seeing this hard turn or hard corner or sharp edge to this set of shrubs that I'm going to create when I scatter these leaves, I can use some of the edit poly tools that Alex was mentioning during his exercise. I can go into edge subobject mode, for example, and I can select the loop command, or not the loop command, I'm sorry, the ring command. Let's see, I am not an expert at this, so this might take me a second to do. I can select an individual edge, and I can go into front view, select all the edges from front view. I have to make sure I'm in a window mode, not crossing mode, because if I'm in crossing mode, I'm going to select all the edges that I intersect, but I only want to select these top edges. And with these edges selected, I can use some chamfering tools or fillet tools or some other tools inside the edit poly to create a softer edge to this vegetation object. And I can do that again and again and so on, just to add a little bit of curvature to this. And get something that looks a little bit better when I start to apply the scatter command. And I can even use tools like Mesh Smooth to smooth out even more. And this object, it doesn't matter how ugly this object looks, it's going to be deleted, and the only thing that I'm going to care about is the rough shape that the vegetation ends up taking, the rough form that the vegetation ends up taking. Or let's back out of this. Let's get rid of that edit poly modifier and maybe try a subdivide command. So we can subdivide this geometry and then apply the Mesh Smooth modifier to smooth it a different way. And again, it doesn't matter how ugly this looks. I can add some iterations to smooth it out a little bit more. But I'm just trying to make some type of shape that I can scatter and not have a rough chiseled look to this geometry. Let me try one other thing. I can try to do a subdivide. Let's do a subdivide, and let's use a pretty small size for my maximum size amount. The subdivide modifier sets a maximum size that you are going to allow for this object. Let's use the Turbo Smooth modifier. Turbo Smooth modifier gives me a little bit better results. All right, now I can apply some scatter to this. I can pick any one of these objects, any one of these leaves. For example, this particular leaf right here, this is a sea grape. I can apply this, and if I want to have more accurate shadows, I can use a more round leaf. The more round my leaf is, the more accurate the shadows will be. Okay. Let's use this one triangle here and scatter it about this distribution object. So we need to select the triangle, go to Compound Objects, and use the scatter command to scatter this along a distribution object that you select. So I need to pick the distribution object and pick on that object. And as soon as I do, I see a duplicate distribution object created. And for whatever reason, they decided to have this duplicate object that you need to then turn off. So I need to hide distribution object under the display rollout, hide distribution object to hide that. And then, of course, I need to delete this original object that I don't need to see anymore. And all I see is one little polygon or one little face down here, but the object is still a scatter object. And I can type in a much larger set of duplicates now. I can type in something like 10,000 duplicates, and I will see these faces created properly. I can see these faces created properly, and let's do more than 10,000. Let's do 30,000. 30,000 for the faces. And if I want to have these faces scattered about a volume, I can select volume, and that allows me to put the faces within the volume of space rather than just along the outer edge of the space. When I have this set to even, all the faces are set to wrap around the outside of my object. One thing with the volume, though, is you have to be careful. For whatever reason, it takes a long time for the volume for that calculation to take effect. The even and area options don't take as long. The area option probably would have been a better option because it doesn't take a long time to do, and it fills inside your object as well. The volume has this downside where it just takes a long time. It looks the best, but it takes a long time for this operation to fill in. So that's a quick, easy way to create some shrubs. Now, let's look at some trees here. In this image, you see some pretty nice, pretty realistic trees. These trees are only going to look as good as the materials and the lighting that you apply to them. And in this case, these trees were created with Onyx Trees. Onyx Trees is a really nice program that runs. It's a plugin that can run inside Max, but it has some modeling programs that run outside. So you model your trees outside of Max, and you import them into Max using this Onyx Storm plugin. All these trees were created with Onyx Trees. Images from galleries that have different trees created with Onyx Storm. Here's another image everything here, all the vegetation, all the shrubs were created with Onyx Storm. It's a good idea to determine what type of shrubs you can get away with using just a scatter command and which type of shrubs you actually need to spend some time to create and look properly. So all of these shrubs were created with Onyx Storm, and it probably could have been created just fine with the scatter command that we've been using. And the file that I'm getting into right now is 2D trees animation. And this animation shows that as I move around the scene, I put some thought into the exact placement of this vegetation, and I wanted the vegetation to just show enough in the bottom of the screen at some points that you couldn't see the full tree. You just had some effect of the tree being down here and not see enough of it to realize that it is a 2D tree. But because I moved around this scene like this and I see this is a full 360-degree turn, I wanted to create some vegetation here that is in the background that in the foreground I would not see too close up. In other words, rendering trees like this 2D in the background is fine, but when you start to get around the scene and see it close up, it wouldn't look realistic. So I always take some time to place the trees in my scene so that they are in a way that when I'm changing views, I don't see the trees in a way that allows me to see that they're not as realistic. And I could have placed 3D trees in the scene. I could have made all of this vegetation 3D, but you have to pick your fights wisely, and all of this vegetation is strictly two-dimensional. It's all crisscross, and I have what I like to call fake shadows at the base of each one of these trees, and these fake shadows are nothing more than images placed on a plane. If I can find the right image. Okay, let's load it up. Nothing more than a black and white image loaded up into the opacity channel. This image loaded into the opacity channel, which you can create by doing a rendering in top view and then using the alpha channel to create this black and white image. So you can render a three-dimensional tree in top view, render it on an open background so that when you click on the alpha channel, you see exactly this, a black and white version, and then even render it with a little bit of a blur, once you bring it into your material editor, apply a little bit of a blur so that it blurs the outline of that tree. I can increase this blur and make it blurrier and blurrier to help lose the definition of this. If I set it to 0, it looks like a much more, the shadow looks much harsher. So you can simulate softer shadows by doing this. It wouldn't look realistic if you had nice hard shadows everywhere else and soft shadows on your shadows here. And vice versa, it wouldn't look good if these were too sharp and everywhere else the shadows were soft. Okay. What makes two-dimensional trees look realistic is that you illuminate them the same amount from all directions. These are crisscross trees, so you have to make sure that you don't let them cast shadows on themselves. So you need to go to the Object Properties Rollout and tell them to not cast or receive shadows. And instead, you need to illuminate them with a series of direct lights positioned around the scene, pointed inward. I have in this scene 4 direct instance lights. I select one of the lights, and you can see that they're instance because it says it's bold up here. Anytime you see bold in the modifier stack, it indicates that it is a instance light. And these 4 lights are set to include only these trees. Only include these trees, nothing else. Notice also around the trying to zoom out and then zoom in. I got an object selected, so it's making it hard to navigate around the scene. Notice around the scene also on the outer edges of what I see in the camera, I have scattered a bunch of triangles or a bunch of faces, just scattered a bunch of faces with no texture on it. It's just a green set of geometry. It's just something to rough up the ground and make it look like it's not a carpet. You don't want to have a vast open expanse of terrain that is just, you know, solid and flat, and as you go off into a distance, it looks like carpet. You got to break up, just like you break up the horizon, you need to break up the ground and prevent it from looking like a carpet. Yes, you have a question? Did I make the leaves triangles so that they would have one face? Yes, absolutely. Anytime you can do something like that to cut down the amount of geometry in your scene, the better off you would be. There's absolutely no benefit of making these triangles more than, or I keep saying triangles, faces. There's no benefit of making these objects, these individual elements, more than just a face. And the objects on which the shadows, the fake shadows were created, those are simple polygons with two faces. You know, a polygon can have as many faces as you want, but the least amount it can have is one face. In this case, I have two faces making up this object, two faces, one polygon. If I wanted to, I alluded to it before, if I wanted to have trees positioned along a road or line up some trees very quickly, there is the spacing tool available, and there's a few different ways to use it. In fact, sometimes when I'm placing vegetation, whether it is a 2D tree or 3D tree somewhere, what I'll do to quickly create an area that I want to scatter some trees in, I will just create a line, and I will just, if I want a particular area that I want to start to place some trees, what I can do, and let me go ahead and reset this scene to show you. If I want to create an area of trees, I can certainly create a surface and scatter trees on that surface, but I can also take a line and I can just do this and just find an area that I want to add some trees, and the more that I want trees in a certain area, I can spend more time, you know, with my line doing this and just add a lot of lines. And then if I want lesser trees in some other area, I'll just add just a few lines like that. So I can take the spacing tool and using a teapot to simulate trees. Using the spacing tool, I can select that line. Let's turn this into a darker line. Go to Tools, Align, Spacing Tool. This menu opens up where I can pick a path and specify how the objects are divided on that path. I can pick, actually I got to select the teapot first. I always do is I select the wrong object first. Select the teapot, pick path, and then select that path, and increase the number of objects. I can type in like 200 here, and I will have more objects tend to group in that area. And that's a nice, that is a nice way to quickly add some vegetation and add more in one particular area. And then you can use something like some of the move tools to just quickly make it look like it's not, you know, on a line or something like that. In conjunction with the vegetation, there is what I call a 3D background rig that I include in most of my scenes, and it's found under the 3ds Max-0308 backgrounds folder. and this contains a typical background rig. There's two files in here, typical background rig and 3ds typical site objects. If you load that typical 3ds site objects, you will see not only the background rig, but some vegetation on the horizon. I think it's very important that you break up the horizon with a set of an image of something that you want to map on a cylinder, and have a bunch of trees or something on the perimeter like this that breaks up that horizon even more. So this is my typical background rig, and it consists of a dome, two cylinders, one large cylinder that you can see right here, a smaller cylinder that you can see right here, and it doesn't look like a cylinder. It is a cylinder, but you're only seeing one side of it. And the purpose of using this is so that we have a self-contained, we have a rig that we can place around our scene so that we never see the background, we never see the horizon, and it's a self-contained scene. So using the same approach, we just carve out an opening around which we can carve out an opening that we can put our scene around, or put our scene within, and the three objects that represent the background consist of the two cylinders and the large dome. We have one cylinder that is seen through the camera, and that cylinder is only visible to the camera. It's not visible to reflections. So if I were to right-click, select Object Properties, notice that it says visible to camera, not visible to reflection or refraction. That means that I will see through my camera this background image, but I will not see it in reflections. And it also means that the dome that I have selected, the dome object in the scene, is not visible to the camera, but is visible to reflections. If I select the dome, right-click, Object Properties, it is visible to reflection and refraction, not visible to camera. So you're not going to see this dome directly with the camera. You would only see it in reflections on other objects. And the reason why is when you're looking through a camera, as long as you don't look too high up in the sky, I'm going to select my camera target and move it higher up in the sky. As long as I don't look too high in the sky, I'm not going to see the top of that cylinder. But the minute I start looking down at objects like lakes or pool water or the reflections off a car, I have a better chance of seeing the top of that cylinder. I could always move the top of the cylinder up or down a little bit, but I don't want to I don't want to distort this image too much. And as long as I don't look too far up, I'll be fine. And I can look a full 360 degrees around my scene. I can look anywhere and see that background. But I have that dome in the scene so that I don't have to worry about seeing the top of the cylinder in reflections. So this dome is set to be visible only to the reflections and not the camera. It's also very important that you turn off these objects from GI. You do not let them be processed by the GI. I'm using V-Ray in this scene. If I go to V-Ray Properties, notice that the Generate and Receive GI is turned off. You have to make these objects not cast global illumination. They will paint your scene with too much global illumination. I notice we have a question. Sorry I didn't see your question sooner if your question's been up. What about this? About what size is that good for? I'm going to unmute your microphone. Let's see. Toby, what was your question about?
I mean, obviously, if you have small scene and you have a very big dome, you're going to have to cover a lot of ground around your small scene.
Right.
And, the other way around, when you have a very large scene, how much bigger or how much larger can you scale this dome up to?
Okay. I'll go ahead and...
before it gets too pixelated to where...
Yeah, the question is how far can we make this scene? How large can we scale up this scene? Well, let me say something first about some of these objects in here. This folder is called 3ds Typical Site Objects. The reason why the scene is set up like this is most of our scenes, at least exterior scenes, have mulch. I'm going to go ahead and mute your microphone. Most of our scenes have mulch, a road object, grass object, and concrete. You can't see it, but there's a concrete material on this object. So to make these objects look good, especially close up, they should have different elements. For example, the grass has some displacement, and it's got two different maps because if you look in the material editor, it is a blend material. Well, you can't see it because V-Ray, I don't have the V-Ray dongle in this machine, but there is V-Ray on this object, and I use two different submaterials, or I'm sorry, I use a V-Ray blend material, which is comprised of two different materials, and each one of these has a different map channel applied. So this first UVW map is set to channel 1, the second UVW map is set to channel 2, so I can give both of them different mapping coordinates, and I can use a V-Ray displacement modifier to create some displacement of this grass and actually make it look like there's blades of grass. And in order to do this, it's a lot easier. It takes a little bit of time to set this up. It takes a few minutes. So instead of having to duplicate this every time I need grass in my scene, all I do is I throw my background rig on into my scene that I need a background for. But since I also have this object set up already, I can just select these three modifiers, copy and paste them into another object. So I can take these three modifiers, copy them, select another object, and right-click paste. I'm not going to do it here, but that's what I can do. And I have another object over here that has unique UVW mapping. It's got the displacement modifier. It's also got the material on it. So it's really simple to copy the modifiers and to drag and drop from the material editor into different objects. So that's why these objects were in here, and I recommend setting up a background rig like this where you can have elements like mulch, grass, road, all quickly brought into a scene so you can quickly copy their attributes. So, but your question is why or how, what can you do with this scene if your dome is not big enough to encompass the rest of your scene? Well, the easiest thing to do would be to just select all the objects in the scene. I'm going to delete this camera. I don't need the camera. And I can delete all these objects. I can turn the lights off. I really probably shouldn't have these lights off right now. I can turn the lights off or hide the lights by within the display panel just clicking on these lights, and that removes them from our view. They're still in the scene. They're still there. They're still going to work. But now I can select all these objects. I can't just scale them up right now. Because I do that, I run the risk of having some some erratic results. It's always best to group an object first, scale it up however large you need it, and take note of the home grid to make sure that when you scale it up, you don't lose sight of that home grid and all of a sudden make your dome not work for the environment. So you scale it up however much you need it. You might need to move up your dome so it matches the real ground. And then I can turn my lights back on and then just reposition the lights and scale the lights up so that they encompass the entire scene. And these should be instance lights, and I can't just scale up these lights. I have to increase the hotspot and fall off so they all update. And now when I select on the others, it didn't look like they updated only because their gizmo wasn't shown. But if I turn on the show cone for all these objects, notice that when I change one, they all change. So that was these objects were just here to hit the vegetation in the scene and illuminate them properly. Okay. So this would be a proper working background dome or background rig. Somebody's asking, are you not running the risk that your background will appear pixelated if you just scale it up? No, there's no risk in the background appearing pixelated because there is no scale to this. I can scale this as large as I want. I can make these objects as large as I want. If the scene that I'm building is large enough to fill this, then there will be no risk of having that happen, because the larger I make this background, the farther away that the more I make this background, the farther away it's going to appear when I put a camera in the scene. Because now when I put a camera in the scene, that camera is going to be a farther distance away from this object. The only thing that matters is how much of the viewport the background takes up in my scene. If the viewport only takes up, if the image in the viewport only takes up so many pixels, then it doesn't matter how large that background is. What matters is how that background is scaled on these objects. If I go to ungroup this and look at this, cylinder, let's isolate the cylinder, I can bring this, well, this is a V-Ray material again, so I can't analyze this too well. It's looking for the V-Ray dongle. It's not on the computer right now, but I can go into this material, look at this image. This image is what's wrapped around the cylinder. It's important to have it's important to have an image on your cylinder that's at least 4,000 to 5,000 pixels wide, because when you're looking at a camera, most camera views only have about a 45-degree field of view. And if you have a 45-degree field of view, that is only 1/8 of the horizon that you're seeing. It's only 1/8 of 360 degrees. So the typical view is only going to see about this much of the environment map. So if you're rendering an image that is 3,000 pixels wide and the background image that you're rendering is only 4,000 pixels wide, then something's not going to work, because if you're seeing 3,000 pixels worth in just 45 degrees, then you're going to have a blurred image. But for something like 640 by 480 or standard definition, that's not a problem. If the larger your final product, the larger you're rendering, the more you have to, the larger your background image, or the more you have to tile that image. I could set the tiling to 2 on this and have 2 iterations of this background, and as long as the seam is, as long as the image is tileable, you won't see that seam very well. So I've essentially turned by doing this, I've essentially turned my 4,000 pixel image into a 8,000 pixel image, because I've just repeated it over the span or the perimeter of this background. Anybody have any questions so far about backgrounds? Okay. Whether or not you use V-Ray or Mental Ray, there are at your fingertips some really great tools under the Render Scene dialog box, specifically Render Elements. If you don't know anything about Render Elements, it's just an area of the Render Setup dialog box that lets you render separate passes of the same scene automatically and behind the scenes. So instead of rendering just the raw image, you can add different elements. For example, I use V-Ray, so I can add a V-Ray object ID pass. And if I render a V-Ray object ID pass, I want to open up this scene again, I can render my raw rendered image, but behind the scenes at the same time another image is being rendered, and that image for the V-Ray object ID pass will be an image that has a different color for every unique object. And the reason why that's great is if I decide that I want to do something with this background and change it out at some point, if I have an object ID pass created, everywhere that you see the sky will be one color, everywhere that you see all these trees will be another color. Every object will be its own unique color. So I can go into Photoshop or compositing and create a selection set from just the V-Ray object.ID pass, create a selection set, and then superimpose something into that selection set. I can put my own background for a still or for an animation. Anybody have any questions so far? I think it's very, very important to avoid using environments inside the environment effects dialog box. Right here you see a V-Ray sky because this scene was created with V-Ray, and there's a V-Ray sky map which you can't see because of this background rig, but it is in there. I really, really discourage anyone from using this environment map for anything other than something like the V-Ray sky or some gradient that you can apply. I discourage you from placing any type of image in here, even for a still rendering, but especially for an animation, because it's so hard to map to the environment map. First of all, the environment map is a spherical image, right? It's a dome. It's this virtual hemisphere that's surrounding your scene. So if you try to place a flat image like the image you saw a minute ago with in this scene, the panorama image. This image that is mapped onto the cylinder is a nice looking background, but it is a linear image. It is a rectangular image. It's just a normal image. If you place a normal looking image like this on the environment map, it's not going to look right. It's going to look ridiculous because this environment map is this virtual hemisphere surrounding your scene that expects a spherical map. You at least, if you do use this, you at least have to use a spherical map. And by spherical map, I mean the kind of map you see on my background dome. So if I go out of here, let's select the background dome. And let's look at this image. This is a spherical map, meaning that if you apply this to a sphere, it won't be very distorted because this was created from a spherical camera, and the spherical camera somehow knows how to map that entire 360 degrees of view onto a flat surface, onto a flat image, and then when you wrap it back around a spherical image, the result will be minimal distortion. Even if that wasn't the case, even if you could place a regular image in the environment map, it still becomes very hard to map this. It becomes very hard to see the background on the environment effects dialog box. Somebody's got a question. Okay, that was a comment, not a question. If I go to the Views menu and open up the viewport background, which I can also do by hitting Alt-B, Alt-B opens up the the viewport background. I can see a background in my viewport, and I can use that to help map whatever I decide to put in the environment effects dialog box. If you have to use something in the environment map, I would suggest using a spherical map, but the problem is it's whatever you see in here, whatever you see right here, you don't. You have to see it through the background image. So I'm just going to demonstrate something. I'm going to load that spherical map into this environment map. So I'm going to go into. I want to add a bitmap to this environment map, and I want to find that same. I want to find that same image. This 360 panorama image, and notice the size of this. This is 9,000 pixels by 2250. You need to have something very large like this to have a decent looking background. So I've just put this environment map in my background. I want to hit Alt-B to open my viewport background, and I want to display the background. If I enable display background, I will then see that background, and I have to also hit Use Environment and select OK. Now there's my background. So depending on where I look, I'm going to have some strange, this just looks strange. So my first thought is, oh my gosh, how am I going to map this? Well, I have to bring this map into the material editor if I want to do any mapping of any kind. So I need to bring this panorama into the diffuse color channel of, well, actually it doesn't need to be in diffuse color channel, it can be an empty sample slot. I can drag any map into an empty sample slot, and now I need, this is all I have to work with to map this. Just the tiling features here and the offset features, and what I see here is the only thing that's going to allow me to control how this object appears. So if I wanted to use this as a background, I literally have to start using things like the offset and try to get this map positioned so that it lines up with my horizon, but my horizon is going to change. You know, depending on how I'm looking, my horizon is going to be completely different with every view change I make. And then I have to worry about, well, I got to tile this because it's too it doesn't look. I might have to tile this if it looks too blurred. I can't say if it looks too blurred right now because what I see here is not really what I'm going to render. I have to render with, it's going to try to render with V-Ray, which it can't. But I can't assume that what I see in the viewport is going to be the kind of quality I'm going to get when I render. I need to be able to render in order to see the kind of quality I'm going to get. The point is, this is a horrible way, this is a very difficult way to do mapping. If you're going to use this sort of approach, I just recommend at least rendering to elements. Doing away with this environment effects dialog box and use the render scene dialog box to use render elements and use an object ID pass to be able to create this background plate so that you can assign a certain material to a selection set that you create from Object ID Pass. So you load, and Object ID Pass is available with Mental Ray. It's even available with Scanline, except with Scanline it's called a material ID. So not only can you assign objects individual colors during the rendering process, you can assign different objects or different parts of the same object material IDs. You know, if I create a wall, I can assign a different material ID to each part of that wall. Well, when I render with the material ID pass, I will see an image that is nothing more than a bunch of different colors, and each of those colors will be assigned according to the object's material ID. Okay, this discussion on vegetation and backgrounds is pretty quick, and I want to reset this and sort of open it up to any questions and any discussion that you guys might have on any subject, anything that we've talked about today. Here's today's agenda. How would I map onyx trees well? Good question. Right. Okay, good question. And an onyx tree, when you bring it in, does not have very good materials applied to it. That much I will say. As realistic as trees are, the materials are not really suitable. If you do things right, if you do things smart, you're going to create some materials that work on multiple trees. So, for example, if I create a palm tree, like you've seen in some of the images, that material I can bring into and apply to another type of tree, and as long as I set up my material IDs properly, I can avoid having to recreate materials and redo a lot of the same work. So let me just show you something here. I'm gonna use this AEC extended to create a foliage, and this is a really horrible area of Max that I can't believe is still around. But let me show you a couple tricks to do some pretty nice vegetation or some pretty nice materials to vegetation. So I want to load this material up into the material editor, and I'm going to use the eyedropper to do it. And I think it's looking for V-Ray still, so I'm not sure why V-Ray is still the active render engine, but I will disable it right now. I think tomorrow when I do this, I'll just put the V-Ray dongle in, so even when I am not trying to show something in V-Ray, it'll come up. Okay, so I have this ugly looking tree and a material on it, but what I can show is something that you can do, to something you probably should do to all your vegetation to get some more realism out of it, and that is manipulate the vertices, manipulate the vertex color of these trees. Even if you have a material on your tree, even if you place the image of a leaf on a tree, you can still change the vertex color to create some sort of blend to this. So let me just demonstrate this for a minute. If I turn this tree into an edit mesh, I can figure out which elements have which material IDs. So I just went and added the edit mesh modifier, and I can use this material section down here to select by IDs. So if I type in 1 and select all the IDs with ID number 1, that's the trunk. I type in 2, hit select ID. I see that I have all the branches selected. Type in 3, and I'm looking for the leaves, and there are the leaves right there. So the material ID, or the sub-material that I'm looking for, are fronds 1. So if I click on fronds 1, I see that there's a standard material applied, nothing special, but I can apply a vertex color to this material. If I was doing this right, I would create some sort of blend material where I have a base material and then a vertex color map on a base material which could have an image, and then another material that has vertex color applied to the diffuse color channel. Let me show you what I'm talking about. So every vertex on every object has a color. If I go to vertex sub-object mode, scroll in really close to one of these vertices, let's pick a vertex that we can see properly. All right, that vertex right there. If I scroll down, I can see a vertex color assigned to this. I can change that color to whatever I want. I can change this to purple. And I don't see that change in here because I have to have a vertex color map assigned in order to see it. If I place a vertex color map in the diffuse color channel and override this green, I will see the results of this color that I've applied to this vertex. So I'm going to select vertex map or vertex color. So I've just assigned a vertex color, and that vertex color is in the diffuse color channel. And I want to go back to this vertex, scroll down. Okay, let's try this again. Select a vertex. That vertex has a color. And I'm trying to figure out why I'm not seeing that color update. Let's try with the Edit Poly modifier. I'm not sure why this color is not updating. I've got to be missing a step that I'm not seeing right now. Well, I'm going to have to look at that tonight and show that tomorrow. I'm not sure why that's not updating. Anybody else have any other questions? Somebody is asking, so do you import your scenes into your background rig, thus you create your scene with all its material and lighting settings independently and then combine it with the rig settings? No, I don't import scenes into the background rig. I import the background rig into the scenes. When you import a background rig, the only thing that you have to do to the scene that you import into is make the light that serves as your sun not affect the background rig. So if you had your scene with a light, let's just say you had a standard target light, and you had your scene shining down, and you import your background rig, you have to set your light to exclude the objects that you bring in with that background rig. So you have to set that light to exclude those objects. The background rig has an omni light that illuminates the background, and that omni light is set to include only the background rig. So when you import it or merge it into your scene, it won't affect any of your scene objects. So you always merge the background into your scene, not the scene into your background. Do you have a question? Do you do the same thing with a daylight system? What do you mean? Right. If you have a daylight system, which is found under the systems, that daylight system consists of a sunlight and a skylight. If you go to the Modify panel, I see a V-Ray sun, standard sun, mental ray, IES sun. Doesn't matter what I have in here. I can have an IES sun, but I need to set it to exclude right here the background rig. So my background rig objects would be showing up here, and I just move them over to the right-hand side so they are excluded. Okay, somebody's asking what is a dongle. The V-Ray is a program that you purchase, and it's a USB drive basically that fits into your computer. So when you activate V-Ray, it runs. And I have an educational license on this particular computer, and I have an educational dongle and a commercial dongle, and I have not been able to find my educational dongle, so that's why I can't run this commercial version or this educational version of V-Ray. Tomorrow we are going to look at some advanced material creation, and we're going to cover some cool stuff that I think you'll really like. There's a term called pelt mapping, which is, if you can imagine, I make reference to this practice of skinning animals. If you had to skin an animal, how would you do it? That would be the same way that you would unwrap an object. So if you have an animal and you try to skin it, you would have to split it down the torso, down the legs, and you would just pull the skin off, and you'd have something that looks like a bear rug. Well, those seams have to be specified inside Max for whatever object that you're trying to create, and that process of splitting, creating seams, and designating where you unwrap an object is pelt mapping. And if you can imagine a bear rug, imagine taking a bear rug and photoshopping it and then applying that bear rug back on top onto the bear. So you skin a bear, let's just say spray paint the bear rug, and then you apply that bear skin back to the bear, and it's wrapped up the same way it was when you unwrapped it. So that's the process of unwrap UVW, and it uses a modifier called or a technique called pelt mapping. So we'll look at the unwrap UVW. We'll look at some cool little material creation techniques. I'll make sure I have the V-Ray dongle so we can look at some scenes that have some pretty nice materials and illumination already set. We'll look at cameras and some advanced animation techniques. Look at system resource management, how to really get the most out of your scenes and how to streamline your objects. More than just what we've done today. We've seen how good 2D modeling creates good, efficient models, but that's not enough in some cases, and knowing how to handle all the different types of objects is important to reducing the amount of RAM that you consume. And we'll look at all the possible modifiers you would ever want to look at. We'll look at render elements, and I'll have to in some cases show some V-Ray scenes since V-Ray is the render engine I use, and V-Ray comes with its own render elements. Mental Ray comes with its own render elements, but it's the process that you'll learn. So, no, we don't cover. I'm not covering Mental Ray. There's I don't use V-Ray. I don't use Mental Ray, so I don't cover Mental Ray in this class. Do you use Mental Ray? Okay. Okay, somebody's asking what you're not covering Mental Ray. What do you mean by advanced lighting techniques? There's a lot of information there's a lot of approaches for illuminating scenes and preparing scenes for advanced lighting. The process of illuminating a scene is very similar in regardless of what render engine you use. As an example, in V-Ray, because that's the render engine I use, there is when you're creating an animation, you have to do sampling. When you use GI, you have to do sampling. That sampling is conducted in a certain way, and how you illuminate your scene is dependent on, or how long it takes to create the GI for your scene is dependent on a lot of things. For example, if your camera moves fast and you constantly update your scene and see different surfaces, you're going to have to sample at a faster rate. So by changing the way that you move your cameras around your scene, that can speed up the rendering process. How you position lights in your scene can affect the render times. When you create interior scenes, you want to throw fill lights into your scene to spread out the light and fill your rooms with enough illumination so you can avoid the common problems of noise. So the stuff we'll look at tomorrow is different techniques to illuminate scenes, and there's a lot of lighting techniques that use some render elements to enhance whatever it is you produce, whether you produce it with Mental Ray or V-Ray. Anybody else have any questions? Anything we covered today? Modeling, scene preparation, site elements. Yep. Okay, there was a file under the sites folder, and it was called rock, and pretty simple. It's are you asking how to make the rock or how to put the material on the rock? Well, yep. Okay. Well, I can't tell you how this one was done. I don't know, because I can't reverse engineer if I don't have the mapping coordinates applied in here. But I can unwrap this, which we'll look at tomorrow. I can add the UVW, the unwrap UVW, and there are the seams that we will create right there. These are the seams. So that when I spread this out, I can go into Photoshop. I can paint it however I want, but this is not really that complex of an object. I mean, I could probably get away with, in this case, UVW mapping, just a simple UVW map modifier. You can actually see right there a seam between the edge of one map and another. Now, from a distance, this far away, you would never see that. You'd have to get pretty close to see this. So if you were really worried about this, what you could start with would be, let's load this material up into the material editor. And this is using a V-Ray material again, so I can't actually see this. I really have to, some of these scenes, I really have to be using the V-Ray dongle to see this. But you could start with a sphere, apply a map to it, and distort that. And the map may look a little bit distorted, but you at least won't have the seams that you see right here along this rock edge, along the different faces of this rock. But I believe this was just using box modeling or using box mapping. I don't think it was anything too specific. Will we be able to ask questions tomorrow about today? Yes. If you have any questions tomorrow, bring the questions and we will address them. We will be broadcasting at 7:45. It just means that the webinar will start showing up at 7:45. We won't go live until 8 o'clock Eastern time. So if nobody has any additional questions, we'll end the day here. And I thank you for watching, and we will be back at 8 a.m. Eastern time tomorrow.